resilient hill roads. Today's workshop brings together leading experts from government, academia, and industry to address one of the most critical challenges in infrastructure development across hilly regions, ensuring safe, sustainable, and resilient road connectivity. May I now invite on stage Shri Sudeep Chaudhary, ADG North and Quality Moth, to kindly set the context for today's workshop and formally initiate the proceedings. Can we all please welcome him on stage?
A very good morning to all the delegates, participants. This workshop has been actually long overdue, and it was basically being very persistently followed up by none other than our Honorable Minister himself. He had tasked us about a year back that get the best industries onboarded, academia, and the best practices that are being followed worldwide, and come out with something tangible. So, to put it in a nutshell, today's workshop basically is a culmination of a collaborative effort and the soul searching involving various stakeholders, academia. And we have been working actually for past nearly 9 months. We have been very cohesively interacting with the industry, the technological solution providers, trying to understand the technology in its nuances so that we can make the ecosystem more robust. There has been many policy actually interventions and initiatives over the past 3-4 years. If we speak of the rockfall mitigation, then disaster resilient road construction in high Himalayan regions. So the domain knowledge that we have is very, cloistered sort of a knowledge. So the idea is basically to have a wider dissemination, have the industry experts onboarded, and try to understand where we are going wrong and what are the right perspectives that we should be basically looking into. All of us are mostly here civil engineers and expertise in other domain areas, but this is a niche field where the understanding is very limited, Because I myself, I have been going through this process for last 9 months and very actively interacting with the experts, and I have no hesitation very candidly to tell before you that even at this stage also, I think I have got many things to learn. Industry has been very forthcoming, and not only that, to put it in a lighter vein, at times I had been telling industry that, okay, we'll just put you all in a room, close the door from behind, and then you bash out each other's brain and give me a solution. But industry has been very forthcoming. The main challenge that is basically confronting us is how to, at the same time not compromising the quality, onboard all the best practices, and also ensure that whatever policy initiatives we take, those are not monopolistic. So I'll not waste much time. Our expectation from the workshop is basically to have something very, tangible, very simple to understand, so that an average engineer at site also knows what are the do's and don'ts, what are the checks and balances, because those are missing now. As we proceed along the day, so we'll come to know what are the main challenges that those are confronting us, where things are going wrong, where we should basically focus our attention to. With that, I think I should invite the first speaker, Mr. Jitin Mukherjee, to put forth the kind of ecosystem and the best practices, documentation, etc. Those are there on which we need to basically have some more tacit understanding. Mr. Mukherjee, thanks.
Where will the presentation show? नहीं. Okay, good. Thank you, Sudeep ji. Good morning, everyone. And thank you, first of all, the entire ministry, all the departments, NHI, NHI, DCL, BRO, and all the people, the consultants, the OEMs, and the contractors who are there. I cannot thank you enough because you took so much time out of your life to be here and learn about this fact, what what we are doing here, how we can learn from our practices, how we can improve and progress. So the fact that we are sitting here today, it only confirms the fact that there are areas which need to be looked into, and very maturely we need to advance forward. So today I am just going to begin with one fact that today I am not OEM, I am not a supplier, today I am not an expert. Today I am just one of you, and today we are one. We are going to discuss matters in a unified way so that we can learn from each other and the implementation should be much smoother. So we can begin with this. I'll try to begin with this on a very humorous point. So everybody's attention is there. So let's assume we have a car, and we don't know what car is this. If it's European or Indian, we don't know that. And we have the technical specifications of it. But one thing we know that it's been tested. It's been tested by a competent agency. We have a safety rating in place. Now imagine you want to plan a road trip with your family up hills. And on one hand, you have this thing, but you don't know what power you need. The road is very steep. You want to go to Leh Ladakh, and you need a very good specifications of the car, room and power and everything, the efficiency and the torque. But but you don't know how do you calculate it. For that thing, you have a code in place. There is somebody out there who is going to calculate it for you. Who is going to calculate it for you? What car is suitable for you under what condition? So So that is where a code comes in, a design comes in. A design's job is to establish and understand the forces that are working against you. It could be gravity, it could be friction, but that is there in the technical code. It helps you with the design. So once you have a product in hand, now it's important to check the safety. Who has tested it for safety? Who has tested it for the parameters it is showing? Is it reliable? It is credible? So that is where the gap lies. Today, the context of this car example is where you have a product in hand according to the need in real world. Somebody has designed it for you, but you do not know if it will perform in real world. And has it been tested by something which is credible? So there is another car. Let's call it an inspired replica. So it promises you the same thing. The only thing is there that it's not tested, or nobody can guarantee the performance parameters. So how will you go about it? I am sure that none of you will put your family into car B because it is not tested for performance or it is not tested for safety. Because when it comes to our family or ourselves, we will not do something which is unsafe or untested. That is the entire context. That is the entire perspective. So today's workshop, my 20 minutes, will start with this perspective that we need to focus on something which has been proven for the performance parameters, which anybody is promising you, and it has been tested for the safety by something which is credible and trusted by a government, something like a government agency like a Bharat Cap or an NCAP star rating in this context. So this is the first thing. We start with the rockfall mitigation measures, the best global practices, which is my theme, and the certifications guidelines which are there. So why this matters, why the entire thing matters, is the accountability which matters. Who is going to be held accountable? If something goes wrong, if some design fails, who will take the responsibility? So now try to imagine the entire process is divided into 3 stages or 4 stages. Once there is a regulatory body, just like the department or the ministry, and then it has a technical arm. In every country, it's the same thing. Every regulatory body which mandates, they have a technical arm. Now that technical arm, like in our case, it's Indian Road Congress. Their job is to do the study and help with the standardization with BIS, or help with the code development through ministry once it gets mandated. And once it is done, the entry of the DPR consultant or the OEM or the applicator follows much later. The first scenario is about the regulatory body who's going to do it. So our objective today is to align India with the global best-in-class practices and what is there and how we can implement it. In the last 15 years, we are already implementing it, but today we are just going to make sure that we get it on board as a standard process. And this is definitely needed that we now think about beyond, this is the main topic, that beyond self-declaration. If I made that car and I would give you a 500 bhp car with 5-star rating, but only I have tested it, would you trust me? I'm sure that nobody would go with that car. So you need something who has tested it for performance. So self-declaration is something which has created a lot of dilemma, a lot of fear in the industry, that if this person has tested something, who will who will vouch for it? So the integration that we are looking into, it's about the geotechnical code, which will help you with the design. That design will help you with the standards in practice. And as ministry or as the topmost apex regulatory body, you cannot trust some random accreditation. You need something which has been trusted by other government agencies, or maybe some other countries, or some other organizations which are there in the past, which have a proven record, and so that the transformation and the adopting the process of adopting it is much more easier. So this is just the context, this is just the introduction part. We come back to the main thing, which is harmonization. There will be some technical jargon, so I'll switch to a very simpler language. What harmonization means, I'll try to make you understand with the simple examples. So harmonization in that way, example, you have a manufacturer from Africa. He wants to trade in India. In India, ISO is that body which issues, in India, BIS is that body which issues standards. But now BIS does not know how to, let's say, for example, for a particular product, does not know how to make a rule, make a standard. That is called standardization. If I am BIS, I know, for example, everything, then I would not need any external support. I would not need any foreign support. I can do standardization on my own. That will be my ruling, that will be my mandate. That is called standardization. The difference between standardization and harmonization is, harmonization will help you absorb the specification from around the globe. So for example, if an African manufacturer is there and for a certain product, and BIS does not know about that product, so what it will do is, it will just quickly jump to ISO or maybe some other international standard organization to fetch for those things which are available. And if found reasonable, they will absorb it immediately. So now it's easier for that African person to come into India and trade, because it will need a certification from BIS which has been adapted from ISO. So that is called harmonization. So the core benefit of harmonization is, it allows you to sell cross borders. This is the bottom line. When you want to issue a standard, you want to understand it first, and then you might think that I am not, probably the best technical person to issue a standard. Why don't I harmonize? Why don't I adapt from the other government agencies or worldwide practices? So harmonization and standardization, they only differ by this thing, that harmonization allows you to adopt different world practices into your own place. So it helps you to sell cross borders. So we will not go into definitions, because I don't want you to be really bored with the technical definitions. So this is all about what is harmonization and standardization, and what is the body responsible for it, which body is responsible for it in India. In India, BIS is responsible for standardization and harmonization both. If there is no global standard which exists for something, then it might do its own research and then issue a standard, and that is called standardization. And if a body is already existing worldwide with a certain practice, it might easily absorb it. That is called harmonization. Now we come to another technical word, homologation. It is nothing but certification, trust, a seal of trust, a hallmark, basically. So what homologation means, if you have any product and if you want it to be tested according to any given standard, once approved and once tested for its performance, it will be homologated. Homologated means that this country has absorbed this technology, absorbed this system, and certified it. Certified by the apex body of that country, of that judicial territory. So now we come back to Indian context. In India, the regulatory body, the apex body is Ministry of Road Transport Highways, operating through different departments. In India, standardizing body is BIS, which can also do standardization, which can also do harmonization. Harmonization is nothing but adopting different global practices and implementing it to help you with the cross trade, cross-border trade. And once you put your product for certification through BIS, it's called homologation. Now this product has been trusted with Indian government that it is good for trade, it is good for business in my territory, in the Indian territory. This is called homologation. So what it does is, the key benefits are, it ensures system reliability. Somebody has tested it for you, some apex body has tested it for you, and this validates the performance claims. It reduces the liability risk. If you do not have a certification in place, there will be always finger pointing, that how can you trust somebody who has not been tested by somebody apex, or some government regulatory body has mandated something like that. Unless it is mandated or tested, you cannot really trust for the performance, like we took that example of the car in the beginning. So what we are going to do here is, we are going to build the ecosystem. So we know that BIS regulators, labs, OEMs, contractors, owners, academia, and we all are there. Now we all have to share this knowledge to form into, to completely integrate this into one integrated ecosystem. This helps in transparency, equal opportunity for everybody, not lowering the bar of the performance, but bringing it to the requirement which is needed by the site, or maybe the problem. So there's a lot of confusion when it, I hope that you have understood about the working of different agencies in India, and how they are operating in India. The role of ISO is highly confused in this context. The main thing to know is ISO legally binding? ISO is not legally binding unless somebody really uses those clauses or references as a mandate. Unless, for example, like BIS, the first thing BIS will do is, if they find anything useful in ISO directory, they will try to learn about it and adapt it. That's harmonization. That's now legal. It has a legal status. But inherently, ISO is not legal in itself. For example, if I am ISO, I am doing my own research of 1,000 products. I have 1,000 procedures to test something or to issue a certain specification of something. It is not obligatory for any country to follow it. It only becomes obligatory if some agency of that country has mandated it, that I want to use this specification because I trust ISO. They have issued something. They will hold the responsibility of the performance of this thing if tested according to their procedures. This is the entire thing. That is the role of ISO. So it helps to give you a structure, of course, but if something is missing in ISO, then of course we can look to other agencies. That is one thing to understand. So ISO in itself is inherently not obligatory. It is not legally binding. We have to see in what context ISO is referred to and who is referring to ISO. Now we come to the role of IRC in this context. So IRC, as I said, in India is the apex body, as the apex technical arm for the highest body in India, which is the regulatory body for, which is ministry. So IRC helps with all the studies, all the analysis by a committee of experts, or maybe they can take opinion from the stakeholders as well. So IRC's job is to understand the global practices, formulate something and send it to ministry or BIS for acceptance. Now it's up to ministry. Should I mandate it as a law? Should I mandate it as a compulsory regulation? And if this gets the status if it gets a legal status, then it becomes a code. The ministry is responsible for studying what IRC has submitted to it for any given problem and try to make a code out of it. This geotechnical, for example, in our context, I'm going to refer to geotechnical thing. If IRC has done something with the geotechnical industry and they have created something on their own, so this will go to Ministry for acceptance, study and approval. If they find it good, they will mandate it. This will form the baseline of the acceptance. This will be the geotechnical law or code, and this will be binding. Unless mandated by the ministry, it is not binding. It is a work of reference or a work of committee of experts which think that this might work. And this is only for then the apex regulatory body to see how should we implement it. So inherently, it is also partially binding unless somebody clearly specifies it that we want to go with this document by IRC. So this is little bit of trying to understand the confusion here. So IRC is very supportive in that role with that regard with MORTH and BIS in harmonization, because everybody, if I would be the regulatory body, I would need somebody to do that study for me. So IRC is doing that study for the regulatory body. So now, like every country, you have a regulatory body, you have a technical arm. The technical arm does the job for you, does the entire study, help you with the research. Now it's up to me as the regulatory body. If I want to mandate it, I'll take the opinion from the stakeholders, try to understand everything. If found satisfactory, then we can mandate it. Otherwise, it will stay with IRC and it will stay there as a reference or a study document. So the ecosystem that we are looking after is the technical arm provides foundation to MORTH and BIS, and BIS harmonizes or standardizes, and the MORTH regulates. So this is just we are moving step by step, because in these 20 minutes it looks like we have to do the entire crash course of our industry. So we come to the most critical part here. This could be one thing that we are here. What are the gaps in our area? So to understand India's terrain reality, broadly we can say that it's divided into three parts. Broadly, Himalayan territory or the Western Ghats or the northeastern hills. And everywhere there's a different problem. Sometimes we need active monitoring, sometimes we need seasonal maintenance, or sometimes we might need a regular inspection. So we cannot say it's one problem pan-India. It's not the same thing. So where we should fall short, it's the ambiguous definitions again, which leads to inconsistent design, incomplete tests, performance uncertainty, missing quality assurance and quality control checks, installation defects, and references which have not been updated, which leads to compliance issues, and inconsistent methodologies, which leads to quality gaps. So both the reports as of now that we have in hand, they are there for a good study and implementation, but they do not explicitly regulate or certify any product type. That is needed to be understood, that it's not explicitly regulating anything. It is still not mandated. So the ambiguity of practitioners, which is the underlying reason for this conference, is the ambiguity for the practitioners. A lot of global practices are there, but that has created a lot of trouble for everybody. So we can also skip this, because this requires another time. And we also need to know that when it comes to standardization or practices related to corrosion protection, we are heavily focused on the product types only, like the meshes or the barriers in our context, or those things, the heavy things. But the accessories, they are highly ignored. So this also contributes to the system weakness and failure, which needs regular checks, periodic checks. It is just to tell you that we need to focus much more on the other areas as well, and we need to rectify these things, and an annual inspection is something that we can begin with. So These gaps, they lead to durability, O&M costs, failures, and procurement disputes. Repercussions, impact on the quality and performance. Under-designed systems, it could be the fact. Unregulated systems, which is one thing which is really disturbing everybody. The liability and the failure risk. So this is something not to be really proud of. This is either due to a faulty design or unregulated material selection process. The word unregulated is really key here, that it is still not a regulated practice, or a poor method statement. So all three are in the zone. Is it a design fault by the consultant maybe, or is it by the practitioner who could not select the right material, or maybe the installer did not have the right method statement. So we do not know who to catch for that reason. Or maybe the incorrect choice of stabilization system. So all of these questions have created those doubts. Now we just need to, I'll take not, I will not take more time. It's already there. So the main thing why we are here is to discuss about coming to regulatory body. The confusion in the mind of the regulatory body is that then what do we do here? Do we let it up to the hands of BIS or IRC? They will do something for us and then we can implement it. And if it's going to take, I really want something indigenous to happen. I really do. But this may take weeks, months, or years, we don't know. But until that happens, we need something in place. We need something that we can really easily rely upon, practice which has been accepted globally. So IOTA is an organization which is there to give you that confidence with the innovative product types. It will help you with the standard procedures of checks, standard procedures how to do the regulatory inspections, how to help with the design parameters. So this will eventually help the regulatory body to eliminate that gap, how to test for performance, which was our main slide in the beginning. You have a technical design to do the job for you. According to that technical design, you have established, I need a certain system with certain specs. That's there. That's not our job to do. That's the designer's job to do. So you have now established a fact that we need a system to deal with this problem. Now, who will test this system and how will they test the system? That is the big question mark. So we have this organization in this place which has taken the responsibility for doing the standard checks and tests across all Europe. And why they do that is that it is mandated by European law. So adopting from one government by another government should be a much more easier process, a much more dependable process. It is mandated by European Union law, and it is binding on all 34 member states. This is one thing which is a very key point to note. So this goes back to the main definition of harmonization. What BIS can do here, or what ministry can do on its own, they can adopt this and harmonize it. That's where the word harmonization comes into picture. So this is the complete chain of event. You have a legal framework which is binding by the law. It is trusted by another government. You have a coordinating agency there, IOTA. Here we can have BIS for that matter. You have technical bodies there which do the test. Here also we can assign a technical body to do the test. But if you look into the mandate entirely, when you get a CE marking, like BIS gives you a hallmark marking in India, then IOTA also gives you a marking which is called ETA certificate. If you possess it in Europe to do the business, it's mandatory to possess that certificate. You are CE marked. You must have heard about this marking CE. This mark is mandatory to do trade in Europe. That's the simple correlation or analogy. What BIS does in India and what this organization is doing for Europe. Now, one little point, that are we only going to discuss about what is being practiced in Europe, or are there other global standards also? So what we know is, okay, so what we know is, in the global practices, we have got ISO. We all know that, which is the International Standard Organization. So ISO helps in harmonization through BIS, which we all have established and learned so far. One thing is that ISO is not legally binding, it's an open organization. You can choose and not choose this. So then there is European, Japanese, Oceanic, American, and IS, which is Indian. This is a one-shot brief comparison with the other global practices. So in the European Union, for example, to test for the rockfall mitigation measures, yes, IOTA is primary and obligatory. In the individual countries of the European member states, it's also mandatory. IOTA status is legally binding on every national that is covered under Europe. When it comes to UK also, the UK technical assessment, that's the document name, UKTA, it's also mirrors EAD, which is the testing procedure, testing protocol of the rockfall product type. US also, but US is not, it is not centralized because it's a federal country, it's not centralized. So they do not have, even USA cites that, we do not have a unified system in US to test rockfall barrier systems or rockfall mitigation systems. Hence, they cite in their guideline that we depend upon IOTA for performance tests. Japan is the only exception which is so far in my study has not gone for IOTA, but for very specific reasons. Because first of all, Japan lies on the Pacific Rim. So there the high frequency earthquakes are there, and the soil type is volcanic, and there is a runoff, which is quite faster than Indian conditions. Then there is snow load during the winter seasons because it's all surrounded by the sea. So that barrier is over-engineered to condition a lot of things, a lot of requirements according to each side. So they don't have a standard system for the entire nation of their own country. They work on territory to territory basis and on project to project basis. Australia, for that matter, also depends upon IOTA. New Zealand also. So what I can easily establish from this fact, and India is partial because so far in last 15 years of my practice, EAD is something which has been there on and off, but it is not still mandated. So one key example with Japan and IOTA I have already mentioned. The only global export potential by binding with IOTA is that adopting IOTA allows you to, thank you, allows you to foster a domestic industry that can export globally because it is accepted everywhere. In fact, out of 69 advanced HDI nations as recognized by IMF and UN, IOTA is officially recognized in 45 plus countries as the rockfall certification for 1:1 scale impacting testing protocol. So it is rather easier to follow. This we have already discussed. This we don't need to discuss. So I conclude with one thing, that safety is not expensive, it's priceless. And we need to have one unified method for one unified standardization with an integrated approach with the ecosystem for enhanced protection. Thank you.
Thank you very much, sir, for that insightful presentation. We now move to our next presentation on expert committee report on cost-effective long-term remedial measures for landslide-prone areas in hilly regions. And to present this important subject, I request Professor J.T. Sahu from IIT Delhi to kindly take it over from here. Can you please extend a warm welcome to him on stage?
Thank you for giving me this opportunity. Respected chief guest and respected secretary sir and all other honorable delegates and participants, thank you for giving me this opportunity, and I'm going to present our expert committee report as a chairman of the committee on the landslide protection measures. So myself, Professor J.T. Sahu, and most of these members organizations are represented in this workshop. So there was a one day brainstorming session by Mr. Sarangi, former DGNSS at IIT Roorkee on 5th April 2024, and based on that, then this committee was formed on 28th. I think this is 28th May. This is I think with the modified slide. The updated slide. Can you put? Anyway, I will proceed. So the mandate of the committee, based on this, this committee submitted its report on 28th November, and basically the ministry said that you have to, this is a guidance and the reference document, and it was put on the website also, and then all stakeholders were requested to take reference from there. So the objective of committee was, when you visit any site like this, let us say, you see the slope, you see what is the height of the slope, you see what is the steep angle of the slope, whether it is a composition is rock or soil. These are the things you note. So based on this visual inspection, you have to decide which site investigation methods are you going to adopt. This is not a mean task. This is one of the big decision making tasks. So for this, we were told to make a matrix where you can look at the visually inspect the site, and from that can you come up with the investigation method. So for that, this is the first matrix we were told to give, matrix of different types of field investigation based on the visual inspection. The second matrix we were asked to prepare was the based on this soil parameters, can we come up with the appropriate mitigation measure, because this is one of the most important gap which is not filled in the literature anywhere. If you see, you go FHWA code, you go to the any other code, this is the big decision making gap, and that is where this particular document come into play and gives you confidence, a structural approach ki these are the elements which can form the mitigation measures. So for that purpose, so visual inspection parameters, we have about 7 types, and most important are slope mass, which type of slope you have. Then what is the height of the slope? It is less than 60 meter, 100 meter or greater than 100 meter. What are the slope angles? Less than 30 degree, between 30 and 45 degrees, and so on. Then what are the source of water flow? That is whether the water is flowing on the surface like nala, or there is a seepage through the slope. And are there any other instability issues like shooting stones, sinking zones? Then there is a ROW restriction also. Is there any ROW restriction? Now here slope mass has been classified into 3 types. One is the rock slope, very easy to understand. Other is the debris or soil slope. How do you define? Debris is basically a coarse material where weight of particles with diameter greater than 2 mm is more than 80%. And soil slope consists of all kind of particles, and talus slope is a mix of 2. If overburden is less than 5 meter made of soil, then we call it as talus slope. So with this in mind, then we decided what field investigation generally we need. We need topographical mapping, which may involve videography, photography, just total station, LIDAR, or DTM or DEM, digital elevation modeling. By drone you can do, UAV, even satellite data nowadays available on Bhuniti portal, but that is 30 meter list count, that's not very useful. Then most important is geological investigation, and there also most important is slope assessment. So in slope assessment, we have many different parameters. So if it is rock slope, one has to determine the slope mass rating, weathering of the rock grade, and whether which you expect planar failure, wedge failure, or toppling failure. If it is a debris slope, you have to determine your strength parameters, which are usually C and phi, based on the back analysis, and classify this slope based on composition, whether it is a debris, riverbed material, or glaciofluvial kind of material. And same way for talus slope. Then beside that, for many cases you need hydrological parameter, geophysical parameter, geotechnical investigation with the borehole, etc. So I give the here investigation matrices for, let us say, example of investigation matrix like for rock slope. So here this is the first two row. Ma'am, can I have the updated slide? नहीं अपडेटेड नहीं है, ये पुरानी वाली जो भेजा था मैंने 4 दिन पहले, वो वाली है. चलिए छोड़ दीजिए, नहीं तो दे दीजिए, यहाँ से कर सकते हैं. नहीं मैं पेन ड्राइव तो है मेरे पास, मैंने वहाँ लोड करवा दिया था. Anyway, so A02 is actually the slope height. This slope height is about less than 50 meter. A03 here is, it tells about the any type of the slope angle. Because A, B, C, D, nothing is written, that means any type of slope angle. So if you know these two parameters from your inspection, then you can find out the B02, which is a topographical mapping will be required, and also you will need geological investigation, which is C category. None other you will need. Similarly, for debris flow, debris slope, you need, if you have, you know this from the slope angle, then you need topographic mapping and geological investigation only. Similarly, for talus slope. That also gone, but now they have, I think, loading. Just 2 minutes. 1 minute. Is on the way. How much time I think? हो जाएगा सर. I'm okay. I'm on the schedule. No, आ गया. Thank you so much. So then we come to the, so once you have determined which type of investigation you have to carry out, and you have determined the investigation parameters, then come the major thing that which type of mitigation measures are you going to adopt. So basically, if you see in this, we have made 13 categories of investigation measures. We have made 13 categories of investigation measures, but actually broadly there are 4 or 5 categories. First thing is, you need to make the surface more gentle, or remove the loose material, wherein we get the removal of material, erosion control, or surface treatment like drapery, etc. Then we have the water problem. Water problem can be solved either by the surface or subsurface water, creating high pore pressure. Then we can have, if it is a river there, then river training work, or channelization of nala if surface flow is there. Then third thing is, if suppose there is some movement has happened, then you need to prevent that movement and put the countervailing weight, and that can be done by the retaining wall. Then you are having the reinforced soil structure. If you want to make the level differences, then, and there is a right of way problem, or on the valley side you don't want to excavate further, then you have the reinforced soil structure. Then if global factor of safety is concerned, you go for the slope reinforcement. If there is a doubt of detachment of rock block, or there is a flow of debris that may occur, then you go for the barrier like rock fall barrier or debris flow barrier. And beside that, some special cases like sometimes you need to support pavement on micropiles, or do the emergency work, or avalanche protection. So these are the broad categories. We have categorized that into 13 categories, and in each category there are some categories have 14, 15 subcategories, and some categories have 3, 4 subcategories. So total 71 subcategories as per the available IRC and IS code we have listed. And this shows some of the, like, removal of material can be done by belly benching, vetiver grass, steel mesh for surface protection. Then you have geojute mat for surface protection. These are the barrier, rockfall barrier, debris barrier. Channelization of nala can be like contour drain or CC channelized nala. River training work may be concrete foam mattress, concrete spurs as can be seen here, or retaining walls can be CC retaining wall, CC cladding wall. These are some examples, not all I am talking about here. And gabion wall or shored MSCW wall. And surface treatment can be like this Japanese creep wall, or you can have the soil slope reinforcement like a soil nail here, or pre-stressed cable anchor, or pavement to be supported on micropile as shown here. So based on this, we have developed mitigation matrices and developed for each of these slope composition, rock, soil, talus, and additional measures, emergency measures. So rock slope, for example, here for rock slope, this shows 2 rows only. There are more than 13, 14 rows here for different combination of slope. So for example, how to use this? So basically, visual inspection will give me height is less than 60 meter, A02A here, and 30 to 45 degree slope is A03B. Then C06A3, this has been obtained from the geological assessment. So 606A, it is slope mass rating 3. Planar failure C06A. Weathering grade is C06A3. These are obtained from the geological assessment. And then once we know that, this on the other side of the matrix, you have the elements which will constitute your mitigation measures. So they consist of rock scaling G01A, anchored CC cladding wall at toe G04J, grouted anchor G07A, and G12E contour drains. Similarly, given for the talus slope, and this is for the debris slope. Here again you can see visual inspection parameter. Height is for this row, if I tell, there are 12, 13 rows like this. for different combination. So for this row, if you can see, this is how you have to read the matrix. A02A gives the height, which is less than 60 meter. A03B, 30 to 45 degree, your slope is there, and debris composition. Then the mitigation measure is G01D, which is belly benching, and erosion control is G03A. Oblique means either this or that. So G03A is seeding and mulching you can adopt, or you can go for the vetiver grass as per the availability at the site. And then there is a additional matrix given wherein you have to account for surface water, subsurface water, shooting stones. So if you have surface water, you can use this matrix is there for subsurface water, which is A0B. So A0B is here, and you can look at here, it is perforated pipes and debris flow barrier. So these will be the additional elements that you will have to adopt. Beside this, additional matrices are given for sinking, river action, road widening, emergency road supports, avalanche, etc. So I will just give two examples, and Mr. Sudeep ji, agar if you want me to stop for any reason, please let me know. I can stop. There are only 4 or 5 slides left now. So case study 1 is Karnaprayag, and this is courtesy measures. This example is courtesy measures DHTC, who from where we had a committee representation. So in this one at Karnaprayag, this is national highway, and because of landslide, this has been ruined. So inspection told us that slope geometry will be less than 50 meter A02, slope angle 40 to 50 degree, and it is a rock slope, seemingly rock slope, so A01A. So inspection matrix give me topographical mapping, total station B01, geological investigation. So now there was doubt about whether it is a soil slope or rock slope. So 2 bore holes were made, like here BH1, BH2, and this is the bore logging, and you can see all the broken stones are there, RQD almost 0. So the affected stretch was 140 meter horizontally and about 80 meter vertically. So this was divided in 3 zones for mitigation measures. So zone 1, it was found that large shearing has occurred. Zone 1 was area above the road. So there it was found that very large shearing has occurred, and soil has, and it has, all the stones have been broken. So it is behaving like a soil. So here soil kind of matrix A01B was adopted, and same way at the road, on both sides of the road, adjoining the road, was also completely broken. So again it was considered as soil slope, and this is the representative row for based on the slope and height, and this is the debris composition. So the mitigation matrices composed of, or mitigation elements comprises of G01C, terracing and benching. So you can see here terracing and benching was carried out on the area above road. Then G07D soil nails, G07D soil nails are shown here. Then 3D net with hydro seeding, G03A and G06C. So seeding, 3D netting was done here because slope was 45-50 degrees. And then seepage was there through the slope. So addition of A02B seepage measure was added, G02A, as shown in the previous example. Similarly, zone 2, which was adjoining the road, hillside and valley side. So road is just at the base here, and this is on this side. Gabion wall G04A was added. Then 2 rows of self-driven rock anchors was added, G07D, G07D here, and contour drain G12E. So this is how you have to use the elements of mitigation measure. And zone 3 was considered toe of the overburden. So road is here, toe is here. So here it was jointed rock and some movement was observed. So it was considered as rock slope, with probable failure mode as wedge failure. So C06A beta, and SMR class was measured as assessed as G06A4. So based on this, these elements were obtained, and here in zone 3, rock scaling G01A was adopted, and anchored RCC wall G04D was adopted. This G06A, which was rolled cable net, and G07B, which was SDRA, were not needed, so they were not used. So this is the way in which you have to operate the matrix. Some elements may have to be used, some elements may not have to be used. Not all elements are compulsory. Then second example is National Highway Meghalaya. So this shows the slope condition before treatment, and this example is courtesy measures highway concession 1, and this shows before pre-mitigation, this shows after mitigation. So in this case, it was reconnaissance survey showed that it is a soil slope with A01B, and height is less than 60 meter, A02A. Slope angle is 30 to 40 degrees, A03B. And the composition is debris, and it was found that bamboo is abundantly available in vicinity, and no subsoil is, no seepage is there. So relevant row in the soil matrix is A02 here, A03B this one, and debris C06B1. So based on that, G01D, that is the belly benching with bamboo, was selected, with seeding and mulching G03A, and or vetiver grass. So vetiver grass was also present there. So G03C was adopted here, and G12E was not needed, which is contour drain, as you can see here. So this shows the bamboo benching and plantation of vetiver grass, and then this was after completion of plantation, and this was after 1 or 2 rains, all greenery. So here G12E was not needed because contour drains were not needed here. So last 1 or 2 slide now. So limitation of this is, we are not, this particular report or metrics are not detailed design. You have to do the detailed design based on the site conditions and may involve use of software. Each slope is unique, and all elements may not be required, or additional elements may be required also. Leaving some or implementing select ones may bring only partial benefit or even failure. Maintenance of rockfall barriers and drainage system is needed. Observation points for monitoring is recommended, and in case of doubt, expert advice should be sought. And finally, conclusion. Then what this particular matrix gives? It gives the confidence based on the structured approach. Second thing is, it serves as a valuable tool. Then it provides you in selecting cost-effective measures. It benefits communities and infrastructure by mitigating landslide hazard. And one of the important thing here is, it provides you a detailed bibliography of more than about, I think, 70 or 80 literature from all over the world, and quotes which are relevant for the landslide protection. Thank you. Yeah, I can take questions. Yeah, I can take questions because, yeah.
Thank you. Sir, my small question is that, sir, in entire report, what, in first example, you have chosen 3 zonation you have done, sir. Zone 1, Zone 2, and Zone 3. And based on the zonation, you have done the analysis. But in the report, sir, I think report is silent on that part, how the zonation can be done.
Yeah, actually, that is the part, that is what I said. This will give you the elements which you should be able to use.
Yes,
You
sir.
should use, not the detailed design. Those zonation, etc., is a domain of a detailed design. I mean, that is the case. Actually, here you will have to understand that when you go to the site and you see the slope, you really do not have idea. Some so-called expert may come and tell you that no, my product is needed, this product is needed. So this avoids that kind of confusion. It tells you that yeah, these are the elements which are needed. Then you can, based on that, do the further investigation, and then after investigation you have parameters. Then these are the elements needed, and now based on these elements you have to take the best benefit and lower the cost
Yes, sir. Thank
by
you, sir.
doing detailed design.
Thank you, sir. Thank you.
And second thing is, all the mitigation measure elements will not be required throughout the slope. If you provide everywhere, let us say SDA, then cost will increase. So maybe 1 or 2 row of the SDA will be required at the base, and 1 or 2 rows at the adjacent to road. Yes, sir.
Namaskar, Professor. I am R.K. Jain, Haryana PWD, connected with the ministry from 1991. You have talked of subsoil water in one of the slides, three slides. There was a peculiar case, NS 75 ministry, kilometer 237 to 263. Water, the hydraulic gradient line from the hillside was cutting through the subgrade, and artesian conditions were developed. The road will fail every year. So if you, in your study, if you could tackle that also, it will be very helpful.
Sir, for that we have suggested 2 or 3 things. One is the presentation is not now gone, I
Of course,
think.
excuse me, I solved it with the help of late Dr. B.B. Pandey. The road is perfectly okay now, running from last about 10-12 years. And this is a beautiful study. I can give you that material. If you include in that, it will be very helpful. How the artesian conditions were taken care of.
So,
Thank you, sir.
just to give you, we have made different categories here. So, in this case, one is, let us say, so this one is the matrix. So, in this one, if I have, I can say subsurface water, high pore pressure.
Yes, yes.
So in this case, we have given most popular is you have to put the perforated pipe, which is semi-perforated pipe, and enclose it with the non-woven geotextile, and then insert that. Make the hole in the rock or soil and insert that, and the geotextile acts like a filter and doesn't and prevents the choking of the clogging of the drain,
That
and
I
then
know,
water
sir.
can come in and get out. So that way you can reduce the pore pressure.
So please elaborate it in your study. That will be very helpful.
No, it is in the report elaborated. So
Okay.
that comes in matrix. And second thing is to prevent the water from entering itself, we have we have given the provision for toe drain or contour drain. So along the contour, when rainwater is coming, you have to provide the drain so that water doesn't get the time to seep inside.
Thank you, sir.
सर बहुत मतलब मैक्सिमम टाइम पे जो हमारा डैमेजेज या फेलियर होता है ड्यूरिंग रेनी सीजन होता है, और हम स्टडी करते हैं उसके बाद ड्यूरिंग नॉन मानसून पीरियड। लेकिन ड्यूरिंग रेनी सीजन बहुत सारे स्प्रिंग जो पैदा हो जाते हैं, निकल आते हैं, वो शायद हम बाद की स्टडी में उनको कैप्चर नहीं कर पाते, और कभी-कभी जो हमारा ट्रीटमेंट हम करते हैं वो फेल कर जाता है अगले मानसून में। तो ये कम से कम हमारे लिए ये मैंडेटरी ना हो, जो फेलियर हमारे रेनी ड्यू टू रेन हो रहे हैं, कि उनकी स्टडी भी हम ड्यूरिंग रेनी सीजन ही करें। क्यों?
सर, उनकी स्टडी रेनी सीजन में बहुत मुश्किल होता है। मतलब अगर प्रोजेक्ट आपको डीपीआर वगैरह भी बनाना है तो यू हैव इन्वेस्टिगेशन ना रेनी सीजन के पहले, जैसे बोरहोल बनाना है आपको, या फिर आपको जियो फिजिकल स्टडीज भी करनी है, तो ये सारी चीज़ें रेनफॉल के पहले ही, मतलब that is what in DPR is done. But क्या होता है कि जब रेनफॉल होती है और one can look at the effect of the water. For example, आपका C5 पैरामीटर जो है we can take as a worst case based on the back analysis. That is why we have recommended back analysis, क्योंकि जब तक पानी नहीं है तब तक तो everything is good, लेकिन जहां पानी आया तभी पोल खुलती है, एक्चुअली बोलना चाहिए.
अभी हमने उत्तराखंड में एक फेस किया है कि हमारा सिंकिंग जोन का ट्रीटमेंट हुआ, ड्यूरिंग ड्राई पीरियड ही हुआ सारा कुछ, लेकिन आगे जो मानसून आए उसमें फिर से शुरू हो गया. इसका मतलब हमने जो रेनी सीजन में जो भी स्प्रिंग का एनालिसिस था वो ढंग से कैप्चर नहीं कर पाए.
सर वो रेनी सीजन से ज्यादा ना सर इम्पोर्टेंट है कि ये देखिए, ये जो डाटा है हाइड्रोलॉजिकल मीटियोलॉजिकल इन्वेस्टिगेशन, दिस गिव्स द हिस्टोरिकल डाटा आल्सो इट कैप्चर्स. सो आपका जो रेनफॉल है तो HFL वगैरह आपको पता चल जाती है कि भाई हाईएस्ट फ्लड लेवल हमारा ये है. इफ यू इवन डू द इन्वेस्टिगेशन इन मानसून सीजन लेट अस से, तो आपका जो HFL है यू शुड टेक द मैक्सिमम HFL ऑब्जर्व्ड इन द पास्ट इवेंट, लेट अस से 15-20 ईयर्स का जो भी पीरियड ले लें जहाँ पर भी हुआ है. आजकल तो काफी एक्सट्रीम इवेंट्स भी हो रहे हैं, सो दीज आर द थिंग्स विच इज हैपनिंग. या Yeah, go ahead. I can hear.
Instrumentation for the slope areas.
So this is what we have said. Observation points should be established for monitoring.
In what form, sir? That what I just want to know. Like in form of different instrument, like what instrument we have to install for slope things, like MPBX or BRT or pressure cell.
I
mean,
think
it's a
our
slight-
mandate was limited to
No, I got-
matrix
I got-
preparation, so I didn't go for. But monitoring also is very important. I feel what you are saying is very right.
Yes.
We must establish certain points, and actually monitoring is completely other domain also which needs to be taken care, because unless the researchers also get the data from the failures,
Yes, sir.
not from the good structure. We are getting so many good data, everything is good and good. We want the failure data, which we are not getting. So if we can get that, nothing like that. So I think you are right. We need to do monitoring.
Thank you, sir.
It's a good report, sir. We also refer it in the field. I just wanted to ask, like, any statistical things have been done to, like, while they're forming the matrix, that to see that, or it's just like you have done the analysis for this type of slope, this types of solution can be used, or the previous datas have been used that if you have such kind of slope, this kind of solution is long lasting or something like that. Or we can make in the future, like, and update the reports also. based
No,
on
that is very good question, and that is what I said. Ki we are not having the data, monitoring data or anything. So no question of statistical. It's only the experience of the organizations which were incorporated. And for example, CSIR, or you take THDC. So these people are very actively doing almost everywhere. They are running this slope, that slope. So means my contribution is more like a management type, but other organizations all have pitched in with their experience and the professional who are dealing with that. So for example, THDC may be is represented here. They have done more than hundreds of DPR, so their contribution. So it's not statistical, but I would say based on the experience. Yeah, but that is a different, altogether different thing, because it's a diligent work you have to go through for years, and may result even very good PhD if you can get the monitoring data and the statistical analysis. So thank you so much. And if there are more questions, let me know during the lunchtime. I'm here, so we can talk about.
Thank you very much, sir, for a very detailed and informative presentation. Ladies and gentlemen, we now move towards the inaugural session. Our chief guest of honor, will be joining us very shortly. As and when they'll arrive at the venue, they'll first visit the exhibition stalls and then will join us inside the hall. As and when they'll arrive inside the hall, we'll request you all to give them a standing ovation and an energetic round of applause. We request you all to kindly remain seated. Thank you for your patience. Ladies and gentlemen, our chief guests and guests of honor have arrived at the venue. We've just been informed, and now they are proceeding towards the exhibition visit. So we would request you all to kindly remain seated. We'll be starting the inaugural session very soon. Thank you. We once again inform all our delegates and participants that our Honorable Minister, our chief guest of honor, have arrived at the venue and are now proceeding towards visiting the exhibition stalls, in which we are showcasing the innovative technologies and solutions in landslide mitigation and slope stabilization. Post the exhibition visit, they'll be joining us inside the hall. Once again, requesting you all to give them a standing ovation and an energetic round of applause as and when they arrive inside the hall. Thank you very much. We request you all to kindly remain seated and please switch your phones to silent mode. Thank you. As you all can see now, the live footage of our Honorable Chief Guest of Honor, proceeding towards the exhibition visit. Yes, sir. ठीक है. Enter the hall. ठीक है सर, ठीक है. Ladies and gentlemen, this is to inform you that exhibition visit is near conclusion. Our honorable chief guest of honor, will be joining us inside the hall very shortly. Once again, requesting you all to please be seated. Kindly switch your phones to silent mode. Thank you. Ladies and gentlemen, our honorable chief guest and other esteemed dignitaries have arrived inside the hall. Let's welcome them with a standing ovation and a thunderous round of applause. Our honorable chief guest, Honorable Minister of Road Transport and Highways, Shri Nitin Jairam Gadkari ji. जोरदार तालियां देवियों सज्जनों, हमारे आज के कार्यक्रम के मुख्य अतिथि अब सभागार में पधार चुके हैं. आइए जोरदार तालियों से इनका स्वागत करें. Honorable Minister of Road Transport and Highways, our chief guest, our guest of honor, Honorable Minister of State, Road Transport and Highways, Shri Ajay Tamta ji. Honorable Minister of State, Road Transport and Highways and Corporate Affairs, Shri Harsh Malhotra ji, our guest of honor, have joined us, along with other esteemed dignitaries. We extend a very warm and hearty welcome. And now, ladies and gentlemen, we move to the formal welcome of our distinguished dignitaries. May I request for the bouquet presentation as we warmly welcome our esteemed guests on stage with floral greetings and our heartfelt regards. I request Dr. Krishna Kumar, MD, NHIDCL, to kindly welcome our chief guest, Shri Nitin Jairam Gadkari ji, Honorable Minister of Road, Transport and Highways, with a floral bouquet. Let's all extend a very warm round of applause. I now request Shri Anshu Manish Khalko-ji, Director ANF NHIDCL, to extend a very warm welcome to our guest of honor, Shri Ajay Tamta-ji, Honorable Minister of State, Road Transport and Highways. Kindly keep the applause going, ladies and gentlemen. I now request Shri Sudeep Chaudhary-ji, ADG Moth, to please welcome our guest of honor, Shri Harsh Malhotra-ji, Honorable Minister of State, Road Transport and Highways and Corporate Affairs. We extend a very hearty welcome to you, sir. I now request Shri Amrendra Kumar, Director Technical NHIDCL, to please welcome Shri V. Uma Shankar, IAS Secretary, Ministry of Road Transport and Highways, by presenting a floral bouquet. Kindly keep the applause going as we now welcome our Secretary, sir. I now request Shri Narendra Sharma, Director Technical NHIDCL, to please welcome Shri V.K. Rajawat, DG RD and SS Moth. Kindly keep the applause going. I now request Shri Pankaj Agarwal, Chief Engineer, to please welcome Dr. Krishna Kumar, MD, NHIDCL. We extend a very warm welcome to Dr. Krishna Kumar, MD, NHIDCL. I now request Shri U.J. Charam Gaur, Director, Technical, NHIDCL, to please welcome Shri Sudeep Chaudhary, ADG North and Quality, Moth. Thank you very much. And now, ladies and gentlemen, we begin with the inaugural addresses. May I invite Shri Sudeep Chaudhary, ADG North and Quality, Moth, to deliver the welcome address and formally welcome our distinguished gathering.
Honorable Union Minister for Road Transport and Highways, respected Shri Nitin Gadkari ji, Honorable Minister of State for Road Transport and Highways, respected Shri Ajay Tamta ji, Honorable Minister of State for Road Transport and Highways, respected Shri Harshdeep Malhotra ji, Secretary Road Transport and Highways, Chairman NHI is not there today, so DGRD and SS, Rajawat ji, MD NHIDCL, delegates attending today's workshop representing industry, technological solution providers, contractors, concessionaires, consultants, government and PSU officials, academia, research institutes, ladies and gentlemen. A hearty welcome to all of you. It is my proud privilege actually to welcome this august gathering in today's workshop, which has been actually, the main initiative of this has been taken by none other than our respected Union Minister himself. He has been the guiding beacon for many of the technological transformation that has taken place in the highway sector over the past decade, more than a decade. And all of us are aware how important, how prolific and unmatched visionary approach that he has. He has been actually immensely concerned about the implementation of latest policies and letter and spirit, because we could all see that the right earnest for development of the resilient, disaster-resilient road infrastructure in ecologically sensitive Himalayan region, that was still not up to the mark. And this had culminated actually into finalization of a detailed SOP of the first presentation that we have witnessed today, Dr. J.T. Sahu's presentation of expert committee report that was circulated in November 2024. But then it was felt that there are urgent requirements of further fortifying the SOP. There are many loopholes there, there are many weak links there, and the primary requirement is that no spurious technology or material comes up, and which are basically hindering the good implementation of the project. So accordingly, Honorable Minister had actually directed us to have very cohesive, fruitful interaction with the industry experts, technology solution providers, And this initiative was taken under his direction about 8 to 9 months ago, and that has actually fructified into the workshop today. We are now in a position to come out with more discrete sort of an SOP where more transparency will be there and do's and don'ts, etc., for our field level engineers. So that is the expectation of outcome for today's workshop. With this brief background, I once again welcome all the dignitaries on the dais and the delegates who are attending today's workshop, representing industry, academia, and everybody. Thank you very much. Jai Hind.
Thank you, sir, for your warm welcome and setting the tone for this very important workshop. May I now invite Shri V. Uma Shankar, IAS Secretary, Ministry of Road Transport and Highways, to share his valuable thoughts with us. Can we all please extend a very warm welcome to him?
Honorable Union Minister, respected Shri Nitin Gadkari ji, Honorable Union Ministers of State, respected Shri Ajay Tamta ji and Shri Harsh Malhotra ji, DG Road Development, Shri Vinay Rajawat ji, MD NHIDCL, Shri Dr. Krishan Kumar ji, and the core organizer behind this workshop, ADG Shri Sudeep Chaudhary ji. My colleagues, representatives from academia, concessionaires, consultants, and all those who are interested in this rather important topic concerning the highway sector. First of all, welcome to this workshop. We have made tremendous progress in the field of highway construction, highway development over the last decade and more. And when such a rapid expansion happens, it's always time to look back and see where have been our points of failure and try to correct those, because this constant correction will enable us to improve and deliver a better quality infrastructure to the people of this country. One area which has always come to the fore is construction in the hills, and specifically in the Himalayan areas. We have seen instances of failure every year during the monsoon. We wait for the next episode of a landslide that creates a problem with respect to movement of traffic on the highways and the hills. And we hope and pray that there is no damage to life and property. Can't we construct highways in the hills that are resilient, that are amenable to changes that we are seeing in climate, that remain robust even during near extreme events, and that cater to the local environment and ecology of the region? This is where a course correction in the way we take up construction in the hills has come about, and this specific topic is the focus of the workshop today. And I'm sure leading from this workshop, there'll be a few more that will happen in the coming year. Idea is to find processes, technologies, and also methods by which we can achieve the end objective of a climate resilient infrastructure in the hills. We have made certain modifications or in the processes as we have gone along. The mitigation matrix for slope stabilization that Professor Sahu just presented to all of you was a part of that exercise. We have modified the mechanism by which construction in the hills will be taken up. First and foremost, attention to the slope. So even in terms of design, the DPR consultant will be expected to come up with slope stabilization alternatives, mechanisms, and costs. This would be specifically vetted by an agency which is specialized in the hill slope stabilization, like the Geological Survey or THDC or NIRM. And then that would become a major component of the bid process itself. Even in terms of concessionaires, our expectations are that formation cutting would be the first activity, followed by slope stabilization before actual road construction starts. That means that we peg the construction period by at least 1 year. But then so be it. That is the way forward to ensure that our infrastructure in the hills is resilient. Then this action also has to be taken, or rather the construction period has also got to be increased. And the increase in the construction period that has been undertaken through this process is a recognition of this fact. We have also taken up a whole lot of slope stabilization measures in the hills, specific actions in the areas where landslides have been observed in the past, especially in the states of Uttarakhand and Himachal Pradesh. But there are certain patterns that are emerging. The roads that hug the river in the hills are more prone to damage. The roads which are not hugging the hills or not running alongside the hills are less prone to damage. So we are not just looking at the slope stabilization so far as the hill is also concerned. We are also looking at how the ebb and the flow of the river is also affecting highways that run along the road. So our major problem, for example, last year was in the Bhagirathi region, along in the Kullu Manali section, which runs along the Bias. Then in Satluj, the Chamba Bharbor region, which runs along the river. So our damage to infrastructure as a consequence of the erosion power of the river has also been very high. So it is not just landslides that we are looking at. A similar action happened with the Glof issue in 2023 in Sikkim, the Teesta River running through NH10. So these activities have gone beyond just the limited aspect of slope stabilization, but also to study how the river movement happens and what extreme movements of the river can have an impact on the infrastructure along the highways. The guiding force, the inspiration, the push behind ensuring that we build robust infrastructure has come from the Honorable Minister with his experience both in the central government as well as in the state government. And it is upon us that we find technologies appropriate, we find processes appropriate, we find mechanisms appropriate, and at the end of it, the construction practices appropriate to ensure that we are able to deliver on that objective. I am sure this workshop will prove a stepping stone, a thought, a meeting of minds to achieve that objective and move forward. I wish the deliberations and the workshop all success. Thank you very much.
Thank you very much, sir, for your insightful and enlightening address. And now, with due respect, may I invite our esteemed guest of honor, the Honorable Minister of State, Road Transport and Highways and Corporate Affairs, Shri Harsh Malhotra ji, to kindly address the august gathering. Sir, we are very privileged to have your presence and we look forward to your words of encouragement. Let's all please extend a very warm welcome to him.
आज की इस वर्कशॉप में मंच पर उपस्थित हमारे सबके बहुत आदरणीय मार्गदर्शक, हाईवे मैन के नाम से जाना जाने वाले हमारे कैबिनेट मिनिस्टर आदरणीय नितिन जी, मेरे साथी MOS रोड ट्रांसपोर्ट भाई अजय जी, सेक्रेटरी उमाशंकर जी, कृष्ण कुमार जी, राजावत जी, चौधरी साहब, सभी यहाँ पर उपस्थित एकेडमिया से और कंसेशनर्स और इस फील्ड में जो अपनी अपनी एक्सपर्टीज़ रखते हैं, आप सबका भी बहुत बहुत अभिनंदन। नितिन जी के मार्गदर्शन की आवश्यकता हम सबको हमेशा रहती ही है, और उमाशंकर जी ने भी बहुत प्रिसाइजली लेकिन बहुत इम्पोर्टेंट सभी बातें कही हैं। विशेष तौर से पिछले 12 सालों में हाईवेज के पॉइंट ऑफ व्यू से देखा जाए तो हमने लगभग 60,000 किलोमीटर के हाईवेज तैयार किए हैं, और वो आज वर्ल्ड क्लास हाईवेज हैं, इसमें कोई दो राय नहीं है। चाहे उसमें हमारी रेजिलेंस की बात हो, टनल्स की बात हो, ब्रिजेस की बात हो, और विशेष तौर से जो ग्रीनफील्ड हाईवेज तैयार किए हैं, उससे टाइम के साथ साथ इकोनॉमी के ऊपर भी इम्पैक्ट आता है। आज आप सब लोग यहाँ पर इस कॉन्फ्रेंस में लैंडस्लाइड मिटिगेशन के इश्यूज पर सारा दिन के डेलिब्रेशंस करेंगे। मेरे को बहुत ज़्यादा कुछ इसमें अभी कहने के लिए नहीं है, मैं खुद भी इसको अंडरस्टैंड करने की कोशिश करता रहता हूँ, लेकिन वर्ल्ड की जो बेस्ट प्रैक्टिसेस हैं, आज हम बहुत छोटी छोटी कंट्रीज़ में भी देखते हैं कि जिनकी पॉपुलेशन भी बहुत कम है और जिनका इकोनॉमिकल स्ट्रक्चर भी बहुत ज़्यादा अच्छा नहीं है, बट उनके यहाँ पर जो बेस्ट प्रैक्टिसेस है, विशेष तौर से जो हिली रीजन है, जो डिफ़िकल्ट टेरेन है, वहाँ पर बहुत अच्छा दिखाई भी देता है और वो रिजिलेंट भी है। हिली टेरेन्स में, हिमालयाज़ का जो जियोलॉजिकल स्ट्रक्चर है, जो उनका हिमालयंस का जो नेचर है, उस नेचर में रोड्स को बना के सस्टेन करना बहुत मुश्किल काम है। ये बात समझ में आती है, हिमाचल हो या उत्तराखंड हो, उधर जम्मू कश्मीर की तरफ भी, लेकिन हमारे विभाग के द्वारा उसको लगातार ये प्रयास करना कि वो लॉन्ग लास्टिंग चले, उसमें सबसे ज़्यादा इम्पोर्टेंट आदरणीय नितिन जी हमेशा बोलते हैं कि जब हम उसका डीपीआर तैयार करते हैं, उस समय उसको हम कितना फ्यूचरिस्टिक देख पाते हैं, ये सबसे ज़्यादा महत्वपूर्ण लगता है। और जिस एरिया में हम अपना हाईवे हिली एरियाज़ में बनाने जा रहे हैं, उसका पिछले 20, 25, 30 साल का क्या उस एरिया का नेचर है, और ग्लोबल वार्मिंग के कारण या एक्सेसिव रेन्स के कारण या अन्य नेचुरल चीज़ें जो कि किस समय आएंगी, क्या आएंगी, इसके बारे में बहुत ज़्यादा समझ पाना भी मुश्किल होता है, लेकिन उसको ओवरसी करके उसके अकॉर्डिंग हम अपनी प्लानिंग करते हैं डीपीआर में, वो बहुत महत्वपूर्ण है। समटाइम्स हम ऑर्थोडॉक्स सिस्टम ऑफ वर्किंग में चले जाते हैं, लेकिन आउट ऑफ द बॉक्स सोचना भी बहुत बार बहुत फ़ायदेमंद रहता है। जैसे अभी कुल्लू मनाली की बात उमाशंकर जी ने भी कही, वहाँ पर ब्यास का फ्लो और ब्यास का जो रूट है, उसमें हमारा जो कुल्लू मनाली है वो सारा ब्यास के साथ साथ चलता है। अभी पीछे एक मीटिंग में भी ये बात आई कि ऑल्टरनेटिव रूट के बारे में भी सोचना चाहिए, लेकिन मैं ऐसा मानता हूँ कि जो प्रेवलेंट नेचुरल रिसोर्सेज हैं, जो प्रेवलेंट नेचर है, उसको हम किस तरह से बेस्ट अपनी प्रैक्टिसेस के अकॉर्डिंग वहाँ पर अपनी रोड्स को डेवलप कर पाते हैं, और फिर मिटिगेट करना, लैंडस्लाइड्स को ओवरसी करके उसको अकॉर्डिंगली उसके लिए मेजर्स को डिसाइड करना और इम्प्लीमेंट करना, ये बहुत महत्वपूर्ण है। वायनाड का भी जो एक्सीडेंट है वो बहुत बड़ा एक्सीडेंट रहा। आप लोगों के डेलिब्रेशंस आज सारा दिन रहने वाले हैं, और मैं ऐसा मानता हूं कि जो बेस्ट प्रैक्टिसेस ग्लोबली हैं और भारत के अंदर इतना पोटेंशियल है, चाहे वो एकेडमिया की बात करेंगे, चाहे हम इंफ्रास्ट्रक्चर के डेवलपमेंट की बात करेंगे, कि हम अपनी डेलिब्रेशंस के अकॉर्डिंग जो इंडियन प्रैक्टिसेस हैं उनको हम ग्लोबल बेस्ट प्रैक्टिसेस में कन्वर्ट कर सकें, ये ज़्यादा इम्पोर्टेंट मुझे लगता है। हर फील्ड में आदरणीय नरेंद्र मोदी जी के विज़न से भारत आज बेस्ट, चाहे वो इकोनॉमिक फील्ड की बात करें तो चौथी बड़ी अर्थव्यवस्था हम बन चुके हैं, तीसरी की तरफ हम अग्रसर हैं। रिसोर्सेज की कोई कमी नहीं है, इंटेलेक्ट की कोई कमी नहीं है। ज़रूरत इस बात की है कि हम उसको कलेक्टिवली डेलिब्रेट करके उसको बेस्ट प्रैक्टिसेस को इम्प्लीमेंट कर सकें और डिज़ास्टर्स या जो भी नेचुरल कैलेमिटीज़ हैं उसको पहले से व्यू कर सकें और उसके अकॉर्डिंग हम काम कर सकें। मुझे लगता है कि मेरे द्वारा इतना ही कहना काफ़ी है, क्योंकि यहाँ पर सभी तरह के एक्सपर्ट्स बैठे हैं जो कि नेचुरली और ऑब्वियसली मेरे से बहुत ज़्यादा एक्सपर्ट्स हैं। उनको मैं ज्ञान दूँ ये मुझे ठीक नहीं लगता है, क्योंकि मेरे पास उतना ज्ञान है भी नहीं। पर हाँ, मैं नितिन जी को सुनने के लिए ज़रूर आया हूँ कि उनका इंसाइट हमेशा हम सब के लिए बहुत यूज़फुल रहती है। बहुत बहुत धन्यवाद, आप सबको बहुत बहुत शुभकामनाएं।
Thank you, Honorable Minister, for your insightful address and gracious presence. With due respect, may I now invite our esteemed guest of honor, Honorable Minister of State, Road Transport and Highways, Shri Ajay Tamta ji, to kindly share his valuable thoughts with us. Let's extend a very warm welcome to him.
आज की इस बहुत ही महत्वपूर्ण वर्कशॉप में लगातार रोड नेटवर्क को पूरे देश भर के अंदर, बॉर्डर एरिया के अंदर, पहाड़ी क्षेत्र के अंदर आप सबके मार्गदर्शन से लगातार वहाँ तक हमने सारे टारगेट पूरे किए हैं बॉर्डर तक के। ऐसे आदरणीय हम सबके मार्गदर्शन नितिन गडकरी जी, मेरे सहयोगी साथी आदरणीय हर्ष जी, हमारे सेक्रेटरी सर, हमारे NHEIDCL के MD सर, हमारे DG रोड, हमारे सुदीप सर, और यहाँ पर उपस्थित क्योंकि IIT रुड़की, IIT दिल्ली और सभी हमारे TSDC और भी जो कंपनियां हैं जो ख़ास तौर पर लैंडस्लाइड के रूप में लगातार लंबे वर्ष से काम कर रही हैं, ऐसे सभी प्रतिनिधिगण। आज की इस बैठक में मैं ये कह सकता हूँ, चूँकि एक प्रदेश से मैं स्वयं ही आता हूँ, उत्तराखंड, और इसलिए उत्तराखंड, हिमाचल और नॉर्थ ईस्ट के भी अगर हम लें तो ज़्यादा बोल सकते हैं सिक्किम, नागालैंड और अरुणाचल, इन सारी जगहों में ही लैंडस्लाइड की समस्या हर वर्ष ही आती है। और आप सबके ध्यान में ही है कि 2013 में केदारनाथ की जो घटना हुई उसमें हमारी पूरी रोड नेटवर्क वॉश आउट हो गया और कोई भी रोड कनेक्टिविटी नहीं रही। और इधर हम इस तरह तो आए तो हमारे पिथौरागढ़ के जो कैलाश मानसरोवर को, आदि कैलाश को जो रोड जाता है टनकपुर के आगे, उस सारा का सारा रोड भी वॉश आउट हो गया था। सौभाग्य से आदरणीय नितिन गडकरी जी के मार्गदर्शन में कि किसी प्रकार से दोबारा से 4 धाम रोड नेटवर्क कनेक्टिविटी हो और ऑल वेदर रोड का काम शुरू हो, वो आपके मार्गदर्शन में 2017 में देहरादून में आपके गाइडेंस में माननीय प्रधानमंत्री जी ने उसकी शुरुआत कर आज हम सब बड़े सौभाग्यशाली हैं कि पूरे 4 धाम की रोड नेटवर्क कनेक्टिविटी बहुत बेहतर है। वर्षों से हम लोग सोचते थे कि भाई लिपू लेक, चाइना के बॉर्डर तक, चाइना का उधर का जो गांव है वो तकलाकोट है, वहाँ की उनकी बहुत अच्छी रोड है, मगर हमारी रोड हम बहुत आगे तक नहीं थी। तब अब अगर हम जाते भी तो वो बिल्कुल सिंगल रोड थी, बहुत कठिन पहाड़ थे। वहाँ पर भी रोड कैसे पहुँचे करके लगातार मॉनिटरिंग, क्योंकि मैं तब मंत्री था टेक्सटाइल का, तो आदरणीय गडकरी जी हर बार बैठक लेकर के कि कैसे करके हमें लिपू लेक तक रोड ले जानी, जबकि वहाँ की पहाड़ियाँ बहुत ही स्लाइडिंग जोन वाली, बहुत सारे लोगों की जानें भी गई उसमें। हम सबका बड़ा सौभाग्य है कि आज सारी रोड नेटवर्क ठीक है, मगर समय समय पर जिस चर्चा के लिए हम लगातार आज बैठे हैं, ये लैंडस्लाइड की घटनाएं, ये लैंडस्लाइड की घटनाओं पर हम लोगों को भी बहुत ध्यान देना चाहिए। अभी मैं सेक्रेटरी सर से बात कर रहा था कि अगर हम कभी किन्नौर की तरफ जाते हैं हिमाचल में, तो वहाँ की पहाड़ी में एक जगह पर ऐसा रॉक है कि ऊपर भी रॉक है और नीचे भी रॉक है। रॉक में हम गाड़ी में चलते ही हैं और कहीं कहीं पर ट्रक अगर ज़्यादा ऊंचे हो तो फंस जाते हैं, और वो पहाड़ वैसा ही है और वहाँ से ट्रैफिक लगातार चलता है। कोई ऊपर से पत्थर गिरता भी है तो पहाड़ बाहर निकल जाता है। तो सबसे पहले, क्योंकि आप सब लोग बहुत सारी मेहनत करते ही हैं, हमको ये देखने की ज़रूरत है कि अगर हम कोई DPR भी बना रहे हैं, उस DPR में, क्योंकि एक पहाड़ से आप दूसरे पहाड़ की तरफ जाते हैं तो पहाड़ का जो चेंज है, वो पहाड़, हर एक पहाड़ एक सा नहीं होता, उसके अंदर का मटेरियल अलग अलग होता है, कहीं डोलामाइट है, मैग्नेसाइट है, या सॉफ्ट रॉक है, मिक्स रॉक है। तो उस पर रोड डालने से पहले नया रोड, फ्रेश रोड में हमको विचार करना चाहिए कि हम किस रॉक पे जा रहे हैं, उसकी स्टडी बहुत ज़रूरी है। सेकेंड, अगर किसी को हम सिंगल रोड को 2 लेन करते हैं या उसको चौड़ा करते हैं, तो चौड़ा करते समय इस बात का भी ध्यान देना है, क्योंकि हम पहाड़ी के बुनियाद को काटते हैं, बेस को काटते हैं, जिस पर पूरा पहाड़ रुका होता है। वो सेटल्ड पहाड़ है, वर्षों से सेटल है वो। तो इसलिए क्या है कि उसको जब हम काटते हैं तो ये देखना चाहिए कि हम वैली साइड में कुछ सपोर्ट सिस्टम का इस्तेमाल करके हिल साइड में कम से कम काटें। तो उससे क्या है कि हमको स्लाइडिंग जोन को कम बार बार आना मुश्किल रहेगा, क्योंकि जितने की हम रोड बनाते हैं उससे ज़्यादा जगह जगह पे जो पैच निकलते हैं उस पर हमको बहुत पैसा बर्बाद होता है। तो इसको हमको देखने की ज़रूरत है, अगर इस पर हम ध्यान दें, क्योंकि मेरा खुद का इसमें बहुत सारा अनुभव है। आज भी मैं अभी जाने वाला हूँ, तो मैं क्वारब में जाने वाला हूँ। क्वारब वाला रोड लगातार पिछले 3 साल से सभी के ध्यान में ही है, वहाँ के ऑफिसर्स को भी मालूम है ही। तो क्वारब है और स्वाला है, ये 2 पॉइंट ऐसे, और उधर गढ़वाल में पागल नाला है। तो ये 3-4 वैली हमारी ऐसी हैं कि वहाँ पर हमारे को हमेशा समस्या ही आनी है। और एक बार तो ये है कि हम बिना स्टडी करे हुए भी बहुत सारी चीज़ों को कर लेते हैं। जैसा कि आपने देखा है कि स्वाला में हमारा पैसा पूरा लग गया, पिथौरागढ़ के दिल्ली बैंड में पूरा पैसा लग गया, और जब हमने पूरी टेक्निकल टीम के साथ उसका ट्रीटमेंट कर दिया, तो वो क्यों आया? क्या है कि हम लोग खाली बाहर देख के उसका ट्रीटमेंट करते थे, उसका सॉइल टेस्ट नहीं करते, उस पहाड़ी का वास्तव में सिस्टम क्या है उसको हमको देखना चाहिए। कहीं-कहीं पर हम क्लम्पिंग कर देते हैं। अब क्लम्पिंग जब करते हैं तो इस बात का ध्यान नहीं देते, हमारे बाहर से ही देख के बता देते भई क्लम्प कर दिया, अब रुक जाएगा, वो रुकने वाला नहीं है। उस क्लम्प के कारण से जो उसके अंदर वो जो पहाड़, सॉफ्ट पहाड़ है, वो और बड़ा बल्क लेकर आता है। इसलिए वो पहाड़ हमारे लिए एक समस्या बन जाती है। तो इसलिए क्या है, उसको स्टडी करना चाहिए। कभी-कभी हम वैली साइड में भी जब दीवार देते हैं, नीचे से बेस उठाते हैं, तो ये देखते नहीं कि वास्तव में ओरिजिनल बेस है या नहीं है। इसको भी हमको देखना ही है। आपदाएँ तो हमारी रोडों को बहुत बड़ा नुकसान करती हैं, और हर साल बादल फटने की घटनाएँ ही हैं। इस बार हरसिल में भी घटना घटी है। मगर सुप्रीम कोर्ट की टीम ने और हमारे सब लोगों ने, जो हमारी रोड की चौड़ाई है वो 12 से 10 मीटर ऐसा भी कहीं-कहीं करी है। मगर कहीं पर मुझे मुझे ऐसा लगता है कि हम जब नए रोड बनाते हैं तो पुराने एग्जिस्टिंग रोड, क्योंकि वो सेटल रोड है, उसके ऊपर हम उसी रोड को चौड़ा करने के बजाय उसके ऊपर भी एक रोड बनाया जा सकता है पैरेलल, जिसकी ट्रैफिक हम एक तरफ को चलाएं और एक तरफ को ले जाएं, जिससे कि हमारा नुकसान कम होगा और पहाड़ का भी नुकसान कम होगा। क्योंकि जो पहाड़ की जो सिस्टम है, जो उसका नेचुरल सेटल है, वो सीढ़ीदार है। अगर हम सीढ़ीदार करते हैं तो पूरी बसावट बसी हुई है, पूरा उत्तराखंड बसा ही है, हिमाचल बसा ही है, नॉर्थ ईस्ट पे ही बसा ही है, कि हम सीढ़ीदार वाले पैटर्न पे जाएंगे तो लंबे समय तक हम रोड का इस्तेमाल कर पाएंगे, और स्लाइडिंग जोन के लिए भी हमारी समस्या का बहुत समाधान होगा। आज के इस वर्कशॉप में, चूँकि आप सब लोग काफ़ी मेहनत के साथ इस वर्कशॉप को कर रहे हैं, और ये कि बड़ी समस्या है, ये देश का भी नुकसान होता है इससे, पैसे का, क्योंकि रोड बनाने के बार-बार गिरने का मतलब है कि बड़ा नुकसान है। मगर अभी हमारी मंत्रालय ने गडकरी जी के मार्गदर्शन में एक लिया है गाइडेंस, कि रोड बनाने के टाइम पर ही डीपीआर में ही हम स्लोप प्रोटेक्शन को भी जोड़ेंगे, जिससे कि आने वाले समय के अंदर जो दोबारा हमको पैसा इन्वेस्टमेंट करना होता है वो नहीं करना पड़ेगा। और मुझे लगता है कि आने वाले समय के अंदर हमको ये बहुत बड़ी सुविधा मिलेंगी, क्योंकि हमको हिमालय के बॉर्डर एरिया के अंदर, क्योंकि सैनिकों के लिए भी बहुत ज़रूरी कि रोड नेटवर्क अच्छा बने, तो उसके और डेंजर जोन में हम जाने वाले हैं। आने वाले समय में जो नए रोड नेटवर्क हैं उस पर हम इस टेक्नोलॉजी का इस्तेमाल करें, इतना ही मेरा कहना है। बहुत बहुत धन्यवाद।
Thank you, Honorable Minister, for sharing your valuable perspective with us. And now, ladies and gentlemen, we arrive at the most awaited moment of this inaugural session. It is my great honor and privilege to invite on the dais our esteemed chief guest, Shri Nitin Jairam Gadkari ji, Honorable Minister of Road Transport and Highways, to deliver the special address. Sir, your visionary leadership continues to inspire the nation's infrastructure growth, and we are truly honored to hear from you today.
मंत्रिमंडल में मेरे सहयोगी आदरणीय अजय टमटा जी, हर्ष मल्होत्रा जी, हमारे विभाग के सचिव उमाशंकर जी, हमारे डीजी राजावत जी, NHIDCL के MD कृष्ण कुमार जी, सभी डिस्टिंग्विश्ड गेस्ट, इनवाइटीज और उपस्थित मित्रों, भाई और बहनों, सबसे पहले मैं विशेष रूप से आज के इस कार्यक्रम के आयोजन के लिए विभाग के सभी कंसर्निंग अधिकारियों को हृदय से बहुत बहुत धन्यवाद दूंगा, उनका अभिनंदन करूंगा, क्योंकि ये जटिल विषय पर एक्सपर्ट लोगों को बुलाकर हम इसका सॉल्यूशन कैसे प्रोवाइड करें, इसके ऊपर दिन भर अध्ययन करके एक क्लैरिटी, अच्छा सॉल्यूशन जो टेक्निकली सक्सेसफुल है वो हम सबको मिलेगा और जिसके कारण ये कठिन समस्याओं के ऊपर हम मात कर सकेंगे। मैं ये मानता हूँ कि लैंडस्लाइड मिटिगेशन के जो मेजर्स हैं और हिल एरिया में विशेष रूप से जो है वो कठिन काम है, कठिन है, इसमें कोई दुमत नहीं है, पर ये असंभव नहीं है, संभव है। केवल इसके लिए हमें टेक्निकली भी और हमारे सिस्टम पे भी हमें सोचने की, विचार करने की, निर्णय करने की प्रक्रिया को बहुत गंभीरता से सोचकर इसका इम्प्लीमेंटेशन करना होगा। टेक्निकल बातों में अभी जैसे अजय जी ने कुछ बातें बताई, क्योंकि वो उस क्षेत्र से हैं, मुझे तो टेक्निकली कोई इतनी जानकारी नहीं है, पर एक बात ऐसी है कि जो मंत्री बनता है वो सब विषयों का एक्सपर्ट है, ऐसा आपको चाहे समझे या ना समझे मानना पड़ता है, क्योंकि बॉस इज ऑलवेज करेक्ट। तो एक अच्छी लाइट मूड में एक विनोद था कि जो मेरिट में पास हुआ वो IAS ऑफिसर हुआ, जो फर्स्ट क्लास में पास हुआ वो चीफ इंजीनियर हुआ, और जो 3 बार फेल हुआ वो मिनिस्टर हुआ। और हमारे यहाँ महाराष्ट्र में एक कैबिनेट सेक्रेटरी थे, बहुत कैपेबल थे वो कुछ भी बातों के लिए सर कहते थे, तो सर, तो मैं कहता था हम आपको कुछ नाराज भी होते तो भी आप सर ही करते हो। तो उन्होंने कहा कि देखो ये सिस्टम में जो मिनिस्टर है वो जो कहेगी वो बात हमारे लिए वो बॉस है, पर यह सच्चाई नहीं है। पहली बात तो एक इस विषय के बारे में मैं एक टेक्निकल भाषा में नहीं जाऊंगा। एक बात ये हो जाती है कि हायर अथॉरिटी में जो काम करता है वो अपने जूनियर्स को उनकी सुझाव को ज़्यादा महत्व नहीं देता। ये भी एक बहुत बड़ा जातिवाद कभी कभी सिस्टम में नेचुरली तैयार हो जाता है, और इसलिए जो अनेक बातें ध्यान में आती है उसके बाद में भी छोटा आदमी जब कहता है तो उसको सीरियसली नहीं लिया जाता। तो पहली बात तो ऐसे कि जो डिफ़िकल्ट टास्क है उसको सॉल्व करने के लिए मैनेजमेंट का सबसे अच्छा कंसेप्ट है टीम कंसेप्ट। हमारे सिस्टम में एक एक फाइल अलग अलग लोगों के पास जाती है, वो अलग अलग व्यूज़ अपने लिखते रहते हैं। इसके बजाय सब लोग मिलकर एक बार अपने व्यूज़ रखें, उसके डिटेल में जाए और मिलकर एक राय बनाए और फिर उसको फाइनल करें, तो नेचुरली हमारी डिसीजन मेकिंग प्रोसेस ज़्यादा अच्छी होती है। तो पहला प्रॉब्लम ये है कि इसके पहले क्या हुआ उसमें जाने में मतलब नहीं है, पर उसको समझना इसलिए आवश्यक है कि भूतकाल में जो गलतियां हमने की वो वर्तमान में काल में हम उसको समझे, इसलिए ताकि भविष्य काल में वो गलतियों को रिपीट ना करें। क्योंकि सबसे पहले पिछले अनेक सालों से हमारी जो DPR बनने की प्रोसेस थी उसमें इन सब बातों को जितना गंभीरता से सोचना चाहिए था उतना सोचा नहीं गया, और इसका बड़ा नुकसान भी हुआ। ये कुल्लू से मनाली का रास्ता है, उसका 4,000 करोड़ हमने खर्चा किए, 4-4,500 करोड़ खर्चा किए, और आज लगभग हमारी 60-70% अमाउंट पानी में गई। नदी भी बीच में बहती है, दोनों बाजू में रोड है, कठिनाइयाँ है, पर कठिनाइयों को समझकर उसके प्लानिंग में उस समय और गंभीरता से सोचकर सलाह लेकर अगर हम कुछ सोचते जो आज कर रहे हैं, अगर वो उस समय कर सकते हैं तो शायद हम हमारा नुकसान बचा सकते हैं। अब प्रॉब्लम यह है कि जो सस्ते में आया, लोएस्ट आया, उसको हमने डीपीआर बनाने के लिए दिया। डीपीआर वालों ने सॉइल इंस्पेक्शन कितना किया नहीं किया, उसने हमको एक डीपीआर बना के दिया। फिर डीपीआर हमारी बाइबल भगवत गीता बन गई और फिर उसके ऊपर हमने टेंडर निकाले। सामने हमको दिख रहा था, पर जो कुछ एक बार लिख गया वो वैसे ही कंटिन्यू होते हुए आगे चले गया। और जब आजकल ये बाढ़ के कारण, बादल फटने के कारण समस्या हुई तो वो कोलैप्स हो गया। अब ये इसका कारण जो है, इस सब सिस्टम में मैं उन कुछ बातों के सुझाव आपको देना चाहूँगा। जो कुछ ये काम करने का मुझे अनुभव मिला, उसमें सबसे पहले एक अच्छी बात मेरे ध्यान में आई कि जब तक आप साइट पर नहीं जाते तब तक आपको बातें समझ में नहीं आती। और हमारे यहाँ इवन मंत्री करके भी मैं जब किसी रोड पर चलता हूँ तब मेरे समझ में आता है कि मैं टेक्निकल व्यक्ति नहीं हूँ, फिर भी बहुत सी दिक्कतें, हमारी कमियाँ समझ में आती है। तो पहली बात यह है कि जो अथॉरिटी है, चाहे NHIDCL में हो, NHI में हो, मिनिस्ट्री में हो, वो ऐसे इसमें उन स्पॉट पर उन्होंने जाना चाहिए। स्पॉट पर जाने के बाद कंसर्निंग लोगों को वहाँ बुलाना चाहिए और वहाँ मीटिंग करनी चाहिए कि ये क्या समस्या है। हमारे सब निर्णय जो होते हैं वो हम मंत्रालय के चेंबर में होते हैं, और जो ज़मीन पर होता है वो वहाँ तकलीफ उसको समझ में आती है, क्योंकि वहाँ पब्लिक की नाराज़गी होती है, पब्लिक का फीडबैक मिलता है, पर उनका आवाज़ मंत्रालय तक नहीं पहुँचता। वो जब वहाँ के एक्सपीरियंस पर अगर कोई डिज़ाइन करके बोलता है ऐसा करो, तो मंत्रालय बोलता है डिज़ाइन काटो, इसका पैसा कम करो, क्योंकि नेचुरली वो थियोरेटिकल जो पार्ट है कागज़ पर लिखा हुआ वो जांच रहा है। जो प्रैक्टिकल वहाँ की स्थिति है वो स्वाभाविक रूप से वहाँ गए ही नहीं, तो उसका पता नहीं है। तो एग्जैक्ट जब निदान करना होता है डॉक्टर को भी मेडिकल साइंस में, तो कोई भी निदान करने के पहले उसका डायग्नोसिस ज़्यादा इम्पोर्टेंट होता है। तो मुझे लगता है कि ये जो निदान करना है, इस प्रोसेस को हमको मजबूत करना होगा। दूसरी इम्पोर्टेंट चीज़ जो है वो ओनरशिप की है। अभी धीरे धीरे, आप लोगों का भी दोष नहीं है, सिस्टम ही ऐसी है कि ऊपर का अधिकारी जैसे मुंडी हिलाता वैसे नीचे भी अपने हिलाते रहते, क्योंकि वो सिस्टम ही ऐसी है। मैं NCC में था तो हमें हमारे ऑफिसर ने कहा था कि तुम जाके खड़े रहो, सावधान में सैल्यूट मारो। तो जब पूछेगा व्हाट्स योर नेम, तो बताओ सर माय नेम इज सो एंड सो। तो हमारे में से एक में गया, उसने कड़क सैल्यूट मारा और उसको पूछा व्हाट्स योर नेम, उसने कहा माय नेम इज सो एंड सो। तो ये सो एंड सो इतने बढ़ गए कि IIT इंजीनियरिंग कॉलेज में मेरिट में पास हुए छात्र सर्विस में आए, पर धीरे धीरे बेचारे परिस्थिति के कारण हो, विवशता के कारण हो, सीनियर के कारण हो, या उसका ओनरशिप भी ख़त्म हो गई। और वो जो ऊपर वाला बोलता है वो करो। अच्छा, ऊपर वाले को, उसके मत को अगर कॉन्ट्रडिक्ट करेंगे तो उसको डर लगता है कि वो क्या लगेगा उसको। तो जो सीनियर है उन्होंने अपने जूनियर्स को बोलने के लिए इनकरेज करना चाहिए। और हमारे पास हमारी कुछ गलती होगी तो उसको हम रेक्टिफाई, मैं कह रहा हूँ वही सही है, ऐसा नहीं है। अगर ये गलती है मेरी तो मैं सुधारूंगा। तो मुझे लगता है कि ये थिंक टुगेदर, वर्क टुगेदर एंड कम टुगेदर, इसमें से भी आपके सामने बहुत सी प्रॉब्लम जो है वो रिजॉल्व होंगे और सॉल्व होंगे। ओनरशिप की बात जो है वो हमारी सबसे बड़ी समस्या है। मैं अभी आजकल छोटे छोटे प्रोजेक्ट की रिपोर्ट करता हूँ, और मैं जब उस प्रोजेक्ट का जब मैं पूछता हूँ कि क्या हुआ क्या नहीं हुआ, तो मुझे एक ध्यान में आया कि मैंने बहुत सेक्रेटरी मेरे साथ आए थे, पर अभी जो सेक्रेटरी है उनको जब मैं पूछता हूँ कि ये केरल का ये फलाना रोड है, तो वो तुरंत वो नाम, किलोमीटर, प्रॉब्लम क्या हुआ था, डिटेल बताते हैं। और अनेक PD और RO को जब पूछता हूँ तो बताते मैं देख कर बताता हूँ। ये जो देख कर बताने वाले, इनकी ओनरशिप कम है, और जिसको पूरा मालूम है वो बराबर जवाब देता है, क्योंकि वो उसके साथ उसकी कमिटमेंट है। ये जो ओनरशिप का अभाव है, ये भी हमारी एक समस्या है। और इसलिए मैं आपसे ये अनुरोध करूँगा कि मैं मंत्री करके मेरी भी जिम्मेदारी है, सेक्रेटरी, मेंबर, पीडी, आरओ, आप सबकी जिम्मेदारी है। तो कोई चीज़ परफेक्ट बने, कोई फॉल्ट उसमें ना रहे, इसके बारे में हम सब की जिम्मेदारी है। और जहाँ जहाँ आप हैं वहाँ आपकी जिम्मेदारी है। आप पोस्टमैन नहीं हो कि कागज दिया, लिया, पहुँचाया, उधर से लिया, इधर पहुँचाया, ऐसा नहीं है। आपको यू आर सोल्यूशन प्रोवाइडर, यू आर डिसीजन मेकर्स। फुटबॉल जैसे केवल इधर की उधर फाइल घूमती रहेगी, और आप जो लॉजिकल, लीगल, इथिकल, डोंट ब्रेक द लॉ, बेंड द लॉ अप टू द लास्ट लिमिट ऑफ द ब्रेकिंग पॉइंट एंड जस्ट फाइंड आउट द सोल्यूशन। हमें हमारे प्रोजेक्ट पूरे करने हैं, केवल टर्मिनेट करना, नोटिसेस देना, प्रोजेक्ट बंद करना, इससे नहीं होगा। और प्रोजेक्ट पूरे करने के लिए उसकी समस्या क्या है उसको कॉन्ट्रैक्टर की समझना होगा, और वो समस्या अगर सही है तो सुलझाना होगा। और हमने सब समस्या सुलझाने के बाद भी वो काम नहीं करता है तो उसके ऊपर कार्रवाई करनी होगी। कहीं ना कहीं हमारी सिस्टम में हमें पॉजिटिविटी के साथ, ट्रांसपेरेंसी के साथ और टाइम बाउंड डिसीजन मेकिंग प्रोसेस के साथ, ओनरशिप के साथ हमारी प्रोजेक्ट को डील करना होगा। जो बात मैंने इस पर्टिकुलरली ये लैंडस्लाइड्स और इसमें जो पुराने समय देखी कि जो जो गलतियां होती थी वो रिपीटेडली ऊपर आते रही, वैसे ही चलता गया। सबसे पहला इंसिडेंट हुआ जब चिब्बर साहब सेक्रेटरी थे, और जब बद्रीनाथ केदारनाथ के ये पूरे 4 धाम के रोड पर हादसा हुआ, तो बात आई डीपीआर ठीक नहीं, और दुर्भाग्य से अंग्रेजों के काल में जहाँ से नदी बहती उसके बाजू में रोड, जहाँ रोड और नदी थी वहाँ गांव। तो सिचुएशन हमारे हाथ में तो नहीं है बदलना। तो स्वाभाविक रूप से बाढ़ के कारण रोड उखड़ जाता था, उसमें कभी बादल फट जाते थे, लोग मरते थे। अब कुछ चीज़ें हमारे हाथ में थी, कुछ चीज़ें हमारे हाथ में नहीं थी, पर हमें जो हाथ में नहीं है उसका भी सोल्यूशन निकालना है, और हमें इसको पूरी तरह उस प्रॉब्लम को सॉल्व करना है। तो इसके लिए आपकी ओनरशिप, डिसीजन मेकिंग प्रोसेस एंड कमिटमेंट, मुझे लगता है जब तक, जैसे मैं अनेक विभागों में मंत्री था, अभी कोई आता है तो मैं बोलता हूँ मेरा अभी तो संबंध नहीं है इसके साथ, आप उनके साथ मिलिए, तो वो मुझे याद करके देते कि नहीं आपने उस समय ऐसा किया था, वैसा किया था, ये किया था, उसका ये फ़ायदा हुआ। कल मैं एक्सपोर्ट करने वाले लोगों के सत्कार के प्रोग्राम में गया था, तो वो मुझे बता रहे थे, एक व्यक्ति मुझे मिला कि मेरा एक्सपोर्ट 12,000 करोड़ का है। तो मैंने कहा अच्छी बात है। तो बोले ये आपके कारण हुआ, मतलब मेरे कारण कैसे हुआ? तो उसने कहा आप जब एमएसएमई के मंत्री थे तो मैं अपनी समस्याओं को लेकर आपके पास आया था, और आपने फटाफट जो जो निर्णय करके दिए, उसके बाद इसका मुझे इतना फ़ायदा हुआ कि मैं 350-400 करोड़ की कंपनी को आज 12,000 करोड़ तक ले गया। तो कहीं ना कहीं हमें जो प्रॉब्लम्स सामने आते हैं उसको सॉल्व करना है। डॉजिंग मत करिए, फुटबॉल मत खेलिए, हमें जिम्मेदारी है। जो अधिकारी ऐसा है, अगर आपको, मैं एक अधिकारी को मैंने कहा था कि इफ़ यू डोंट वांट टू टेक द डिसीजन, व्हाई आर यू आस्किंग फॉर प्रमोशन? तुम अगर प्रमोशन लेकर बड़े अधिकारी बनना चाहते हो तो डिसीजन करो, फाइल पे लिखो ना कि ये सही है कि गलत है, करना है कि नहीं करना है। जो भी आपका नीचे का व्यक्ति उसको ओवर रूल करना है तो करो, अगर आपका कॉन्शियस परमिट करता है तो। पर वो करना ही नहीं, मुझे फाइल घूमने दो, ऐसा नहीं होगा। तो कहीं ना कहीं इसमें इस प्रकार की अड़चनें आई, और अड़चनों में बहुत बार विशेष रूप से एक अच्छा फ़ायदा हुआ कि मैं डावोस गया था, और डावोस के बाद मुझे स्विट्ज़रलैंड बहुत घूमने का मौका मिला। ऑस्ट्रिया और स्विट्ज़रलैंड में मुझे एक बात देखने के लिए मिली कि हिमालयन टेरिन और वो बिल्कुल सेम है, और उनकी परिस्थितियाँ भी हमारे परिस्थितियाँ जैसी है। और ध्यान में आया कि उनके पास कोई लैंडस्लाइड नहीं होती, उनके यहाँ कोई समस्या नहीं है, कोई एक्सीडेंट्स नहीं होते, कोई लोग नहीं मरते। तब मुझे ध्यान में आया कि अगर ये कर सकते तो हम क्यों नहीं कर सकते। और उसके बाद में उसमें से बहुत सी कंपनियां भी हमको भी इंडिया में आई, वो मेक इन इंडिया कर रही है, हमारे लोग भी अच्छा काम कर रहे हैं, हमारे इंस्टीट्यूट भी अच्छे काम कर रहे हैं, और गवर्नमेंट इंस्टीट्यूट भी काम कर रहे हैं। पर हमें इतना काम है कि वो इंस्टीट्यूट की भी मर्यादा है। सब काम टेरी वाले को देंगे तो उनके पास उतना तो स्टाफ चाहिए। तो हमको प्राइवेट सेक्टर में हमारे आईआईटीज़ को, प्राइवेट इंस्टीट्यूशंस को, प्राइवेट कंपनीज को भी कॉम्पिटिटिव बनाना पड़ेगा। और इसलिए ये सब करने के लिए जो बेस्ट प्रैक्टिसेस है उसको हम स्वीकार करें। मैं बिल्कुल अच्छी बात आपको बताता हूँ कि जो जो अच्छी चीज़ होती है उसको जब आप महसूस करते हो तो अपने मन में लाकर अगर वो अच्छी चीज़ अगर आप स्वीकारते हो तो यही अच्छा व्यक्ति बनने का सबसे अच्छा आसान तरीका है। मैं बहुत बार याद करके एक बात अक्सर बताता हूँ कि जिन लोगों को मैं बड़ा समझ रहा था उनके नज़दीक जाने के बाद पता चला कि वो बहुत छोटे हैं, और जिनको मैं छोटा समझ रहा था उनके नज़दीक जाने के बाद मुझे पता चला कि भाई छोटे नहीं, बहुत बड़े हैं। और इसलिए टेक्निक की अलग ही बात होती है। मैं क्रिकेट खेलता था और क्रिकेट में मेरी बड़ी एम्बिशन थी कि मैं अच्छा क्रिकेटर बनूं, तो बाद में मेरी लाइन बदल गई। तो मुझे मेरे समय वेस्ट इंडीज़ के प्लेयर रहते थे, ये लॉयड, रिचर्ड्स, ग्रिफिथ, आपको बड़े बड़े प्लेयर सोबर्स कहाँ हैं, तो बड़े बड़े हमारे वो एक प्रकार से आइकॉन थे। और वो 6-6 फुट ऊंचे रहते थे, ऐसे इतना ताकत इनका रहता था, मैं देखता था। तब मेरे मन में आया कि अच्छी बैटिंग करनी है तो जब तक मनगट मजबूत नहीं होगा, ये क्या खाते हैं, प्रोटीन कितना खाते हैं, मच्छी खाते हैं कि मटन खाते हैं, इनकी ताकत कैसी है, इनकी बॉडी कैसी है, ये बॉडी बिल्डिंग, मेरी लाइन सब उस लाइन पे जा रही थी। और अचानक मेरे लाइफ में 2 अच्छे इंसिडेंट हुए। आज योगा से दोनों मेरे अच्छे मित्र हैं, एक सुनील गावस्कर और दूसरे सचिन तेंदुलकर। तो सुनील गावस्कर जब मेरे घर पर आए तो मैंने उनको कहा कि सुनील जरा एक काम करो, आप दीवार पर खड़े रहो। बोले क्यों? मैं बोला, मुझे मेरी तसल्ली करनी है। जब खड़े रहे तो मेरे कंधे के नीचे कोई हाइट नहीं, कोई बॉडी नहीं, कोई मनगट मजबूत नहीं। सचिन तेंदुलकर को देखा, वो भी उससे भी ठिंगा, उसकी भी कोई हाइट नहीं, कोई ताकत नहीं। तब मेरे दिमाग में पहली बार आया कि मैं तो इनसे ऊंचाई में ऊंचा हूँ, ताकत में बड़ा हूँ। आजकल मैंने 46-47 केजी वजन कम किया है। आजकल मैं हेल्थ कॉन्शियस के पीछे समर्पित हूँ। सबसे इरेगुलर इनडिसिप्लिन मेरा आयुष्य था। अब 2 घंटे में रोज खा रहा हूँ, अभी क्या मालूम, पर मैं अपने ट्रेनर को बोलता हूँ, अब क्या मेरी उम्र भी नहीं है। तो वो जैकी श्रॉफ आए थे मेरे घर पर, तो वो क्या करते थे, दाल में घी डाल के दाल पीते थे। तो मैंने उसको बोला कि वो जो उसका लड़का है टाइगर श्रॉफ, वो भी दाल में घी डाल के खाता है, मैं भी खाऊंगा, मुझे मेरी बॉडी टाइगर श्रॉफ जैसी बना दो। अब वो संभव नहीं है। कभी कभी क्या होता है कि हम जो पकड़ के चलते हैं वो और एक्चुअल लाइफ में उसका संबंध नहीं होता। तो सुनील गावस्कर ने मुझे बताया कि नितिन जी, क्रिकेट इज़ नॉट ए गेम ऑफ स्ट्रेंथ, इट इज़ ए गेम ऑफ स्किल। और इसीलिए वो एंडी रॉबर्ट्स बाउंड्री से दौड़ते हुए आके इतना बड़ा बॉल डालता था और ये गिट्टा सुनील गावस्कर उसके बॉल कर छक्का मारता था, तो वो समझ में नहीं आता था। और इसलिए आज जो काम करना है वो देखो, लकड़ी तोड़ने वाले के शरीर से कितना भी पसीना निकले, वो दिन भर लकड़ी तोड़े, वो कभी पहलवान नहीं बनता। पहलवान वही बनता है वो 1 घंटा 2 घंटा बराबर जो करना चाहिए वो एक्सरसाइज करता वो बनता है। ये रफ का फेयर करके कोई ज़िंदगी नहीं बदलती। ये सरकारी कामों में आपका आधा टाइम रफ का फेयर करने में ही जाता है, खाया पिया कुछ नहीं, गिलास पड़ा हटना, बेकार के बेकार समय खराब होता है। इनपुट आउटपुट का हिसाब लगाओ कि क्या मिला उससे। मैं सबके लिए नहीं कह रहा हूँ, आप में से तो कोई ऐसे है ही नहीं। अगर योगा योग से कहीं भी मेरी टोपियाँ आपको फिट बैठी होगी तो समझ लो आपके लिए नहीं है, वो दूसरे अनुभव का मैं बता रहा हूँ। तो पहली बात, ये पूरे सब्जेक्ट को आप ओनरशिप में लाइए। ये मेरा देश है, ये मेरे देश की प्रॉपर्टी है, यहाँ रोड पर कोई मरना नहीं चाहिए, कोई हादसा होना नहीं चाहिए। मैं इसको एट एनी कॉस्ट मैं इसको अच्छा करूँगा, ये मेरी जिम्मेदारी है। अब ये छोटी सी बात अगर आपने तय की तो आपको ही कुछ सोल्यूशन मिल जाएंगे। और सोल्यूशन देने वाले अपने नीचे में भी लोग हैं, ऊपर में भी लोग हैं। और जो अच्छा है उससे सीख लो। देखो मैं आपको बता दूं, जो अच्छा है किसी में हो उसके ऊपर कोई उसका पेटेंट नहीं है। मैं बहुत बार आपको, अभी हमारे मेमू जी उस समय आए थे मुंबई में, रोड सेफ्टी का शूटिंग चल रहा था। तो शूटिंग चल रहा था तो अमिताभ बच्चन दिन भर थे। तो अमिताभ बच्चन का उस दिन रात को बेचारे गिर गए और उनके एक हेयर क्रैक भी आई थी, उनका हाथ बहुत दुख रहा था। तो उन्होंने 7:30-8 बजे वो कुणाल मेरे साथ प्राइवेट सेक्रेटरी उसको फ़ोन किया कि नितिन जी पहुँचे क्या मुंबई? बोले हाँ। तो बोले क्या हुआ? बोले कुछ नहीं हुआ। ठीक है, मैं कल आऊँगा। और पूरे दिन भर शाम को 7 बजे तक कंटिन्यूस वो शूटिंग कर रहे थे। और जब निकलते समय मैंने कहा कि मुझे पता चला आप गिर गए, आपका हाथ अच्छा नहीं है। बोले मैं यहीं से डॉक्टर के पास जा रहा हूँ। तो बोला आपका कोई फ्रैक्चर नहीं निकलेगा। तो जब वो गए तो मुझे रात को जब मैंने फ़ोन किया तो उन्होंने बताया कि इसमें फ्रैक्चर निकला है। पर कितनी कमिटमेंट में देखो कि उस अवस्था में वो व्यक्ति दिन भर शूटिंग करके काम कर रहा था, और उनके मन में पोस्टपोन करते तो क्या होता, हम चले जाते, इतना बड़ा कलाकार है। पर उसने कहा कि नहीं, मेरी कमिटमेंट, वो भी पैसे लेकर नहीं काम कर रहे थे, रोड सेफ्टी के कॉज के लिए काम कर रहे थे। दिन भर उनने काम किया। और फिर जब हम लोग काम में भी एक देखा कि छोटे 5वीं 7वीं के 2 लड़के जब ऊपर चढ़ते हुए आए तो मैं नीचे बैठ गया। तो मुझे लगा कि अब ये छोटे लड़के, हमने खड़ा होने की कोई ज़रूरत नहीं। वो खड़े हो गए, झुक कर उनको सलाम किया, और फिर मुझे संकोच हुआ, फिर मैं खड़ा हुआ। तो छोटे से छोटे आदमी को भी रिस्पेक्ट देकर बात करना, ये बात मैंने उनसे देखी। कोई भी छोटा आदमी आए, कितना भी छोटा हो, उसको रिस्पेक्ट देने का, तो वो छोटी छोटी बातें सीखने के लिए मिलती है। और इसलिए जो फॉरेन कंसल्टेंट है, अब हमारे यहाँ ऐसा होता है, विशेषता आपके यहाँ राजनीति में होता है कि मैं ही शायाना हूँ, क्योंकि लोगों ने चुन के दिया, हम मंत्री बन गए, तो हमको ही समझता है, बाकी किसी को नहीं समझता। ऐसा नहीं है। नो वन इज परफेक्ट एंड नो वन कैन क्लेम दैट ही इज परफेक्ट। उत्तम, अधिक उत्तम, सर्वोत्तम, अप टू इन्फिनिटी। और इसलिए मेरा आपसे एक रिक्वेस्ट है कि ये जितना कुछ आपका ब्रेनस्टॉर्म डिस्कशन हो रहा है, उसको आप एक इंडिपेंडेंट इम्पार्शियल व्यू से देखो। अगर हमारे में अच्छाई होगी, आपको लगता है, आपका कॉन्शियस कहता है कि ठीक है, चिंता मत करो। और अगर आपको लगता है कि कोई कमी है, तो उसको स्वीकार करो, और स्वीकार करके उसको एक्सेप्ट करो और उसको पूरा करो, ताकि किसी भी स्थिति में वी डोंट वांट टू कॉम्प्रोमाइज़। हम किसी भी हालत में 100% परफेक्शन की ओर ही जाए। हमारा काम लीक प्रूफ बने, ताकि हमारे देश में एक भी हादसा नहीं हो, एक भी कोई मृत्यु ना हो। हम ऐसा रोड बनाएंगे, ऐसी टनल बनाएंगे कि इसमें एक भी इस प्रकार का इंसिडेंट ना हो। और इसलिए ऐसे सेमिनार ये नॉलेज को अपग्रेड करने के लिए बहुत उपयोगी होते हैं। और इसलिए आप सब लोग टेक्निकल नॉलेज के ऊपर मैं कुछ बोलना नहीं चाहता, क्योंकि मैं भी इसमें जानकार नहीं हूँ। मुझे समय रहता तो मैं और दिन भर उसको समझने की कोशिश करता, पर आप लोग जब इसको सीखोगे, समझोगे, और इसका प्रेजेंटेशन जब होता रहेगा, तो धीरे धीरे मैं भी उसकी एस्पेक्ट को समझने की कोशिश करूँगा। और मुझे लगता है कि हम सब की इस अध्ययन से, इस चिंतन से, अच्छे सक्सेसफुल प्रैक्टिसेस को स्वीकार करने से हमारे काम में, विशेष रूप से जो लैंडस्लाइड और मिटिगेशन का जो हमारा जो मेजर्स है और जो प्रॉब्लम्स और समस्या है, उस क्षेत्र को हम सुधारने में हम कामयाब होंगे। अभी अरुणाचल, मेघालय, त्रिपुरा, सिक्किम, ये 7 सिस्टर्स, उधर तो प्रॉब्लम है ही। ये उत्तराखंड का तो मंत्री जी उपस्थित है, उनके यहाँ बहुत बड़ा प्रॉब्लम है। हिमाचल में प्रॉब्लम है, ये कश्मीर में प्रॉब्लम है। और इसलिए मुझे लगता है कि हम सब लोग जिस प्रकार से इसके लिए एक बहुत अच्छी शुरुआत हुई है, पिछले कुछ दिनों से इस क्षेत्र में जो कुछ हम स्वीकार कर सकते हैं, उसके बारे में एक पॉजिटिव एटीट्यूड के साथ हम लगातार प्रयास कर रहे हैं, डिस्कशंस कर रहे हैं, सेमिनार कर रहे हैं। और मुझे लगता है कि इन सब बातों का उपयोग निश्चित रूप से होगा। जो हमारे टेक्निकल डायरेक्टर्स है NHIDCL, NHI में, तो मैं सेक्रेटरी साहब को एक रिक्वेस्ट करूंगा कि इस क्षेत्र में काम करने वाले लोगों को कम से कम 5-7 साल ट्रांसफ़र मत करिए। अदरवाइज़ ये ज्ञान हासिल लेंगे पूरा अनुभव करके, और फिर नया आएगा, फिर वो पूछेगा राम की सीता कौन, फिर शुरू होगा तो फिर रामायण शुरू हो, तो वो चला जाएगा। तो अब इसके लिए कोई तो भी परमानेंट ऐसा कैडर हमको तैयार करें कि एक ग्रुप टनल में एक्सपर्ट है, एक रोड कंस्ट्रक्शन के पूरे एक्सपर्ट हैं, एक लैंडस्लाइड्स, ये विशेष रूप से ब्लैक स्पॉट्स है, इसमें भी हमारे लोग अच्छा काम करते हैं। कल उड़ीसा के जो आरओ थे उन्होंने खुद इनिशिएटिव से ड्रोन से एक ब्लैक स्पॉट का शूटिंग करके उसका डिज़ाइनिंग किया, और उसका जब फोटो मैंने देखा तो उन्होंने उसका सॉल्यूशन बहुत अच्छा निकाला था। तो उन्होंने खुद के इनिशिएटिव से जो काम किया और प्रॉब्लम सॉल्व किया, दैट इज़ द थिंग विच वी नीड। ये हमारी आवश्यकता है। हमें बताने के बाद काम करना ऐसा थोड़ी है। बताने के बाद काम हम करेंगे तो हम जानवर में और बाकी हम में क्या फ़र्क होगा फिर। हम सुमोटो खुद के इनिशिएटिव से हम प्रॉब्लम को रिजॉल्व करने के लिए आगे आए और पॉजिटिविटी के साथ उस सॉल्यूशन प्रोवाइडर के रूप में उसका सॉल्यूशन निकाले, तो हम लोग समस्या का निराकरण कर सकते हैं। अलग अलग इसमें एक एंगल है कि विदेशों में कॉस्ट बहुत ज़्यादा लगती है, हमें कॉस्ट इफ़ेक्टिव सॉल्यूशन भी निकालने होंगे। इंपोर्ट जो कर रहे हैं वो चीज़ों को हमारे देश में तैयार हो, इसके लिए भी प्रयास करने होंगे। और अगर ऐसी लॉन्ग टर्म पर हमको ज़्यादा लगती है तो ऐसे कंपनीज को भी इनकरेज करेंगे। तो मुझे लगता है कि धीरे धीरे हम लोग जो पूर्णांक की ओर जा रहे हैं, अब पूर्णांक ये मिलता नहीं कहीं, हम सब अपूर्णांक हैं। पूर्णांक ये तो कभी वहाँ तक पहुँचना कहीं, क्योंकि हर साल नई टेक्नोलॉजी आती है, नए नए मटेरियल आते हैं, नई नई बातें, नए सॉल्यूशंस आते हैं। दुनिया बदलती रहने वाली है। जो कल था वो आज नहीं, आज है वो कल नहीं, ये चलते रहेगा। पर हम बदलते रहेंगे और धीरे धीरे अच्छा से अच्छा प्रोवाइड करते रहेंगे। यही मेरी आपसे रिक्वेस्ट है। बाकी टेक्निकल बातों के बारे में मैं इतना ही कहूँगा कि हमको 100% लीक प्रूफ सॉल्यूशन चाहिए। जो हमारी जनता की अपेक्षा है वो कैसे करना और कब करना और कितने समय में करना, ये सब आपके स्किल के ऊपर डिपेंड होता है। आप इसमें अगर कामयाब होंगे तो उन लाखों लोगों के जो उस क्षेत्र में रहते हैं उन सब के जो धन्यवाद है आप तक, हमारे मिनिस्ट्री तक, हम सब तक मिलेंगे और उस कार्य में आप सब लोग कामयाब होंगे। इसी विश्वास के साथ मैं अपनी बात को समाप्त करता हूँ। धन्यवाद।
Thank you very much, Honorable Minister, for your visionary address, your inspiring leadership, your unwavering commitment towards building stronger, safer, and future-ready roads of our nation. And now, ladies and gentlemen, we'll resume our technical presentations. Our upcoming presentation is on slope engineering, landslide, and geohazard mitigation, a holistic approach. To deliver this important presentation, may I invite we would request our honorable dignitaries to kindly grace the front row. Ladies and gentlemen, you may please be seated now. To deliver our upcoming presentation, may I invite Colonel Soumendra Banerjee from GeoQuest to kindly take the stage.
Jain sir, I am Colonel Soumendra Banerjee and I represent GeoQuest. On a broader front, I represent the entire industry who is sitting here and working on field. सर सबसे पहले तो मैं रिस्पेक्टेड ऑनरेबल मिनिस्टर को ये धन्यवाद देना चाहता हूँ कि आज इंडस्ट्री को इस मंच पे आने का एक मौका दिया गया, क्योंकि यहाँ पर जो NHIDCL मोर्थ के सब ऑफिसर्स हैं एक तरीके से मिल के काम करेंगे इंडस्ट्री के साथ। there is nothing in this world that we cannot achieve. So thank you for that. अब मैं शुरुआत करता हूं एक स्लोप स्टेबलाइजेशन होलिस्टिक अप्रोच। जैसे यहाँ पर मंत्री जी ने ऑनरेबल देन रिस्पेक्टेड सेक्रेटरी साहब ने कहा कि एक हमें सब तरीके से देखना पड़ेगा कि ट्रबल स्पॉट कहां पर है। तो स्टार्ट करने के लिए जस्ट एक स्लाइड है कि हम हैं कौन, जियोक्वेस्ट। हम हैं तो सर एक फ्रेंच कंपनी, बट हम 1997 से हम इंडिया में हैं और हमारे साथ बड़े दिग्गज कंपनियां भी हैं, फ्रेसिने जो ब्रिजेस में काम करती हैं। अब मैं सब्जेक्ट पे प्रॉपर पे आता हूं सर। माइंडसेट ऑफ ए माउंटेन टेमर सर मैं फौज में था सर, और मैं बॉर्डर रोड ऑर्गेनाइजेशन में, अजय टमटा जी उस टाइम थे सर, कैलाश मानसरोवर यात्रा रूट की कनेक्टिविटी दी थी सर, मैं कमांडर टास्क फोर्स था। तो उस टाइम मेरे दिमाग में जब ये पहाड़ें गिरती थी सर, क्यों गिर रही हैं, कैसे गिर रही हैं, ये मेरे दिमाग में था। तो एक माइंडसेट, एक सोच को चेंज करना, कैसे चेंज करना है, उसके बारे में मैंने थोड़ा सोचा। और पिछले 3 साल में जब मैंने इंडस्ट्री के साथ में लिंक में आया, जियोक्वेस्ट में आया काम करने के लिए, तो मैंने कुछ चीजें साधी सर। डीपीआर बन गया, ठीक है, सामने आ गया, ठीक है, बट उसके बाद जब हम स्लोप स्टेबलाइजेशन की कार्रवाई पे आएंगे सर, तो हमें फिर से डीपीआर को रिविजिट करना चाहिए, स्पेशलिस्ट को लाना चाहिए। इन्वेस्टिगेशन नहीं हुआ तरीके से तो फिर से करना चाहिए सर। अभी हम सब मिनिस्ट्री में इंटरेक्ट करते हैं और इस चीज को बात समझ में आ रही है सर। उस टाइम जब मैं फील्ड पे था, आई वॉज ओनली लुकिंग एट 2 थिंग्स, सप्लाई, इंस्टॉलेशन एंड मेंटेनेंस। इसके बियॉन्ड में गया ही नहीं, क्योंकि दिमाग चला ही नहीं सर, माइंडसेट नहीं था। माइंडसेट बनाना पड़ेगा, डीपीआर फिर से बुलवाने पड़ेंगे, किसने बनाया है, कहां बनाया है, बैक एनालिसिस करना पड़ेगा। 4 साल पहले की डीपीआर है, आज के दिन में वैलिड है कि नहीं। सेक्रेटरी सर brought out the various channels, aquifers which comes out, but whether it is, what is the volume of water that water body is carrying, back analysis very important. दूसरा, उसके बाद जो है सर, कार्रवाई वहां नहीं खत्म हो जाती है कि इंस्टॉल कर दिया सर केयर करना है सर, प्यार करना है उस चीज को जो हमने बनाया है सर। तो मॉनिटरिंग एंड इंस्पेक्शन, ये भी जिसने मैन्युफैक्चर किया है, जिसने रखा है, उसी की अगर जिम्मेवारी होगी तो आपका कभी भी कोई फेलियर नहीं होगा, बिकॉज ओनरशिप सर, ओनरशिप आएगी सर। और वही चीज नॉट ओनली विद द ऑफिसर्स, वो हमारे इंडस्ट्रीज के यहां लोग बैठे हुए हैं, वो भी चीज वो उसको फील करेंगे सर। इन सबको अगर एक सीमलेस अगर मैं इन सबको एक सीमलेस तरीके में बांधता हूं, तो वी कैन क्रिएट वंडर्स सर। ये 2014 में जब हुआ था सर, ऊपर रोड काटने की जगह नहीं थी, तो एक ही तरीका था कि हम वैली साइड को रीइंफोर्स करें सर। 102 मीटर का इतना बड़ा वैली था, मिनिस्ट्री के किसी एक ऑफिसर ने उस टाइम एक लिया सर, एक काम किया कि भाई मुझे वैली साइड में बनाना है। तो सर ये 102 मीटर की ऊंची दीवार बनी, हमने थोड़ा कंट्रीब्यूट किया, बट जो मिनिस्ट्री में जो ऑफिसर बैठे हुए थे, ही टुक दैट इनिशिएटिव, उन्होंने कहा कि नहीं करिए आप। एंड आज के डेट में 2019 में ये काम खत्म हुआ है सर, और बढ़िया परफॉर्म कर रहा है सर। सो दैट माइंडसेट सर, अगेन, कि कर सकते हैं, हो सकता है, विश्वास। तो और इसका क्या हुआ सर, वर्ल्ड का टॉलेस्ट सर, लिम्का बुक ऑफ रिकॉर्ड में भी है सर, वर्ल्ड का टॉलेस्ट बन गया सर ये। फिर आते हैं सर, हम एक मैकेनिकली स्टेबलाइज्ड अर्थ की बात हम करते हैं सर। मैं ये हाइट दिखाने के लिए नहीं कर रही, ये सोलन का सर, एक सोलन कैथली घाट रोड का एक है सर। इसमें सर ये सोच थी कि हम वी शुड गेट बैक टू द नेचर सर। इसमें अगर आप देखेंगे सर, जो डिजाइनर ने सोचा कि अच्छा, जो नेचुरल पानी का जो एक बहाव था उसको नहीं रोकेंगे, उसके लिए बीच में हम एक चैनल बनाएंगे और हम वी विल गो बैक, ट्राई एंड कनेक्ट इट बैक टू द नेचर सर। ये सोच अगर आ जाएगी, और ये हुई है, ये हुआ है काम, वी हैव ऑलरेडी डन इट, व्हाई कांट वी रिपीट इट। These kind of mindset needs to propagate to each and every person who is down right at the junior engineer level. Surface drainage is important. There are ways of doing it. Give it. We talk about surface drainage. मैं उसके ऊपर भी आऊंगा, बट अभी हम surface drainage की बात कर रहे हैं। और आई एम श्योर आप सभी लोग यहाँ बैठे हुए हैं, एक किसी भी स्लोप स्टेबलाइजेशन जो भी ऑफिसर करता है, उसके अगर 6 महीने में उसके ऊपर अगर ग्रीनरी आ जाती है, उसको एक सेटिस्फैक्शन होता है, उसके ऊपर एक सेल्फ सेटिस्फैक्शन होता है कि हाँ, मेरा स्लोप स्टेबलाइज हो रहा है। सो ये सब चीजें आप अगर डिस्कस करेंगे, हम उसका सोल्यूशन लेकर आएंगे। सर ये नेपाल का फोटोग्राफ है, बट जैसे सेक्रेटरी सर ऑल्सो ब्रॉट आउट कि हम एक कॉरिडोर को पकड़ते हैं, एंड उस कॉरिडोर को पकड़ते हैं तब उसमें पहले हम स्लोप स्टेबलाइजेशन का काम करेंगे, फॉर्मेशन हो गया, स्लोप स्टेबलाइजेशन करेंगे, फिर परमानेंट वर्क पे आएंगे सर। कलवर्ट्स, ब्रिजेस बाद में करेंगे, बट स्लोप स्टेबलाइजेशन करेंगे। एक कॉरिडोर को, एक कंटिजियस आपका जो स्लोप है, एक के साथ एक है, एक को पकड़ लिया दूसरा नहीं किया, सॉरी, तो इसके लिए आपको एक होलिस्टिक सोच होनी चाहिए कि भाई इसके बाद एक और लैंडस्लाइड है, लेट्स वर्क ऑन दैट। और इसमें अगर आप देखेंगे हर एक लैंडस्लाइड में हमने एक निकासी यानी कि एक वाटर शूट रखा हुआ है सरफेस वाटर के लिए। सो इस तरह का एक डिजाइन पेपर पे जब डिजाइन आएगा, फ्यूचरिस्टिक थिंकिंग करेंगे, तब ग्राउंड पे इंप्लीमेंट होगा। सिविल इंजीनियरिंग का सबसे बड़ा महत्व है ये, थिंक हार्ड, थिंक फार, देन थिंग्स विल लास्ट। ओके, अब ये जो है एक, मैं ये हाइट की वजह से अगेन मैं नहीं दिखा रहा हूं सर। हमारे बीच में कर्नल कमांडर 16 BRT BRO के यहाँ पर आए हुए हैं, ले से आए हुए हैं, उनका सेक्टर है ये सर। इस जगह पे ये स्नो लाइन के ऊपर है सर ये, और यहाँ पर फ्रीजिंग एंड थॉइंग होता है, और जो सॉइल का पैरामीटर होता है वो लगातार चेंज हो रहा है। अब इसमें जो नेल लगेगा उसकी गहराई कितनी होगी? तो जो डीपीआर और डिजाइनर, जो कंसल्टेंट आपके पास आ रहे हैं, उनको ये सवाल पूछने चाहिए कि आपने सॉइल इन्वेस्टिगेशन किया? तो हम लोग से सर सोनमर्ग टनल का अप्रोच वर्क है और बढ़िया तरीके से चल रहा है सर। ये कॉम्बिनेशन ऑफ सिस्टम सर, सिर्फ एक तरीके से काम करने से नहीं होगा, कुछ भी टेम्पलेट नहीं होता है, पीरियड। इस इंजीनियर्स हैं हम लोगों को इनोवेट करते रहना चाहिए। उसमें हमें यह देखना है कि कॉम्बिनेशन से काम होगा कि नहीं, उस पर ध्यान रखना है। तो हमारा माइंडसेट को बड़ा करना है। मैं ये तरह का कॉम्बिनेशन भी मैं आपको बताऊंगा। मैं अब थोड़ा सा जो है सस्टेनेबल की बात करता हूं मैं सर। हमारे पास IRC है, बहुत ही पावरफुल बॉडी है सर, कोड्स निकालते रहते हैं, कोड्स बताते भी हैं कि अगर आप इसमें देखेंगे सर, मैंने एक अभी आपको हाईलाइट किया है, shifting of the highway alignment away from the tow and slide area eliminate the need to provide tow support, लिखा हुआ है। IRC SP 48 का ये एक्सट्रैक्ट है ये। बट अगेन माइंडसेट सर, माइंडसेट इसलिए क्योंकि स्लोप को रोकने के लिए कम पैसा लगता है, वैली को में फॉर्मेशन बढ़ाने के लिए ज्यादा पैसा लगता है। बट लाइफ साइकिल कॉस्ट सोचिए सर, लाइफ साइकिल मेंटेनेंस सोचिए। This is more profitable at the end of the day. Again, IRC SP 48 का ही निकाल रहा हूं सर मैं। बैलेंस्ड अप्रोच, वैली की तरफ जाइए, थोड़ा सा देखिए कि वैली की तरफ में आपको जगह नहीं भी है तो क्रिएट करिए, क्रिएट होता है। अभी मैं आपको अगला कुछ एक एग्जांपल्स दिखाऊंगा कैसे क्रिएट होता है। होलिस्टिक अप्रोच, अब ये अगेन सोनमार्ग का अप्रोच रोड है जो बनाया गया था, हमने बनाया था उसमें। तो वैली साइड और हिल साइड दोनों को मिला के काम किया सर, ताकि कटिंग ना करना पड़े, और फॉर्मेशन विड्थ भी मिला सर। सर यहां पर जितने लोग बैठे हुए हैं सबको यह मालूम है कि ड्रेनेज, पानी की निकासी इज द बिगेस्ट प्रॉब्लम। सिंकिंग हो, लैंडस्लाइड हो, सोल्यूशन क्या है, कैसे कर सकते हैं? अगेन देयर आर लॉट ऑफ थिंग्स अवेलेबल इन द मार्केट। हाई प्लेन वेलोसिटी के ऊपर जो आपके ड्रेनेज कैपेसिटी बढ़ाती हैं, जो ज्यादा लोडिंग में काम करती है सर। ये एक छोटा सा एग्जांपल बता रहा हूं सर मैं। ये जो दीवार में जो ये पाइपें आ रही हैं सर, ये इसमें से पानी निकल रहा है, इसके ऊपर तकरीबन 200 टन का लोड है सर। ये एक माइनिंग का प्रोजेक्ट है, उसका है ये। यही चीज जो है सर हम हाईवे में ला सकते हैं, जहां पर हमारे रोड के नीचे पानी का दिक्कत है। ये बिछा दीजिए, एक रोल है, बिछा दीजिए इसको। आपको मैं फिर से वापस लेके जाता हूं सर, एक रोल है ये सर, उसको आप बिछाएंगे, उसके नीचे से पानी की निकासी चलती रहेगी सर। स्लोप इंजीनियरिंग सर। अब आते हैं सर, मैं अभी वैली की बात कर रहा हूं, बट मुझे एक तरीका भी आपको दिशा दिखानी है कि वैली में किस तरह का काम हो सकता है। यह भी IRC में बहुत ही क्लियर तरीके से दिया हुआ है कि एक तरीका होता है जब हमारे पास एनफ विड्थ है वैली साइड में बढ़ाने के लिए, और जहां पर विड्थ अवेलेबल नहीं है, जो अमूमन सेकंड वाला जो है W2 जहां पर कम रहता है, वहां पर हमें ज्यादा दिक्कत आती है। अभी ये जैसे मैंने W1 का बताया, ये जो फोटोग्राफ है ये आपका बद्रीनाथ के रास्ते पे है, इस पे काम हो चुका है। इसमें हमें विड्थ मिल गई थी। ये एक जनरल थंब रूल है, ये आप सभी को के लिए है। एक थंब रूल है कि अगर आपको आरई वॉल या आरएस वॉल बनाना है तो आपका हाइट का 0.7 मीटर हाइट जो है, आपको उतना डिस्टेंस होना चाहिए, आपकी आरएस वॉल आसानी से बन पाएगी, क्योंकि उतना ही जो है डिजाइन स्ट्रेंथ और फोर्सेस में जरूरत पड़ता है। अगर वो नहीं होती है सर, तो अगला IRC SP 48 ने अगेन एक रीइंफोर्स शोर्ड वॉल कंस्ट्रक्शन के बारे में बताया। अब ये है क्या चीज सर? इसमें क्या है कि पहले आपका जो एग्जिस्टिंग स्लोप को हमने पकड़ा। कैसे पकड़ा? नेल से पकड़ा। इंश्योर किया कि इसका मूवमेंट ना हो, और इस नेल के लेंथ को, इस नेल जो है ये सॉलिड नेल है और इसके आसपास ग्राउटिंग है, सीमेंट की ग्राउटिंग की गई है, और इसका पुल आउट तकरीबन 50 किलो न्यूटन तक का होता है। अब इसके ऊपर ये जो ब्लू वाले जो आप देख रहे हैं डॉटेड, पानी की निकासी, ड्रेनेज हमने इसमें डाला ताकि इसका अगर कोई पोर वाटर प्रेशर बन रहा है, आज अभी नहीं तो कल जरूर बनेगा, उसको निकालने का पहला हमने सरफेस को तैयार किया, फिर उसके बाद उसको रोका नेट और नॉन वोवन जियो टेक्सटाइल से। काला वाला जो कपड़ा देख रहे हैं आप, नॉन वोवन जियो टेक्सटाइल है। इसमें क्या है कि फाइन्स जो है ये बाहर नहीं निकलेगा और मट्टी वहीं की वहीं रहेगी। इसको वहां पकड़ा हमने, और एक नीचे एक बेस में अगर आप देखेंगे, ये अगर आप बेस में देखेंगे कि एक छोटा सा हमने एक बेस बनाया। इस बेस के ऊपर हमने जो फोटोग्राफ दिखाया था 102 मीटर का, वो बनाया हुआ है, और इस बेस पे ये तकरीबन 30 मीटर हाइट की वॉल बनेगी। अब इसके ऊपर हमने एक फॉल्स फेसिया शुरू किया। अगर आप यहां देखेंगे, यहां पर एक फॉल्स फेसिया शुरू हुआ, और इसके बीच में सिलेक्टेड फिल यानी कि मुरम जैसा एक मटेरियल लाएंगे, और पीछे के हेड से सामने वाले को कनेक्ट करेंगे। तो इससे क्या होता है कि हमारा पहला ऊपर का फेसिया जो है वो एक आउटर फेसिया के जैसा काम करता है, और उसका जो रिएक्शन है वो हमें इसके हेड से मिल रहा है। और इसमें अगर आप ध्यान से देखेंगे, ये जो स्ट्रैप्स जो है सर, इसमें दांतें बनी हुई हैं सर। ये हाई एडिशंस हैं सर। ये दांत जो है लेटरल हाई एडिशन देता है। तो ये सब चीजें हमें डिजाइन करना पड़ता है, हमें देखना पड़ता है। बट ये है कि ये अवेलेबल है हमारे पास सर, और ये हो सकता है। देन कमिंग टू, ये धीरे धीरे जो है सर, इसमें हमने फिलिंग किया, और ये फॉर्मेशन विड्थ हमने गेन कर लिया। अब इसमें अगर आप देखेंगे, हमने थोड़ा भी जो है सर, हम हिल साइड में नहीं गए, और अगर हिल साइड में नहीं गए तो सेफ है सर। तो ये एक लॉन्ग टर्म सस्टेनेबल सोल्यूशन है सर। मैं हर समय एग्जांपल देता हूं, पुराने जमाने में ब्रिटिशर्स जो हम लोग के रोड बनाते थे सर, हर समय रिज लाइन को फॉलो करते थे सर पुराने, क्योंकि सर वहां कटिंग सबसे लीस्ट होती थी। आज के डेट में नहीं कर सकते, बिकॉज ऑब्लिगेटरी पॉइंट है, बीच में कोई ना कोई एक गांव आ जाता है जिसको हमें कनेक्ट करना पड़ता है सर। तो इसलिए सर एक ये बहुत बढ़िया एग्जाम्पल है सर। ये है बिना कुली BRO का काम है सर। ये हमने उसमें सोल्यूशन दिया था सर। इसमें बद्रीनाथ के पहले है सर ये। तो इसमें क्या है सर कि एक ये बड़ा, एक यहाँ डबल लेनिंग का काम चल रहा था चारधाम यात्रा के अंडर में, एक बड़ा हिल है सर। अब इसको जो है सर, हमें 4 मीटर का था, इसे हमें ब्राउन फील्ड कटिंग है, इसको हमें बनाना था सर 12 मीटर। इमेजिन करते, एक ये जो पहाड़ है जो जिसका रॉक 120 MPa जैसे इसका हार्डनेस होगा, इसको काटते तो ये कहां जाता सर। ये एक और लैंडस्लाइड क्रिएट करते हम, और एक्चुअली ऐसा ही होता है। मैं जब BRO में था, मैं आई विल एडमिट सर, मैंने बहुत सारे लैंडस्लाइड पॉइंट क्रिएट किए हैं, क्योंकि कट करके मैंने पहाड़ बनाए सर। एडमिटेड सर, बट सोल्यूशन है आज के दिन में सर। तो इसमें क्या हुआ सर कि हमने एक वही जो शोर्ड वॉल कंस्ट्रक्शन के साथ हमने इसको सोल्यूशन दिया, और ये नदी के साथ है सर। नदी के साथ में है, तो वी हैव गॉट enough ways and means. We have got anti-score construction materials which can take a velocity of 6 to 7 मीटर पर सेकेंड का जो फ्लो है सर, वो उस पर हम डिजाइन कर सकते हैं। अंदर केबल डले हुए रहते हैं सर। तो टो का जो है सर, हम वी कैन गिव अ सोल्यूशन, एंड वी हैव डन इट सर। अब हिल साइड में आते हैं सर। 2 तरीके होते हैं सर हिल साइड को प्रोटेक्ट करने के लिए। एक होता है एक्टिव, दूसरा पैसिव, जिसके ऊपर वन बाय वन में आता हूं मैं सर। एक्टिव में कुछ नहीं है सर, जो नेल है, नेलिंग किया, बट नेलिंग से ज़्यादा ज़रूरी है सर इसका ऊपर का जो आपका मेशिंग सिस्टम है। तो ये मेशिंग सिस्टम जो है स्टील मेश से हो सकता है या हाई टेंसाइल मेश से हो सकता है सर। अब इसका एक लाइव एग्जांपल दिखाता हूं सर मैं। ये है सर आपका, आपने जो पीछे का बैक है इसको पकड़ा और इसके ऊपर नेलिंग की, और ये नेलिंग जो है सर ये सॉलिड नेल से होती है जिसको ग्राउटेड होता है, और साथ में ड्रेनेज सर, ये ड्रेनेज इज द मोस्ट इंपॉर्टेंट पार्ट ऑफ इट सर। अब अगले में आता हूं सर मैं, मैश सर। आज के आप जो लैंडस्लाइड का जो आप देख रहे हैं सर, ये रोड के ऊपर काम करता है और ये हाई टेंसाइल हाई परफॉर्मेंस नेट्स होते हैं सर ये। सो इस हाई परफॉर्मेंस नेट में जो है आगे आपके चलते हैं एंकर सिस्टम सर। पैसिव मेजर्स में जब बहुत ज्यादा बहुत लंबे चौड़े होते हैं सर तो हम उसमें एक्टिव नहीं कर सकते, तो हमें उसमें ये वाले पैसिव सिस्टम में जाना चाहिए, जो कि ये आपके रॉकफॉल शेड सिस्टम हो गए। बंड्स बन सकते हैं सर, जैसे ये वाला बंड है, दिस इज एबल टू टेक अ हिट ऑफ अबाउट 5 मेगा जूल्स, अबाउट 120 किलोमीटर पर आवर के स्पीड में ये आ रहा है। कैनोपी सिस्टम्स, एक ये वाला सिस्टम जो है सर, एटेन्यूएटर सिस्टम, जो लोगों को कम मालूम है, इसको ये पत्थर को पकड़ता नहीं है सर, ये उसको अलाउ करता है रोल करने के लिए, एट द सेम टाइम उसको निकालता है। दिस इज जेड मोड अगेन सर। इन दिस वे वी आर एबल टू डू द वर्क। अब जो मॉनिटरिंग जो है सर, दैट इज वेरी इंपॉर्टेंट, दैट वी शुड डू इट। This is the system which I was talking about, is the how we can ensure that the water is channelized. सर ये अगेन सोनमर्ग जो हमारा जो आज का मेन थीम है सर, उसके ठीक एंट्रेंस के नीचे ये बना हुआ है सर, और ये जो है सर इसके बीच में केबल्स चल रहे हैं, एंड आई एम श्योर ये सब तरह के स्काउरिंग मेजर्स को टेक केयर कर सकता है सर। ये एक छोटा सा वीडियो, इसके बाद मैं आई विल कंक्लूड इट सर। दिस इज अगेन जो हमारा थीम है सर, उसके हिसाब से सर इसमें हर तरह के सॉल्यूशंस जो है आप देख पाएंगे। एक रोड को, एक हिमालयन टेरेन रोड को क्या चाहिए सर। मग डिस्पोजल इज अ मेजर टास्क एंड विच शुड बी यूटिलाइज्ड स्पेशली इन हिली एरिया टू क्रिएट प्लेटफॉर्म्स। उसका भी है सर। अभी हम लोग NHI, DCL, मोर्थ, हम सभी हिल में जा रहे हैं, और मग डिस्पोजल इज अ मेन प्रॉब्लम सर। ये जो मैं आपको बता रहा था, दिस इज हाउ वी शुड चैनलाइज। अगर हमारे रोड अलाइनमेंट में वाटर बॉडी आती है तो उसको किस तरीके से कंट्रोल करना है सर। आपके एजेस को, एम्बैंकमेंट आर द मोस्ट वनरेबल सर। एम्बैंकमेंट पकड़ लेंगे तो आपका फ्लड कभी नहीं आएगा सर। स्लोप, हर तरीके के स्लोप को जो है, चाहे वो किस उसका फंक्शन, चाहे उस टाइम वो क्या परफॉर्म कर रहा है, हाई वॉल्स। सो दिस ऑल कल्मिनेट्स टू अ कंप्लीट होलिस्टिक सिस्टम, एंड विद दैट आई थैंक यू सर। थैंक यू फॉर दिस अपॉर्चुनिटी ऑन बिहाफ ऑफ द इंडस्ट्री अगेन सर। थैंक यू सो मच सर।
Thank you, sir, for a highly informative presentation. With the kind permission of our honorable chief guest, ladies and gentlemen, we'll now pause for a 15 minutes tea break. Can we please once again thank our honorable chief guest, our guest of honor, for gracing us with their benign presence. Can we all again, ladies and gentlemen, please thank them with a round of applause. We once again thank our chief guest, Honorable Minister of Road, Transport and Highways, our guest of honor, Honorable Minister of State, Road Transport and Highways and Corporate Affairs, for joining us for this highly relevant and impactful workshop, for their wholehearted contribution, their gracious presence, and sparing their valuable time for us. We look forward to having their esteemed presence in the coming times also with us. We once again thank our esteemed dignitaries for their time and their presence. Ladies and gentlemen, we'll take a 15 minutes tea break as we are running behind schedule. We will request you all to kindly reassemble in this hall at sharp 1:15 p.m. I repeat, we request you to reassemble at sharp 1:15 p.m. Tea is organized in the pre-function area, which is outside the hall on your right, as well as leaders lounge. Tea is organized in pre-function area outside this hall on your left, as well as leaders lounge. Kindly reassemble at 1:15 p.m. for our next presentation. Thank you. we move to our next session on building resilient slopes, insights, and best practices from case studies and maintenance strategies for rockfall and landslide projects. To present this important topic, may I invite on stage Sri Arvind Ganesh and Sri Rudra Buddhapati from McAfee. Can we have our speakers on stage for our upcoming presentation? Ladies and gentlemen, post this presentation, we have 2 more presentations and then we'll break for lunch. We'll be starting very shortly. Thank you. We now have with us Sri Arvind Ganesh and Sri Rudra Buddhapati from McAfee. Over to you, sir.
Hello, good afternoon, everyone. I hope I'm audible. Okay, so I'm joined by my colleague Rudra Buddhapati, and we are going to take you through about giving some real-time insights from some case histories of rockfall and landslide mitigation projects, which we had executed or were involved in the past few years. And Rudra will cover, based on that, what could be the possible O&M strategies. Firstly, sir, thank you to the Ministry and NHADCL for giving us this opportunity to present our views as an industry. And definitely, I mean, I concur with whatever was presented by my industry colleagues from GeoBrog and GeoQuest. Especially even the views from the ministry were like music to our ears, you know, where we are talking about long-term performances, looking at durability part, and also looking at a holistic view of it. You know, in a hillside, it is not only about just looking at the hillside or the top of the hills, but looking at the total slope from the river till the crest of the slope. So what are we going to show here? So basically, from the insights, what you can look at is real factors which contributed to the technical performance, durability, long-term performance, and obviously its impact on the cost and even the timeline. I mean, as we all know, time is an important factor in the execution of these projects, especially in hillside infrastructure projects. So the first one which we are going to show is about the rockfall mitigation works done at Borghat section of Mumbai-Pune Expressway. Now, this was executed in 2015, and just to give you a backdrop of it, the Bombay-Pune Expressway passes through the Borghat section, which is now common for both NH4 and the Mumbai-Pune Expressway, and it's like faces a heavy traffic, and obviously also face a lot of rockfall and landslide problems there. Now, to set a context to it, this was in 2015, and within a period of 45 days, it faced a huge rock slide in 3 different locations within 45 days. Obviously, this also caused a huge disruption to the traffic. You know, it's a heavy traffic area, and also a loss of lives. And hence, there was a lot of public sentiment against this, and even rightly so, even the authorities were concerned about doing some long-term measures to provide a safe environment for the users, as well as to protect the road assets. So, to give you a backdrop, this was the first rockfall mitigation project in the Indian highway sector, which was executed on design, supply, and also a 10-year obligation, the maintenance obligation. To tell you, in those days, I think most of the contracts would come with hardly 2 or 3 years maintenance obligation, and the design would be done by a consultant. But here, all the three were clubbed into one because it was a need of the hour. I mean, firstly, it was an emergency work. It had to be taken up immediately. So everything was clubbed into it, and at McAfee, we took that challenge. Obviously, when this happened in monsoon, and you all know about the peak traffic during the festival time, so obviously critical stretches had to be attended, and obviously there was huge pressure on finalizing the designs and then implementing the solution. Yes, the designs were done. I mean, the detailed investigations, drone survey, geophysical investigations, and the detailed analysis was done phase by phase for each critical stretch. So that was one of the challenge. In some locations, the slope had to be treated up to 50 meter in height, and the work had to be executed during peak monsoon and heavy traffic. So in terms of achievements, what we could say is, even though the work had to be executed during monsoon, the work was executed on time, incident-free. Yes. And to manage a project within such timelines needed a strong stakeholder collaboration. So obviously we'll have the authorities, the consultants, but this was a running expressway, so it needed a very close coordination with even with the ON operator, the district administration, police, for the complete handling of the situation there. And as of now, we have completed around 9.5 years out of the 10 years defect liability and maintenance period, and I can tell you that this carriageway has remained free from disruption due to rockfall till date. But we will show you how it was done and the insights what was done. And based on this model served as a benchmark for subsequent future projects also here. The components was, those times we had used EAD approved rockfall barriers for 5 meter height. Considering that along with the performance, it also ensures a durability. I mean, let's say for this condition, the working life was around 25 years using Class A zinc aluminum coating. Likewise, EAD approved rockfall drapery mesh. Now, during the tender, how there was certain flexibility given to the bidders was they framed the BOQ items considering all the kinds of meshes, all the possible items, and that helped us to pick and choose and derive the executed solution there. So EAD approved rockfall drapery mesh for strengths ranging from 50 kilonewton to 250 kilonewton was used, and total, I would say, was around 65,000 square meter meshes was executed, and close to around 30,000 anchors were drilled. These needed a very deep drilling, and subsurface drainage also played a very important role. Coming to the maintenance part, as I said, these systems need maintenance, and it's just not about doing the maintenance or performing the maintenance obligation, but doing it on time. And this is just not a one-time maintenance obligation, but it was done frequently over the years. So we have just outlined the kind of steps which were done to perform the maintenance operation, which needed skilled manpower, removing the components one by one, and safely bringing down the slope, detached boulders down the slope, and disposing it safely. Important point to note here is this was possible because we use a durable galvanized protection for all the components, which helped us, let's say, remove, unscrew the anchors, remove the mesh, and redeploy it. Similarly, this was the maintenance rockfall barrier. Of course, here, after any kind of incident, it needed a replacement of the parts, but this also needed a safe disposal of the boulders. And here you could see we are using a mechanical device to break the boulders into smaller sizes and bring it down. These are the photographs of the current status. It's functionally as intended even now. This is of the Adoshi Tunnel, Khandala Tunnel. Now, based on this, the authorities also decided for subsequent scope. So they have added multiple stretches on the same highway even ahead. And I think they added at least another 3 to 4 packages here, and that has been executed. So what were the insights and lessons learned? See, as we said, definitely a lot of insights which could help us, but also, as we say, no one is perfect. We could definitely learn from our lessons here, and hence we have tried to make it listed down here. The use of certified EAD systems definitely ensures performances not only up to DLP period. I mean, when we are spending for such an amount for in providing rockfall protection and slope stabilization, we don't want to function it only for 10 years. Why not 25 years? Why not 50 years? And with the presence of technology here, which assures the durability of surface products, we should use that. And here, even after, let's say, 10 years, we can say that it will last for another 15 years, minimum 20, total around 25, 30 years, it should last there. About the durability in working life, yes, compared to the earlier trends, there were concerns that, oh, the cost is high, but we can say giving such high quality products, initial cost is up, but if you see at the total cost of ownership, considering the maintenance and other things, we didn't have to replace the material, the total cost of ownership does come down. Contractual fees, material selection flexibility did help us finalize the design and thereby aiding timely execution. Loose scaling, we saw the recommendations of Professor J.T. Shah, where they're saying we have to look at doing the loose scaling, but performing loose scaling definitely goes a long way in ensuring the performance, reducing even the maintenance costs, and likewise even drainage arrangements. Collaboration, at least in such areas, strong stakeholder coordination is critical so that the progress goes on as intended. Maintenance measures, in terms of learning, I would say, in this particular contract, it was stipulated as only pre and post monsoon period as the maintenance measures. So definitely it ensures reliability and long-term performance. But if we have to adopt the same thing for Himalayan regions and other places, this would entail a huge amount of cost, and the maintenance, when we're looking at a 10-year DLP and maintenance period, I can say it will entail a huge amount of cost, and that needs to be taken care in the cost estimate, either by the DPR or even by the contractor. From the early warning system, I would say we should move from pre and post monsoon checks to continuous monitoring. I mean, given even how the climate change is affecting right now, you have unseasonal rains starting, let's say even in this place, it started as early as March and goes up till November or December. So just performing pre and post monsoon checks, I think we should move to a continuous monitoring, and we have IoT based devices which are very easy to install, which can give you real-time alerts on a continuous basis. Coming to the second case study, now here from the Western Ghats, we are moving to a upper Himalayan place, and this is a sinking zone project which we executed. We were the technology partners there. We gave the solution for a contractor and Border Roads organization. So we all know about Atal Tunnel. Now this is a place, I'm starting with a schematic, what was adopted there. So here it was a multifold problem. Sinking zone, the sinking just didn't mean subsidence at the road level near the tunnel, but it entailed a complete slope stability right from the hillside till the toe of the slope, and there was a river flowing there, which was causing erosion. And obviously we also had an avalanche issue there. So the key challenges was it was a large sinking zone, troubled by subsurface water flows, slope instability, toe erosion, drainage areas. In terms of working environment, it was a high altitude zone, giving us a very limited working time, and also the avalanche treatment to be done for the first time in India. These are some pictures of what was the situation like. This shows a tunnel subsidence area near just at the entrance of the south portal. This is a condition of loose material along the valley slope, and you can see even at the river area. And this is an aerial view of it, which shows the flow of the river. A more close-up of the portal area where you can see the cracks, joints being opened up for the RR masonry wall, and also a huge subsurface water flow. In the hillside, you can see the subsidence. This is close to around 50 to 60 meter hills on the hillside, and the bent trunks showing that the slope is creeping. So just a few things of what solution was adopted there. This is at the portal area. The valley side consisting of a toe wall, a paramesh wall with an RCC jacketing, and deep anchors on the slope with a flexible fascia like a steel wire mesh for the rocks, and a geosynthetic mat, reinforced geosynthetic mat with hydro seeding for the slope, soil slope portion. And finally, this is the reinforced soil slope just along the road. On the hillside, you can see vegetation has taken place. And finally, these avalanche solutions, these are called umbrella units, which was fixed at the initiation zone, so close to around 600 meters above the road level. This was installed there. And an aerial view of the situation. So what were the insights and lessons learned? Sinking zone, yes, is a complex issue requiring multidisciplinary approach, because you are dealing from the toe of the slope right up to the crest of it, including river training structures here. These involve deep stabilization, so you have to look at deep anchors up to 30-meter length, and even deep subsurface drainage pipes. And not only about deep stabilization, even installing these kind of snow umbrella units 600 meters above the road level, you need to have a really capable contractor with a lot of resources and skilled manpower there to execute these kind of solutions. Modular and composite systems helped us in the ease of construction and ensure the speed. EAD approved systems ensure performance and long-term durability. Especially, I mean, the attention was even paid on the polymeric coating on the wires so that it doesn't turn brittle in the sub-zero conditions. Variations, sinking, there was an increase in the sinking zone length. Obviously, there were contractual complications, and hence the time duration increase. I mean, in these kind of slope stabilizing issues, variations or change of conditions are but natural. So any kind of thing which can help us facilitate it really helps in saving time there. Here, it was also but limited working window due to snowfall, and if there's a cloudburst event which happened in 2022, it does impede construction speed. While the cloudburst event didn't impact any of the structure, but there was some loss of machineries and a stockpile of soil. So I would say that monitoring and alert systems, if we are able to use it, can give us early warning about it so that we can minimize the damage there. Total cost of ownership definitely comes down when factors such as durability, system modularity, monitoring are incorporated in the project, even if the initial cost is slightly higher. Yes, I'll ask my colleagues to present on the operation maintenance.
Thank you, Arvind. Thank you, Arvind. I will now quickly cover the aspects related to the O&M strategies. So when it comes to O&M and especially the maintenance part of it, we have seen the importance of it in the two case studies that Arvind presented. So the strategies which should be implemented should cover these objectives, such as to ensure the traffic safety and the availability of infrastructure so that it can be used. It needs to maintain, it needs to be maintained because we need to ensure the design performance over the life cycle that is intended for the project. It needs to be such that it complies to the DLP requirements, and definitely it is meant to prevent premature issues in terms of the failures. And finally, of course, it is required to reduce the emergency closures and rehabilitation costs. This is the most important part, I will say, apart from the other points. And in order to implement this, the roles and responsibilities of all the stakeholders, the assignment of it is critical. And it all starts with the DPR consultant, because if the DPR consultant incorporates the aspects related to maintenance in the DPRs for the tenders, automatically things will start falling in place, because many times this is something which is forgotten or not covered in the DPR. Then when it comes to the responsibilities of authority engineer or the independent engineer, of course, it is very important to have an oversight on the project and to ensure that the compliance checks are carried out along with the safety audits. Coming to the concessionaire or the EPC O&M team, it is very important that the team carries out the routine inspections and does the maintenance and safety measures. Now, the role of the specialist technology provider is to ensure that the detailed assessments are conducted post events, design upgrades are done based on the requirement of the performances, and the component replacements are done. It is very important that the appropriate advanced monitoring systems are put in place. Documentation and reports, as we all understand, is part and parcel of a project, but then it is apart from regular things like the as-built drawings and maintenance manuals and such. Incident reports are very, very important, because incident report covers the date, rainfall, failure volume, if any, action taken, and all these things in terms of documentation provides the necessary input that is required for rehabilitation planning and the funding approvals if needed. Now, coming to the mandatory inspection. So as we are discussing, it's not just about the pre-monsoon, during monsoon, or post-monsoon inspections. We now need to move towards event-based inspections, such as, like, for example, after a cloudburst or landslide or rockfall or an earthquake. This will enable a proper inspection. Now, why do we need instrumentation and monitoring? So this basically helps in providing the early warning of any instabilities that may be there, and also provide us with the incident alerts, so that when we come to the maintenance aspect, the decisions can be taken from a data-driven objective, not just on the cases of a time-based manner. This basically helps in reducing the sudden closures and the safety risks, and definitely it helps in enhancing the reliability. So what are the different instrumentations or monitoring sensors that can be implemented? So just to give a quick example, for monitoring the movements, we can think about the inclinometers, the accentometers, the tilt meters. When it comes to groundwater monitoring, we can think about the piezometers. But especially for rockfall and debris, we have to think about the alert sensors with respect to the impact. For weather, again, it's very important, because we see that after a rainfall, typically the instabilities are getting generated. So we need to take care about the sensors such as the rain gauges, the temperature sensors, and the humidity or the moisture sensors for the soil. Now, when we think about the sensors, imagine typically we are working in a remote area, or the solutions that are implemented are not easily accessible. So it is very important that these sensors or the systems that are implemented are easy to install and should have a plug and play capability, because it's very difficult to do anything on site with respect to calibration requirements. It should be not complicated, it should be easy. And then, as based on need, the plug and play capability, even with respect to adding sensors based on the need in a project, shall be there. When it especially comes to landslide and debris flows and rockfall events, basically these are sudden events. Okay, and for such we need the real-time alert system in place. Holomac is one such system which can be installed on rockfall barriers, drapery systems, and debris flow barriers, basically to give you an impact alert which is instantaneous, and this alert comes to you through a SMS, an email, or an app. It can also be used to monitor or detect movements in specific locations along a channel. Now, the key aspects of this kind of a system is that it's very easy to install, it's very lightweight, small, maintenance free. It has an inbuilt battery which lasts minimum 5 to 10 years. It's very reliable. It is weatherproof. It is, let's say, safe against direct impacts. It doesn't need any specialized manpower. Whoever is doing the installation of drapery systems or rockfall barriers, the same person can do this installation. It's completely wireless based on IoT, and it's never without network coverage because we have two options, GSM as well as satellite. Now, another very important aspect is that it is possible to integrate it with all the other possible sensors that may be needed, and it is possible to retrofit it as well. Since it is all app-based and it's there in the cloud, you don't need data loggers on site, and all the data is visible on a single dashboard. These are some of the examples of the Holomac device fitted on the rockfall barrier. On the right is the debris flow barrier. On the left, again, is the installation on a drapery system. And on the right, what you see is the Holomac installed in a debris flow channel to detect debris flow movements. Thank you for your attention.
Thank you very much for sharing some very practical case studies and valuable maintenance strategies. In the interest of time, we request all our upcoming presenters, speakers to kindly restrict their presentation to 15 minutes. I now invite on stage Shri Ankur Saxena from TechFab for a presentation on enhancing quality and quantity control in slope protection and rockfall mitigation for national highway projects in India. Over to you, sir.
A very good afternoon to all dignitaries, all respected guests, my fellow colleagues, my dear friends, and my partner from my fields. So today's topic of my presentation is enhancing the quantity and quality control in slope stabilization and protection works in India. So with going to the presentation, the session overview is by bidding behavior analysis and the triggers, way forward, and conclusion. Initiating with the presentation, I would like to give a brief description, a small description about the tenders trend in India. In last 4 to 5 years, there are more than 200 tenders which is coming annually, and the approximation value of those tenders is around 10,000 CR. Majority of the tenders bidded by the contractors are aggressively low, and the average tender value is approx 50 CR. And some of the tenders has been bidded by the contractors are substantially below the benchmark. So the 50 CR, which is a pocket size of a single standalone contract, is coming around 30 to 40% or maybe sometimes 50-55% below. So if these kind of tenders are bidding by the contractors, what kind of execution excellence and what kind of quality we expect, and how to upgrade that installation quality. And in this slide, I would like to thank Ministry of Road, Highway and Transport, BRO, THDC, and all. They have initiated the step to get the non-SOR initiated in the state of Uttarakhand, which have included so many of the new technologies, the new products, and these products give major helpful idea to get more and more good kind of work to be done. And the same non-SOR will be repeated and revised with new innovative product has been incorporated in SOR of 2024. Besides these two non-SOR which has been initiated, the same exercise has already been initiated in different states of Northeast, where these SOR will help contractors as well as the stakeholders to inbuild better products and services and solutions. एक स्लाइड इसमें से कम हो रहा है शायद. Operation excellence. with going to the operation excellence, because once the contractor bidded the tender and has initiated the execution activity, there are 4 major things which we need. मैंने चेंज किया है इसमें प्रेजेंटेशन. वेयर इज द प्रेजेंटेशन? दूसरा लगा देना. Yeah. So this is how if these kind of project has been bidded by the contractor solo, so what kind of overall system we required? So the bid document, because at the time of DPR there are so major checks and balances to be included, which takes care of quality of the work, which takes care of the methodology. If the tender is going beyond aggressively bidding, so we need to also take the checks what kind of methodology they are going to use in future. So with taking this, the provision of inclusion of DPR is very important. Provision of DPR is because in many of the tenders of NHAI we check that the DPR has been included in the tender document itself. But in slope stabilization and rockfall, the DPR is missing in the tender. So if the DPR is included in the tender, it will be helpful for the contractor to bid exactly, and it will take the site insight of the solution which is required. Apart from that, it is very important the contractor should go and visit the site before bidding those major contracts, because while seeing the site, it will give the clear idea what kind of solution is required. Current documentation of tenders are neither EPC nor item rate, because there is a minimum quantity which has been declared in the tender document that it should be done at least this much of the quantity has to be executed by the contractor. But this quantity makes the contractor make one easier part, that minimum quantity he executed, and neither depending upon what kind of solution it is required at that site. So I need like if we making some these kind of DPRs, so these kind of provision need to be included. Apart from that, I also request one more point, like if contractor is bidding and in the previous bidding if he has done a very good work of in a hazard condition, there should be a pointing system or the grading system for a contractor for bidding these kind of project. If these kind of grading is there, so L1 is not the only criteria which selects the contractor. There should be certain more criteria, like in consultant, when we hiring a consultant, there are certain point based system is there to select a consultant. Similarly, these kind of system can be upgraded so that the quality of the work can be upgraded. DLP period, yes, there is a DLP, and it is very good that 10 years of DLP is there in slope stabilization rockfall product. But binding of a bank guarantee or a PVG is very less. We should initiate, like we should increase that binding, and we can give back that DLP amount on a pro rata basis if they have succeeded for 5 years or for 8 years or for 10 years. So these kind of inclusions can be taken care in DPR and the tender document. Again, subcontracting. This is one of the main project, because I am taking whole scenario how these work initiated and how kind of quality has been initiated by the contractor. If we talk about subcontracting, the main work has been awarded to a main contractor which is taking this contract at a very low price, and it again sublet to different contractor, and then again sublet to the labor contractor. Actually, the work which has been initiated or the doing executed is through the labor contractor only. And if this labor contractor is doing the work, they don't know what is the SOPs is there, what kind of scenarios, what kind of procedure need to be taken care of, and they do the work on a very low cost. So these cost, because the main contractor has taken a work on a very low cost, so similarly those applicators also do in a very low cost, and the quality of the work has been compromised. So we have to uplift the training of the applicators also, because apart from the contractor, majority of the work has been done by the applicators. And if we train those applicators with the SOPs or by the ministry or IAHE, we can uplift their working style. Then non-compliance. Manufacturing installation guidelines are never followed, as it is not binding to the contractors. Again, a quality check, absence of SOPs for checking and installation anchors, quantity of grout, wire mesh installation without accessories. So these kind of total scenario, if we take care of these all the point holistically, we can upgrade the tender document so that the bidding can also be enhanced and the quality of the work can be enhanced. While while after the bidding, there are the 4 major points which I want to discuss, like the quality of the material, which is one of the main tasks which need to be checked. Then second thing is the workmanship. Then the quantities. Yes, the contractor which is doing the execution work, what kind of quantity he is using, and the quality of this quantity is being taken by the source or not. And last is not the least is testing, because testing is very important. Going with the quality of the material, these are the photographs I have taken, because I am there based out of Uttarakhand and I used to travel each and every location. This is kind of the material which is look-alike. This is lower in tensile strength than specified. Mesh opening is higher. Use of recycled and low-grade steel is there, and absence of ETA certification. Insufficient quality check. Material test certificates are custom-made. No third-party lab validation. Approved and used material are often different, because once the contractor initiated the work, he take the source approval of very good companies which is there in the market, and once he takes the material initially, he will not come back to taking those material again. The contractor takes look-alike material, and normally the material is very look-alike to the higher quality of material. So that gives him a space to make the cost low and to do the work. And look-alike material from a distance for all rope wire nets look similar. From distance, if you look, that's all the wire mesh are look similar. But when you go closer, you find the real differentiation. Knotting, clips are the integral part of the system, and the compromise of the clip can lead to the failure of the mesh. This photograph is that it is already written 8 mm wire, and if we check that, it comes around 7.5 mm. So these kind of material has to be checked. If we talk about the quality, again, if we go about the clip of the mesh, this is how the clip is made. It is 2.5 male part and the female part is 4 mm. Clip crimping is done by applying a uniform pressure with the state-of-art hydraulic pressure. We have already embossed the company name also, which shows that the product is of the top quality. Because if the name of the company is there, you can check any time at the time of execution. And the logo gives the authentication. Produces high junction strength of 18 to 20 kilonewton. This is how we there are 2 different kind of meshes. One is thickness of clip. One is good quality of material. Second is non-standard material. Non-standard material gives the junction strength of 6 to 8 kilonewton. Apart from the quality of the material, workmanship is very important. Here, if you see, the good quality of material can also fail if the workmanship is not proper. And in this slide, if the first photograph, if you see, the ropes are missing, wire rope cables are missing, top and bottom ropes are missing. The 2 meshes overlaying and the connection of the 2 rope meshes are missing. In this photograph, if you see, there is a minimum quantity of mesh, I think, which is required to be installed. So the contractor installed a single panel of higher mesh, and apart from the all secondary mesh to complete the quantity only. As per the tender document, the minimum quantity which is required to be installed, so the only one mesh is there only in the system. In this photograph, you see like lacing wire is missing between the two panels. Same lacing wire is missing between the two panels. So these kind of accessories or these kind of workmanship, if a good quality of material is there, still it will not give the better result. So these are the some best practices which is required to be followed, and if we uplift the applicator base to refine them and to learn them how to install the meshes and the anchors, so that it can be give the good quality, and with these kind of accessories, the total system gives better quality. If we stretch the mesh with the ropes, cable, rope anchors, and these kind of accessories which is installed, so definitely the performance of the overall system will increase. This is again a slide for workmanship. These kind of drifter machine is being used for drilling, and these kind of drifter is a customized made machines which gives so much of vibration. And while giving the while doing the installation of the anchoring, if these kind of vibration is there, definitely the hole will collapse. And there is a system like if you done the drilling, the grouting to be done within a span of 2 to 4 hours, not more than that. Because if you don't do the grouting at the same time, the hole will collapse. So these kind of machines give in the first photo, these kind of machine gives so much of the vibration that the hole will collapse. And for that we have to take these different kind of machines which is more affordable and give the customization to do the drilling with a different angle which is required for the drilling. So these are the anchors which is used. The extended length of the exposed anchor is so high. Improper inclination of the anchors. Use of the proper grouting machine. So these can be like formed if we take good quality of machine and better check what kind of grout is there, and the drilling, after drilling, we need to do the grouting at the same time. This is again one major thing, like majority of the companies give their MTCs, and with MTCs we request like if there is a scanner, so that it can be taken care at any point of time what kind of material has been taken by the contractor at what time and on what project. The introduction of the conformity certificate will, through the checks on material quality, establish accountability at the source, support cross verification with site execution and PMC. Apart from that, if the QR code is there, so it will eliminate the fake and compromised document, strong audit compliance, and prevent the use of look-alike material in the system. While going with the workmanship, quality of the material, quantity of the material, still one more thing is very important, is the testing. While the cherry picking testing, majority of the contractor used selective location, which is the favorable location, which is very near to the roadside, because there can be easily pull out test can be done. And the length of the anchor will also at the as per the required as per the tender. But if you go up the hill, the pull out test is not easy task. So in that scenario, the length of the nail shall be compromised. So we have to check and we have to place one system for the testing. Manipulation of the testing is there. Some samples submitted of the testing are sourced from the superior quality, and other material which has been taken by the contractors from the inferior quality. These kind of things are going in the tenders and by the contractor. Manage third party test. Third party testing is also is visible during the inspection with the substandard areas temporarily concealed or cosmetic correction before. And non-adherence to the test frequencies, because it is very important that with no objection, critical time and logistic pressure, with no objection raised due to the lack of strict oversight. So way forward, there are the 5 points which need to be included, which I recommend to upgrade the system, is the performance-based specification, because once the DPR has been made, the specification has been taken as per the customized site requirement. The kind of material has been taken care, but at the time of tender, there are only 2 or 3 different kind of specification, 150 kilonewton of tensile strength, of 100 kilonewton of tensile strength. It doesn't go with the requirement of the site. Pull-out capabilities, tensile punching strength, durability, these kind of scenarios to be taken care. Mandatory system certification, ETA and CE mark is very important. Mandatory source approval, only the eligible and the most competent manufacturer will qualify for supplying products. Documents to include material test certificate, ETA and CE. Product data sheets. Introduction of the QR codes. QR code based MTCs is required to give the validation of the certification, date, issuance, total quality and cumulative quantity, point of contact. And mandatory checks are also important. The ETA, if the outsourced material, imported material is coming to India, the ETA certified being imported should be necessary have the packaging list, country of origin, detailed ETA certification issued in the name of client, and the performance certificate. These are certain photographs which we have done in our project. This is the slope stabilization work has been done. Good quality of work has been done in Uttarakhand by the contractor taking whole material, as well as rockfall protection work at T4. This is again a USBRL project of railways. It has been a prestigious project of ours. We have used DT mesh, ETA certified rockfall barriers, and this is already been operated right now. This is a work of Texlope mesh which we have installed in Sri Lanka outside India. This is again the quality of the work and the quality of the workmanship is very fine. This again is a slope consolidation at Guwahati multipurpose project. There is a water tank at the very height, and this water tank, we have to protect that water tank because there is a vertical slope. So we have given a solution of RS wall with erosion control beside, so that to give the higher risk-free protection of the water tank in the area. This is a Zyka funded project which we have done recently. For concluding, I have taken 5 major points which we can taken care of. Empanelment of the skilled and certified applicator through process of training by OEMs and IHE, etc. Increasing PBG amount. If the PBG amount increased by 5 to 10%, and we can give that PBG amount on a pro rata basis on the time based. Experience of PMC like IITs or some NIT, CRRI shall also be included for a vetting of the design. Method statement, mandatory statement submission which include installation sequence, equipment and trained manpower, safety and quality checks. Stage-wise inspection is very important after drilling, borehole grouting, before shortcutting, before mesh fixing, post installation of the quality check as per the manufacturer guidelines. And last, DLP period check, putting the maintenance clause and inspection guidelines during the DLP period. So the slope protection system is an installation sensitive system. Even high quality of material fails if workmanship is compromised. Thank you. Okay. Any questions?
Do we have any questions? We can take 1 or 2 quick questions for sir.
क्यों ना प्रॉब्लम।
हाइट मेजरमेंट करने का कोई तरीका है जो ग्राउंड से मेजरमेंट कर सके? क्योंकि हम
वो
expert नहीं
तरीका
होते हैं।
एक्चुअली वो तरीका अभी तक नहीं है कि हम ग्राउंड से मेजर कर सके या बाहर से चेक कर सके,
क्योंकि वो फिर
बिकॉज एक तरीका ये है कि जब हम बहुत ज़्यादा हाइट पर काम करते हैं जहाँ पर एंकर्स लगते हैं
सर,
तो हम कम डाया का उसमें बार डाल करके चेक करते हैं,
वो तो
दैट इज़ वन थिंग। बट अपार्ट फ्रॉम दैट देर इज़ नो फुल प्रूफ सोल्यूशन टू चेक आफ्टर इंस्टॉलेशन की कितना लेंथ गया है एंकर का। सो फॉर दिस आई हैव टेकन द पॉइंट कि क्वांटिटेटिव एनालिसिस भी होना चाहिए कि मटेरियल जो कॉन्ट्रैक्टर अगर प्रोक्योर कर रहा है तो कुछ OEM से कर रहा है, बिकॉज कॉन्ट्रैक्टर जब OEM डिसाइड करता है तो वो उसका सोर्स अप्रूवल कराता है,
सर
और जब वो सोर्स अप्रूवल कराता है तो उसमें 3 से 4 कंपनियों को वो अपने अप्रूवल में रखता है। अगर डिपार्टमेंट चाहे या स्टेक होल्डर्स चाहें तो वो चेक कर सकते हैं OEM से भी कि उस प्रोजेक्ट में फॉर दैट प्रोजेक्ट ओनली हाउ मच मटेरियल ही हैज टेकन एटलीस्ट, एंड द QR बेस्ड मैंने वो डॉक्यूमेंट दिखाया था, तो इट कैन बी वेरीफाइड एट एनी पॉइंट ऑफ टाइम वाइल चेकिंग थ्रू द QR कोड कि इस प्रोजेक्ट में कितना मटेरियल गया है, कितना रिमेनिंग है, और किस लोकेशन पर किस OEM से इन्होंने मटेरियल लिया है। तो एटलीस्ट यू शुड चेक कि इस प्रोजेक्ट पर इस कॉन्ट्रैक्टर ने इतना मटेरियल ऑलरेडी प्रोक्योर किया है। दिस इज द ओनली वन थिंग जो हम अभी सोच रहे हैं, इनिशिएट कर सकते हैं।
थैंक यू सर।
Anything else? Okay. Thank you very much.
Thank you very much, sir. Ladies and gentlemen, we'll now pause for a 45 minutes lunch break as we are running behind schedule. So we would request your cooperation to kindly reassemble at sharp 3 p.m. for our next session. The venue for lunch remains the same as tea, that is Leaders Lounge and the pre-function area outside the hall. Thank you very much. Enjoy your lunch and kindly reassemble at sharp 3 p.m. Thank you. I now request Dr. Akanksha Tyagi to kindly take the stage, Assistant Professor IIT Roorkee, and present on geophysical and geotechnical data-based numerical modeling of rainfall-induced instabilities in Himalayan debris slope. Over to you, ma'am.
So, hello everyone. Good afternoon. So, I'm Akanksha Tyagi, Associate Professor at IIT Roorkee, and today I'll be presenting on geophysical and geotechnical data-based numerical modeling, which helps us to predict the time of failure and also helps us in decision making for the instrumentation and monitoring systems of landslide slopes, and also helps us in the decision making for taking timely strengthening measures. So this is the outline of my presentation. Now, there are several triggering factors for landslides, and from the morning onwards, we are talking that the rainfall is the main culprit. And so basically, what happens is I'm going to tell why the rainfall is the main culprit and what's actually is happening in the slope. So basically, whenever there is a rainfall, the rain gets infiltrated into the strata, and before the rainfall, there is some suction in the slope, which is a negative pore water pressure basically, and it provides strength to the slope. Now, what happens because of the rainfall? The zone becomes saturated, and slope it loses its suction, and the pore water pressure increases, and that's why you get failure. Now, because of this, there are several failures that are across the Indian Himalayas, and these are the pictures that we took in September 2022. These are all debris slopes. Now, so I'll be talking about some of the results that we got in the project that is sponsored from Ministry of Road Transport and Highways, the development of guidelines for instrumentation and real-time monitoring of hill slopes. Now, within this project, we have picked up this slope. This is a Gular slope in Rishikesh along NH07. And basically, we selected this slope based on the workshop that we conducted in 2024, in which many of the participants or audience who are here today, they actually attended that workshop, and they helped us in making decision of picking up the slope. So basically, this is a debris slope that you can see, and it was eroded, and you can see there is a very less vegetation on this slope. The failure happened such that the debris actually it covered the retaining wall system which was present there, and it was covering towards the center line of the road. Now, to start with the monitoring, first we wanted to understand the slope. So we conducted the geotechnical investigations and geophysical investigations. Now, in geotechnical investigation involves borehole drilling, and borehole drilling usually it is done up to 20 meters, 30 meters. So we did 20-meter borehole drilling. It's an invasive type of method, and that's why it disturbs the slope. Usually for borehole drilling, you need a 20 feet by 20 feet platform, and therefore it's not possible usually to do this kind of borehole drilling on the slope. That's why we did the borehole drilling on the crest of the slope. And on the slope, also we wanted to know what is the strata. So we did electrical resistivity tomography, which is a non-invasive type of method. Now, you can see that red dot where we did the borehole investigation, and you can see it is a 2-ton rig which was used. for this type of investigation. This is the core box. And the borehole investigation revealed that actually up to 20 meters, the RQD was nil. So the overburden that we saw on the top of the slope, it was there prevalent up to 20 meters at least from the borehole investigations. Because when we see these type of slopes, we think that it is only up to 2 meters, 5 meters, and we will get some stable strata after a few meters. So this is the ERTs that we did, and you can see here there are total 4 lines that we did on this unstable slope, and we did along the slope, 2 across the slope, and finally we also did along the road. And why we did that, I will let you know. So basically, when you do geophysical studies, it is very important that you should have borehole data with you, because otherwise it is very difficult to correlate your geophysical data and interpret those results. Why? Because usually, geologists, they refer to the material as heavily weathered rock or moderately weathered rock. However, in this strata, when we did geotechnical investigation, we found that it's a silty sand with gravels and boulders. So when I say that it's not heavily weathered rock, but it's actually silty sand with gravels or boulders, your approach towards the problem changes. The whole methodology will change for the analysis as well as for the strengthening measures. So once we correlate our geophysical resistivity, our ERT resistivities to the borehole, then basically you can see that this is a very heterogeneous slope, and along the slope there are boulders inside this soil gravel matrix, and this is across the slope. There are zones of which are classified as saturation as well, but they need not to be zones of saturation, but maybe they are very soft soil zones. So this is another ERT. Now, after doing all this ERT on the slopes, we found there was no stable strata. And that's why we decided that let us have ERT along the road itself. And from the ERT on the road, we found that up to 30 meters, below a few 35 or 40 meters, the Ganga river is flowing. So in fact, for this slope up to 30 meters, there was no stable strata. So all you see is the overburden, and we can expect the same overburden. Now, what is the takeaway from this type of investigation is that, we should always do geotechnical laboratory investigations along with the geophysical investigations to have a complete picture about what problem we are addressing. Especially, see, it was a landslide. So on the top, you could see what is the material. But especially in tunneling projects, when you don't know what is to be there, then it is very important that you have some idea of what is the material, what the actual material is. So let us come to the landslide again. So this is the INSAR results analysis, which was done by Professor Alok Bhardwaj's research group at IIT Roorkee to find out when this failure occurred. So this failure occurred actually in year 2020, and from the satellite images, they found out that the failure occurred due to the expansion of road. So the main culprit was the expansion of road, and subsequently then, because the landslide got unstable, because of the rainfall events, this landslide or instability occurred. Increased with time, and then it became kind of a perennial landslide up to 2025. This is the data, and till date actually this slope instability activity is happening. So what we did is from the unmanned aerial vehicle, which we also say drone, from the drone survey, we found out what is the typical geometry of this slope, and we took the worst cross section. Now, this worst cross-section, basically, we modeled in a finite element-based software, or you can also model in limit equilibrium-based software, which is a GeoStudio. So today I'll be just showing you the limit equilibrium analysis that we did in GeoStudio, not the FEM analysis. So you can see that 19 meter is the road, and this is the whole geometry of the slope. And basically, these are the input parameters. Now, so this is very technical, but what I would like to point out here that usually in our analysis, we take cohesion, friction, unit weight, that's it. But here, we are also modeling the unsaturated behavior or partially saturated behavior of the slope. So we are going to actually model the rainfall infiltration, and we'll see how the factor of safety will change with the rainfall. Okay, so for this type of analysis, we actually need this. This is very important. This is like a fingerprint of soil. So this is a soil water characteristic curve. This is volumetric water content versus metric suction. I think many of you were saying that we should, put a tensiometer, a suction sensor, or a volumetric water content sensor in the soil, in the field. Why? Because, every soil has this soil water characteristic curve according to which it behaves. So you can see the suction actually is very high when this water content is low, but the suction is low when the water content becomes higher. Means during the rainfall, the suction will be lost. So from this is all research based. Yellow curve is from the empirical equation, and orange one is from our lab test. Black curve that you see is the final predicted curve that we are using for our analysis based on our laboratory test and also the literature which was present. So you can see here that for the given parameters, okay, for the given cohesion, friction, saturated permeability, metric suction, you can see here, this is the factor of safety. The blue curve shows the factor of safety, and the orange one shows the cumulative rainfall, and the x-axis is the days. So you can see here the initial factor of safety, which is the one which you get in the conventional analysis, in the conventional practice. In the morning, somebody was saying that we are only analyzing it for the dry period. So the first factor of safety is for the dry slope. Now, when the rainfall occurs, you can see the factor of safety has reduced in particularly, and it goes below 1 at the 207th day, which I define here as a time of failure. So basically, this is occurring in mid-July. So if we are actually, we can, model our slope like this, we can actually predict the time of failure. This is the back-analyzed time of failure. But I know now the properties of the slope. And so in future, if somebody is, trying to stabilize this slope, I can do the similar analysis even with the extreme rainfall events, and I can actually predict the failure. When, what is the time that it's going to happen? It's not, 100% correct, but there is some limitation to this analysis. But actually, this is predicting that, in 2020 rainfall, this slope failed. Now, you can see here, this was the initial suction, and there is the critical slip circle. And there is this video, it is showing you how the saturation is, changing in the slope. So basically, you can see the colors are changing. And when this slope is becoming saturated, it is becoming saturated because of the rainfall. Okay? Then actually, your slope will fail. So what is the use of this kind of analysis? It's not purely academic. Basically, the use is when we say that I want to use volumetric water content sensors to monitor the saturation, or I want to use tensiometer, or I want to use an inclinometer. This kind of analysis gives you some idea, where to use these kind of sensors. Okay? Now, based on this, our analysis, based on the literature review, also we discussed with the experts from Norwegian Geotechnical Institute and Japan, so that, we are not, we are actually, the sensors that we are using here is actually global practice, and we are in line with what is currently happening in the world. So you can see this is a slope, and the yellow boxes that you see are the data loggers, okay? And those orange cylinders and blue cylinders, those are in-place inclinometers and piezometers, okay? And you can ask also why I am putting those sensors in the green area also in the stable slope, because in this project, we also wanted to compare the unstable slope versus a stable slope. Like what is actually happen in that besides the slope that and the failure is happening. Because, you know, when we did the borehole investigation, the similar kind of strata was there in the stable slope also. So the triangles that you see are the volumetric water content sensors, and that sign is also there, double triangle sign for tensiometers and the volumetric water content sensors for the suction stress and the pore water. Now, when you see this laboratory studies, you know, or numerical studies, people will tell you that put the inclinometer there where you see the critical slip surface. But we didn't. And there is a reason, because, you know, inclinometers, they need borehole drilling, and borehole drilling needs you to make a platform of 20 feet by 20 feet. So it's not, you know, you will disturb the slope. So unless you have a berm there, you cannot actually put the inclinometers. So, but every slope is unique. If you have a berm in the slope, in the mid slope, then actually you can put the inclinometers. In addition to this, we also put the low cost camera network. So that those low cost camera network are there, they are actually CCTV cameras, which are actually giving us the real, they are actually for the real time monitoring of the slope for the, so it's covering all the parts of the slope, and in real time we can see the slope. However, today I'll not be able to show you because of some, here there is some network issue, so I'll not be able to show you that. So this is the in-place inclinometers. We have put it at certain depths, 3 in-place inclinometers, you know, in each borehole, and 3 piezometers in each borehole at different levels. This is also based on the, whenever you drill the borehole, you will also get the report of the change in levels. So accordingly, you can decide where to put the inclinometers or piezometers. Although what we think, it's a general practice to use inclinometers or piezometers. We have used this because it's a general practice. However, for this kind of slope, you know, where the water level is not going to change much, we don't expect that the piezometers will have a bigger role to play. But in order to conclude that, we have actually installed this. So my purpose is not, here we are not giving solution, that it's not a copy paste solution that you have to, you know, copy paste this solution to every slope. Basically, this is kind of a study that we are doing to find out what is the optimal sensor location, or what sensor we should use for these kind of debris slopes. So basically, the conclusion here is to show you that by geotechnical and geophysical data-based numerical modeling for partially saturated slopes, we can actually, it is helpful for the back analysis where we can predict the failure due to the rainfall, and it is helpful in deciding on the monitoring systems. It is helpful in decision making for the timely strengthening measures. These are the relevant outcomes. We have also given a draft guideline for geotechnical and geophysical investigation for Himalayan debris unstable slopes along the hill roads. I would also like to add, besides this project, my research group also did a study for Konkan railways. This is a lateritic soil slope, and this slope failed in August 2022. And we did the similar analysis. Okay, and we also created some time of failure charts for them, for the lateritic soil slopes. Lateritic soil slopes are more homogeneous than these Himalayan slopes. So for lateritic soil slopes, for different slope angles, for different geometries, we actually gave the time of failure chart so that you can actually see, you know, for a given lateritic soil cut slope, when the failure can happen, at which rainfall intensity. And this was published in a reputed journal of engineering geology. So these are the references. This is our group, which is working in the MOD-sponsored project, and the students. And I'm very thankful to Ministry of Road Transport and Highways for giving us the opportunity to work on this project. It's a five-year project. So in the coming years, we'll be giving you some of the data which we get from, you know, 1 or 2 monsoon cycles. So we'll be able to tell you how, you know, what to do with the sensor data. I told you we put the sensors, but what to do with the sensor data, that we'll be telling you after 1 or 2 monsoon cycles. Thank you.
Thank you very much. Ladies and gentlemen, I will now take this opportunity to felicitate our learned and esteemed speakers who've presented till now. And post the ceremony will continue with the remaining presentation. May I first invite on stage Professor J.T. Shahu from IIT Delhi, our esteemed presenter. Sir, to please join us on stage along with Shri Amrendra Kumar, Director Tech NHIDCL. I request Shri Amrendra Kumar to kindly present a token of appreciation, a token of respect to Professor J.T. Shahu from IIT Delhi. Ladies and gentlemen, let's all put our hands together and thank Professor Shahu for joining us for the technical workshop and sharing his valuable insights with all of us. Thank you, Amrendra sir, for doing the honors. We'll now felicitate Shri Jitin Mukheja from GeoBrug. Mr. Jitin, to please join us on stage. I request Mr. Adil Singh, ED NHIDCL, to please be on stage and felicitate Shri Jitin Mukheja from GeoBrug. Shri Jitin, to please be on stage and take the center stage. Kindly take the center stage. Ladies and gentlemen, let's give it up for Shri Jitin Mukheja. Thank you very much. We will now felicitate Colonel Soumendra Banerjee from GeoQuest. I also request Srimati Ral Simmi, GM Tech NHIDCL, to kindly be on stage and present a token of appreciation to Colonel Soumendra Banerjee. Sir, to please kindly come on stage and take the center stage. Kindly take the center stage. A round of applause for Colonel Soumendra Banerjee. Can we give him a more energetic round of applause? Thank you very much. May I now invite Shri Arvind Ganesh and Shri Rudra Buddhabati from Macquarie to kindly come on stage. I also request Shri Ankush, GM Tech NHIDCL, to kindly join for the felicitation. Please put your hands together for Shri Arvind Ganesh and Shri Rudra from Macquarie. So, Ankush sir, to please present it to Shri Rudra as well. Thank you very much. We'll now felicitate Shri Ankur Saxena from TechFab. Shri Ankur Saxena. We request Dr. Akanksha Tyagi, who've just presented, to please join us back, Assistant Professor IIT Roorkee. I request Shri Manoj Kumar, ED NHIDCL, to please take the stage. Kindly take the center stage. Let's all give it up for Dr. Akanksha for sharing her expert insights, on-ground experiences with all of us. Thank you, Manoj sir, for doing the honors. I request Mr. Ankur Saxena to kindly be on stage from TechFab. Sir will now be felicitating you and thanking you for sharing your expertise with us. Requesting Shri Trivendra, EDNHIDCL, to please be on stage and present a token of appreciation to Mr. Saxena. Sir, please take the center stage. Thank you very much. And now, ladies and gentlemen, we'll continue with our presentations. Coming up now is a presentation on geological, geotechnical, and geophysical investigations for landslide and slope stability assessment. To deliver this important presentation, may I invite Sri Lalit Pathak from Gripple to kindly take the stage. Sir, over to you.
Good afternoon, all of you. I know this post-lunch session can be a bit heavy, so I'm going to keep my presentation precise, and I'm going to stick to my baseline of this, that is geological, geotechnical, and geophysical investigation for landslide and slope stability assessment. So why this topic matters? As we all know, slope instability is a corridor resilience issue. It is not merely a geotechnical problem. The consequences are multidimensional. A slope instability leads to blocked transport, isolated settlements, damaged retaining works, disrupted services, and direct road user risk. And the root cause is often inadequate site characterization, particularly of geology, groundwater, and slope geometry, rather than the lack of mitigation concepts. So we must focus on the investigation before moving ahead with the design. If the failure mechanism is misunderstood, even expensive stabilization may prove ineffective. So we are going to discuss an integrated framework wherein we are going to cover the geological, geotechnical, geophysical monitoring and analysis of 4 different types of terrains, starting with soil slopes, where rotational and translational types of failures are quite dominant. They are controlled by the stratigraphy, drainage, and saturated patterns. In soil rock mixed slopes, complex seepage and variable stiffness plays a major role, and irregular and composite failure surfaces are generally observed. In weathered rock mass, both rock mass behavior and structure matter, and seepage generally happens along the defects, affecting the stability of the slope. And in hard rock, the discontinuity pattern plays an important role. So to visualize this, if we look at this particular figure, in the left, we can see a soil slope where rotational type of failures are quite dominant. And in the right side, we can look at the hard rock slopes where the discontinuity patterns play a major role. So investigation priorities generally differ across the highway corridors depending on the terrain. And based on the failure modes, the investigation implications can change. For rock failures, wherein planar wedge toppling failures are happening, the priority is discontinuity orientation, study of the persistence, shear strength of the discontinuity, and water pressure. For the composite type and rotational type of failures, priority is stratigraphy, shear strength of the strata, groundwater, and slip mass geometry. For rockfall, we have to prioritize the whole system, the source area, the release mechanism, the trajectory of the rock, and the runout patterns. And for debris slides, priority is generally the hydrology, chainage coupling, and trigger thresholds. So to highlight the entire crux of this mechanism. So if we look at the different steps involved in this integrated investigation framework, it starts with the preliminary study. Then we develop the engineering geological model, followed by the subsurface investigation, choosing of the correct parameters, doing the correct analysis for the design, and ultimately the execution and monitoring. And the most important step is the developing the engineering geological model, because it translates the field dirt and rock into design math. And good investigation is a continuous workflow, not a disconnected sequence of reports. So to start with the first step, that is the preliminary study and data collection, we should in detail study the topo sheets, the DEMs, the existing geological map. We should study the past landslide records, the rainfalls, the seismic data. We should identify the scraps, the benches, drainage diversions, toe erosion, rockfall tracks, and in fact, also what is the overall consequence on the corridor. So traffic consequences, right of way constraints, and overall project function. And based on the preliminary data, we can develop a preliminary hazard interpretation report and a targeted field plan. The preliminary stage is followed by the site recurrence or the site visit. So when we do the site visit, we verify the desk study that we have done. We record the landforms, the lithology, the distress pattern, and we look beyond the road edge. We assess the entire system, from where the landslide has started, what's the source of it, what's the transit patterns, and how the runout is happening. So in the right, you can see the NBRO JICA guidelines, which stipulates the different steps involved while carrying out a site visit. So it involves geomorphological information, geological information, hydrological information, history of the landslide, and susceptibility of the landslide. Now, if we come to the most important step, the engineering geological mapping. So basically, when we develop the geological map, we should study the lithology, weathering patterns, study in detail about the faults, the foliation, joints, and drainage features, how that particular geology is altering with the overall interaction. So how the road cut has altered the lateral supports, the intercepted groundwater. And based on the geological mapping itself, we can plan for the borehole targeting, where the borehole should be carried out, and the overall development of the model that we need to do for the analysis. So in the right, you can see an example of a geological mapping, which is a recurrence level geological map. And a different type of geological map is being shown where the faults have been properly mapped. And if we are talking about a typical hard rock, jointed rock mass, then structural geology also plays a major role, wherein we record the dip and dip directions, the spacing of the joints, the persistence, the roughness, aperture, infilling, and water conditions. And just the orientation of the joint itself is not enough. We need to record the persistence of the joints, the infill patterns, whether the slope is going to be remaining stable, reveling, or sliding, or toppling is going to happen is basically determined by the persistence and what is basically lying in between those joints. Now, depending on the area that we are doing the geological mapping, either we can adopt line mapping, window mapping, or a scan line map can also be developed. And to expand the horizon of the geological mapping, we can rely on remote structural mapping using imagery, point clouds, and laser scanning. So this is a typical discontinuity survey data sheet adopted from the USGS and also followed by the GSI, wherein we record the dip direction, the persistence, termination, aperture, and other major factors which basically governs the discontinuity and behavior of the rockfall. And to expand the horizon, we can rely on aerial photography, unmanned aerial vehicle surveys, LIDAR, and laser scanning. So it acts as a multiplier of geological understanding. It is not a replacement for the field geological mapping. Now, coming to the next component, that is the geophysical investigation. So why are they exactly needed? Why do we do geophysical investigation? Now, when we do the boreholes, they provide excellent point-based data. Wherever the borehole is being carried out, we get the data for the isolated points. Now, if you look at the right image, this is a particular slope failure where we have done the study in the state of Manipur, where we carried out 2 boreholes at the right flank and left flank. But after we carried out the geophysical investigation in the form of ERT, we found out that there is a probable existing drain filled up with colluvium. Otherwise, we would have just got the point-based data of BH2 and BH3, and this existing drain filled with colluvium would have been completely skipped. So in order to summarize, Geophysical fills the gap that geotechnical leaves. So it interpolates between the boreholes and detects concealed variability. And through geophysical data, we can determine the bedrock depth, buried channels, fractured zone, saturated slip planes, and weathered interfaces. So what's the best practice? We should use geophysics as a model building and borehole targeting tool. Geophysics cannot replace geotechnical investigation. Now, these are some of the generally used geophysical methods: ERT, SRT, MASW, GPR. Each one of them has specific use case. So for ERT, the main use in slope investigation is identification of bedrock depth, identification of saturated zone, buried channels, slip surface contrast, weathered interfaces, and lateral variability between boreholes. For SRT, it is useful for depth to competent rock measurement, low velocity weak zones, fracture belts, rippability, and broad velocity architecture of the slope. MASW, it is best for stiffness profiling. It distinguishes between the soft slide mass from the substrata and helps evaluate weathering depth or weak overburden. And GPR, it can be used for shallow high resolution imaging of near surface discontinuities, void-like features, etc. Now, there are key limitations also associated with different geophysical methods. So for ERT, we should not use it on a standalone basis for slip surface confirmation without drilling or geological control. For SRT, we do not rely SRT alone where complex layering or velocity inversions are expected. For MASW, we do not assume MASW can be precisely used to define the thin slip surface without support from other data. And for the GPR, it is basically not used as a primary method of deep, wet, clay-rich landslide slope investigations. Now, where exactly to carry out the geophysical study? Where the profile should be laid? So as per JICA guidelines, at least one longitudinal profile needs to be carried out, where starting from the crown of the slope towards the toe, the entire geophysical line should be done, and at least 2 to 3 transverse profile needs to be carried out, covering the entire flank of the landslide. If possible, if we need to carry out even more investigations, then across the road, we can do that. And if there are multiple cracks, then we can target those anomaly lines and use the geophysical method. Now, once the geophysical investigation has been done, in conjunction to that, the geotechnical investigation is done. So what's the drilling strategy and borehole planning? So as per JICA, at least one borehole shall be done at the upper part and 3 boreholes at the lower part of the main line of the landslide. And for a small scale landslide area, at least 2 boreholes shall be installed to understand the geological condition of the area. If time permits and if budget is more, then multiple boreholes can be done within an interval of 30 to 50 meters. Now, when it comes to the geotechnical investigation, core logging, sample quality, and orientation of the core also plays a major role. Specifically in rock slopes, discontinuity orientation from surface mapping is usually more reliable than from non-oriented core. So if we are taking out cores, the orientation of that core should also be recorded. And for the proper sample quality, triple tube core barrels should be carried out, and careful handling should be done for the closely fractured and weak rock samples. Now, geotechnical investigation also includes groundwater and hydrogeological investigations. Since groundwater is a key trigger for slope instability, we need to map the seepage points, the perched horizon, and seasonal piezometric responses. And why do we need to measure these seasonal piezometric responses? Because we just cannot trust the dry logs. So assuming that we do a geotechnical investigation in the month of April, May, when the season is dry, our entire investigation can go haywire. So to verify and develop a dynamic model, use of standpipes, vibrating wire piezometers, packer test should be coupled so that we get the proper behavior of the groundwater. Now, talking about the laboratory testing framework, so once the geotechnical investigation is done, depending on the type of strata we are dealing with, if it is a soil strata or a collivium strata, index testing, density, permeability, and shear strength testing must be done. Of course, the shear strength testing will be dependent on the type of material that we are doing. So if suppose the soil is mixed with boulders and large size boulders are present, we can go for a large box direct shear testing. For weak and weathered rock, point load testing, UCS, slake durability and porosity can be done. For hard rock, intact strength, elastic modulus, and pulse wave velocity needs to be studied. And to understand the discontinuities and how they are behaving, direct shear testing on the rock joints and infill characterization plays a major role. Now, one of the most important aspect is field monitoring. So whenever geotechnical investigation is being carried out, it should always be supported by field instrumentation because it gives us a time-based model. Instrumentation converts static investigations into behavioral models. So I'll quickly talk about some of the different instrumentations that we generally deploy in field. So wire crack meter, vented pressure transducers, inclinometers, piezometers, and metrological stations, crack meters, wire deformators, waterproof tilt meters, and anchored load cell are some of the different instrumentations deployed in different types of slope to measure the overall behavior of the slope. Now, once we have all the data, we derive the parameters. So for slopes with soil and SRM mix, soil rock mix, the shear strength parameters in the form of Moore Coulomb parameters, cohesion and angle of internal friction. For the intact rock, the UCS value, the modulus of elasticity. For the rock mass, highly jointed rock mass, GSI values, the RMR values, the SMR values. And for the discontinuities, joint roughness coefficients and the infill characteristics plays a major role. So if we want to move to the analysis, it starts with the parameters that match the ground behavior and choose and what analysis method we are actually selecting. Now, based on the investigation outputs, we generally govern the analysis selection. So if we are dealing with a hard jointed rock mass, we do the kinematic analysis. If we are dealing with a soil colluvium and soil rock mix, either we can do an LEM or an FEM or an FDM analysis, which assumes the entire strata as a continuous rock mass. And if we are going to study the blocky persistent joints, then discontinuum analysis is generally followed. Now, to help you visualize, in kinematic analysis, we do the stereographic projections, we do the kinematic analysis and identify the wedge failures, the toppling failures, the planar failures. And if we are doing in LEM, FEM based analysis, we generally talk about the factor of safety of slope, the rotational behavior, and how the overall slope is, deformation is happening. In discontinuum analysis, we basically model all the joints. The joint infilling properties also play a major role. And in the rockfall, we follow the rockfall trajectory, the release point, the impact point, and how the path of the rockfall is going to govern the overall failure. Now, what to expect from a high-quality geotechnical investigation report? So a high-quality investigation package must include an engineering geological model, geological cross-sections, material zoning, site-specific slope geometry, dynamic groundwater model, discontinuity set models, stereo nets for rock slopes, the different parameter ranges, uncertainty statements, and recommended analysis paths, and of course, the instrumentation and long-term monitoring plan. So we are running short of time. So this is a consolidated list of literature that one can go through if you want to delve deep into this topic. Thank you.
I now request Shri S.B. Singh to kindly join us on stage, ED NHIDCL. Request Mr. Pathak to kindly take the center stage and give us this opportunity to thank him by presenting a token of appreciation. Ladies and gentlemen, please give it up for Shri Lalit Pathak. Thank you very much, sir, for a very highly informative presentation. Thank you, Mr. Singh, for doing the honors. Ladies and gentlemen, we now move to our next presentation on application of drones and laser scanners for landslide studies along national highways in the Indian Himalayas. To present this fascinating and highly relevant topic, may I invite Dr. Alok Bhardwaj, Assistant Professor, IIT Roorkee. Over to you, sir.
All right, good afternoon to all of you. So myself, Alok Bhardwaj. So I'll be speaking on the application of drones and laser scanners for monitoring landslides. I'll be focusing on these two technologies, but I'll also be giving you a general idea of the different geospatial technologies that we can use to monitor the landslides. I'll be speaking on landslide detection at the regional scale, also at the local scale using drones and INSAR, and landslide monitoring at the micro scale when you have single landslides using terrestrial laser scanners, and also the fusion of the UAV and the laser scanner point cloud data. So this is a landslide atlas of India released by NRSC. It shows that our India is exposed to landslides in different parts, in different states. In particularly in Uttarakhand, along the national highways, there are a lot of landslides that are happening. So we need to do something to also monitor them over a longer period of time. These are the typical examples of the landslides one can see when one is going in the Uttarakhand, and also similar landslides also occur in the different states of India, and everyone is aware of that these landslides are happening, and also different type of landslides that are there. So if one wants to do a monitoring of the landslide, so one has to do a regional scale study where they have to do a landslide detection. So this landslide detection is really important at the regional scale. After you identify the landslides at the regional scale, you can do a periodic monitoring at a local scale using techniques like interferometry, synthetic aperture radar, or the drones. And then after that, you can shortlist one or two landslides where you can apply or use the terrestrial laser scanners as well as the camera systems to do near real-time monitoring of the landslide activity. So first, I'll be showing you at the regional scale. So this is one of the tools that my research lab has developed at IIT Roorkee. So this tool basically gives the power to the user to detect the landslide at a regional scale. It's a scalable solution. It can go from a few kilometers to to about a couple of hundred of kilometers, and we have tested that for the entire length of the national highway NH7 in the Uttarakhand. So whenever a landslide event happens, you have to select a few dates when the event happened before that and even after that, so that you know the period where you need to select the satellite images. So this tool is based on getting a satellite image at a 5-meter resolution, which is good enough to identify landslides, medium to large size landslides in your study period. You can also select your area of interest where you want to identify those landslides, and you can give those dates. So a few example of the dates that have been given over there, and the area of interest that you can select. So based on that, this tool can give you some of the images pre-event and the post-event. You can go through all those images. You can click on the images. You can see that where the footprint of the landslide is in that, or the footprint of the satellite data is in that area of interest. So you can select those, and the blue rectangle shows you that where is the footprint of the landslide. The red part shows your area of interest. So based on your need, you can select either the two images between which you want to determine the landslides that are occurring. You select those images. Now this shows that, so this tool has been developed in the AWS cloud. So it does all the data processing. A lot of digital image processing goes into this on the images, satellite images that you have selected to identify the landslide. So a typical result is something like this. And these are not point locations. These are the actual landslide polygons showing you the boundary of the landslide that it has covered. And this is also what we also call as a landslide inventory. And a lot of the time, whenever we are talking about landslide susceptibility, hazard, or risk, the input that goes into calculating all of this is the landslide inventory. So what we focused on is on the development of a tool that can, create that landslide inventory. And based on that landslide inventory, you can further do susceptibility, hazard, or risk analysis. And so this is how these landslide polygons are created in this analysis, and then you can also visualize that in a graphical user interface. This we developed, we are trying to develop for Uttarakhand and the Himachal Pradesh, but an AI/ML algorithm goes into the development of this. But we used those algorithms and we tried and tried to test that in Sikkim region. So last year, this event happened in an army camp in Sikkim. So that's a pre-event image, that's a post-event image, and one would want to know that where the landslide polygon is, like where the landslide has actually happened. So here it is able to select that where the landslide has happened. And such a tool can be used to develop a historical information of a landslide activity in a given area. So this is one of the research papers from our lab where we try to get the historical information of the landslides that were happening in from Rudraprayag to Sonprayag. So that is a very active area of the landslides in Uttarakhand, and we did that for the past 8 to 10 years. And we tried to develop a database of the landslide inventory for this region. And then we also went into the field to validate whether the landslide inventory that we are getting is correct or not. So this particular tool, so the blue arrows that you see, it helps you to detect the new landslide, but it also gives you the information on the extension of the old landslides. Now, as it was spoken by different presenters, that one has to go into the field to identify where the landslide is happening, right? So you go into the field, you see a landslide is happening, but a more important question is that by how much the landslide has expanded in a given period of time. So this also gives you that information that how much of the landslide has expanded in that period. The information you get is in the form of landslide polygons, and it is in the compatible GIS format. So we applied that in the MOT-sponsored project at IIT Roorkee. We applied this technique which we developed in our lab earlier to identify a landslide, and we identified that there was this Gular landslide which was very active for the past many years. So it's a regional scale study where you, given a period of time, you can identify that where the landslides are happening. Now, another technique that you can use is what we call as the interferometric synthetic aperture radar. So that is a technique which you can apply using radar satellites that are up in the space. Although in this diagram, you can also see there are different other techniques like ground-based interferometer, ground-based LiDAR systems, Doppler radars. There are different kind of systems that are there. But if you really want to have a scalable solution where you can determine that where the landslide activity is happening at a regional scale over a period of time, so INSAR is one of those geospatial techniques to use. And it actually gives you a deformation from millimeter to centimeter scale. It has these satellites have these two orbits, what we call as an ascending and a descending orbit. In these two orbits, the satellites are moving up in the space, trying to cover our whole Earth. And now there are a lot of satellite data that is available, radar satellite data that is available that one can use to develop this INSAR monitoring of the landslides. So we did that for the Gular region where we try to apply the INSAR analysis. And here you can see that the flow of the analysis, that first we did a regional study. We tried to identify that is Gular. And then the second is that we used INSAR again to do the analysis for the Gular. And this result was also shown earlier, where we saw that there were a few cycles of deformation from 2018 to 2025. And where these periods of high deformation is there, that actually gives you an indication that this period you can use it to do some numerical modeling on that landslide. Now, once you have applied such type of tools at a regional scale, now when you identify a few landslides, now you can use the technology of the drones to do periodic monitoring. So here we for the Gular landslide that we identified, we have flown the drone for the past 1.5 years, every few months or so, and where you make the flight plans. These are autonomous systems, so they take those flight plans, as you can see in the top left figure. They take those flight plans, they move along those flight plans, trying to capture the landslide on the ground. We use GPS receivers that actually increase the accuracy of this aerial mapping. And so I've just shown two of these, although we have a lot of data, but we have shown you the first and the latest data that we have acquired. So the first data from the drone that we acquired for this landslide was in 24 June 2024, and the latest one was on 30th January 2026. And we can able to create digital elevation models, and digital terrain models from this. Although digital terrain model, you also need to remove the vegetation. That is one more part of the analysis, but you can also get that. Now, how can one use this information of high digital elevation model? One is that you can use this DEM digital elevation model to do numerical modeling to understand how much of the volume of the debris could be released from a particular landslide. So that kind of numerical modeling could be done. And a simple way is also to subtract both the digital elevation models to know from which part of the landslide the debris material is is coming out, and which part of the landslide it is being deposited. So you have an added information. Suppose you want to go for invasive sensors, that these are the points from where the debris material is being released. You can do some physical modeling of that to know that maybe at the crown of the landslide the debris is being removed. So here we saw that from the crown the debris was removed, that was getting deposited towards the middle and the toe of the landslide. This is another study that one can do using the drone data. So drone data, in addition to digital elevation model, also give you digital images. On those digital images, you can apply your AI, ML, and computer vision algorithms to detect the boundary of the landslide. Now, given enough number of drone data you have, you can always determine those boundaries, and you can determine whether the boundaries have extended over a period of time. You can always compare these boundaries over a period of time to know that exactly where on the landslide the activity is happening. So here the green part is used to map that the boundary of the landslide from one drone data. Now with the periodic monitoring of the drone, you have obtained some information of the landslide activity. Now the drone, which is capturing the data, it is capturing what we call as a nadir geometry from the top down. It does not have an information from the front. So for that particular information, to obtain that information from the front, one can use a terrestrial laser scanner. So here we have shown you one of those terrestrial laser scanners with some checkerboards and spheres shown by a red circle and the blue rectangle that is used for co-registration of the different scans that you obtain from your terrestrial laser scanners. Now, with that terrestrial laser scanner, you would typically get a point cloud. But the point cloud that you're getting have trees, electric poles, roads, everything. That data is being captured. You need to remove everything to get the landslide body. So a lot of pre-processing has to be done before you can get the landslide body. So here in one of the landslides, we have removed all of those features and we obtained the landslide boundary. And we did the terrestrial laser scanner study multiple times. So again, it's very simple that you can subtract both of it, and then you can know that where exactly the material is being removed from which part of the landslide, either from the crown, middle, or the toe of the landslide. Now, this is a very interesting study that we did. So that is a Rampur area, which is along the National Highway 7 that goes from Rudraprayag to Sonprayag, that comes between these two places. So we have flown the drone on that landslide, and we also took the terrestrial laser scanner data for that. On the left, it shows you the drone data. In the drone data, because of the slope overhang, it misses the data towards the toe of the landslide. So the red circle shows that the data is missing over there. Whereas on the right hand side, the data has been captured from terrestrial laser scanner from the front of the landslide. Because of the geometry of the scanner, it misses out the data towards the crown of the landslide. So if you really want to develop a holistic point cloud of a landslide, you need to do both the drone and the TLS study together to create a complete 3D digital 3D model of the landslide. And this also leads to the development of a digital twin. So in the morning session, it was talked about that the decision makers generally take decisions within the closed doors. So such type of data can be brought from the field and can be presented within the discussion rooms, where they can see the whole 3D information where the discontinuities are from the top to the bottom of the landslide. So a very good decisions can be taken if you have these point cloud data taken both from drone and the laser scanner and fused together. Although there are more techniques to that, it is not that simple to fuse. Research goes into that, a few algorithms, but ultimately you get this information. Now, in one of another mod-sponsored project at IT Roorkee, we have installed these camera systems in front of the Gular landslide. So now what we did was we went from a regional study of the optical remote sensing and INSAR to a local scale using drones and to do periodic monitoring, to now very specific one landslide to apply these camera systems. So now you are pretty sure that this is the landslide which has been active for the past 7-8 years, and it is next to the national highway, and I need to study this landslide because of the material is coming out of that. So one can use camera systems to do that. So here I'm showing you 2 examples. So here you can see this was during before some rain happened on the slope. So here on the top you can see that some of the AI ML algorithms, computer vision algorithms, have been applied on this to detect exactly from where on the slope the motion is happening and how much of the material is being released, and it is moving from the top to the bottom of the landslide. And in this research, we on the right hand side, what we have also did is that we have also tried to identify that what is the motion of the material that is being released from the landslide. So here you can see that this part is being falling down. This is basically your debris that is coming down, particularly soil, but it is also reporting you the velocity with which it is moving down. Now, based on this, you can always create some alarm system to give out some very early morning. There could be stoppage signs connected to that the traffic is being stopped, and the lives could be saved with this. So, this was a landslide where some material was removed from the toe, so these camera systems can also be used to exactly identify from where the material is being removed from the slope, and you can always map this that how much of the material, what volume of the material is being removed. So, in conclusion, I would like to say that this optical remote sensing data is useful to provide landslide activity within a given period of time at a regional scale. You can use INSAR to provide information over a longer period of time are also at a regional scale. Then you can use drones to provide higher spatial resolution images and digital elevation models to determine erosion and deposition zones at an individual landslide sites. Terrestrial laser scanners gives you very high resolution point cloud data, and that should be used in conjunction with the drones to give you holistic point cloud data, which can ultimately lead to the creation of a digital twin of a landslide. Related to this, one guideline was also submitted to the MORTH on the rapid preliminary assessment of slope instability using remote sensing and satellite products. This is our working group at IT Roorkee. I would like to acknowledge MORTH, PWD and UPCL for helping us out in this project. Thank you.
I now request Shri Biju Patir to please join us on stage. He's EDP NHIDCL. Please give it up for Dr. Alok Bhardwaj. Thank you very much for sharing your valuable perspectives and insights with us. With this, we now move to our next technical session on From Reactive to Predictive, a national framework for landslide risk monitoring on mountain highways. To deliver this important presentation, may I invite Shri Bhavik Merchant from SwanSat to kindly take the stage.
Hello everyone. Wishing everyone a very good afternoon or early evening in this case. And thank you for all the officials and the colleagues present. So today I'll walk you through a very simple framework, how satellite-based monitoring can help improve landslide risk mitigation on mountain highways. This is an attempt to explain a practical and scalable approach. So landslides, of course, everyone knows here is a persistent challenge across the mountain highways, especially in Uttarakhand, Himachal Pradesh, Jammu and Kashmir, the Northeast. These roads are built at a fairly high cost. The figures we got were roughly 15 to 30 crore per kilometer over there. But a single landslide can result, even a small one can result in 10 to 25 crores in damage and road closures for several days, which means trying to mitigate this becomes an extremely important thing for us. The road remains closed, of course, for several days, disrupting traffic, disrupting tourism, disrupting the economy. So the impact goes way beyond repairs as it affects this connectivity, logistics, and safety, of course, because many people die as well in this. And importantly, these events tend to occur. So let's look at what the current approach is, whether it's pre-construction, during construction, or post-construction. Most of the actions are triggered after the failure occurs. A landslide happens, the road is closed. Yeah, am I audible? Better. Yeah, the landslide happens, the road is closed, and emergency repair follows. And then the cycle repeats. So the system is largely reactive, not predictive. Right? So as you can see over here, a landslide often appears suddenly for people, but in reality, as our colleague previously also mentioned, the slope moves gradually over time. There is slow deformation followed by accelerating movement, and the failure is the final stage. So if we can detect this movement early, intervention becomes possible way before damage occurs. Right. So this is where continuous satellite monitoring becomes important. Satellites observe the same location repeatedly over time. By combining these observations, we can measure ground movements at a millimeter scale. This allows detection of movement that is not visible on the ground. In mountainous terrain, not all areas provide strong, consistent reflection points. So to address this, advanced time series approaches combines both persistent and distributed scatterers together. And this fusion is a unique technology is what we bring to the table. This allows us is to extract reliable information even from natural surfaces like soil, vegetation, and slopes. So in simple terms, This means we're not limited to buildings, we can monitor natural terrain effectively as well. What makes this approach particularly powerful is it combines three things: continuous monitoring, very large area coverage, and detection of subtle millimeter level movements. This combination is especially unique, especially in the mountainous regions. So the next question is, once we detect movement, how do we interpret it and assess risk? Which brings me to the multi-criteria analysis. So once the deformation is detected, the key challenge in this case is interpreting what that movement actually means in terms of risk. Because not all movement leads to failure, right? So at the satellite level, we are working with time series INSAR data, which provides displacement measurements for thousands to millions of points across a slope with millimeter level precision over time. The first level of analysis is how the displacement is evolved over time, right? We look at patterns such as linear or slow creep movement, accelerating displacement, seasonal variations which are linked to rainfall, and sudden changes in velocity. So these patterns help distinguish stable slopes from those evolving towards failure. Next is the spatial context. We analyze how this movement is distributed spatially. Is it localized or is it spread across the slope? Is it aligned with the slope direction? Is it close to critical infrastructure like the road? This is what makes the intelligence more and more useful. The next step after this is multi-layer fusion. So say this deformation data is then combined with additional layers, such as terrain and slope characteristics, rainfall and hydrological conditions, soil and geological properties, and proximity infrastructure. So we're not just measuring movement, we are also placing it in physical and environmental context. The next step is the risk classification, as you can see on the screen. Based on this combined analysis, the slopes can be categorized into different risk levels, which makes it easy for an authority to take action. We classify it as low, moderate, high risk, etc. And the final output is not raw data, but a structured risk map or priority list, indicating where the attention is required. This converts large volumes of satellite data into actionable intelligence. So to close with, the multi-criteria analysis bridges the gap between measurement and decision making. And once the risk is understood, the next step is to see how it performs in real conditions. So we carried out a proof of concept in the Chardham highway in the Tapovan area across 100 kilometers. And in this proof of concept, we took about 4.5 to 5 years of data, and about 114 segments were checked. 14 high priority zones were actually marked over there. So this approach has been tested in the real world, and it turned out that some of our past observations actually predicted landslides which did occur, and we checked this with the reservoir repository, and we've identified further areas where landslides can also occur. So satellite monitoring was used to track the slope movement across the corridor, and areas where the gradual deformation were happening, as you can see on the screen, were identified. This demonstrates that this approach is not theoretical but actually worked in practice. So the objective is not to, and our objective of course is not to predict every event, like we cannot tell you of 14 high priority zones just like that, but to also improve the visibility and enable early action. For the current high priority zones which are there, if geotechnical investigations are carried out over there, I'm sure corrective measures can then be interpreted out loud. So based on this, we can look at how this approach actually creates value. So let's look at the pre-construction stage of a road, right? When you're planning a road, static surveys are carried out, and identifying unstable zones helps improve the alignment and slope design. So what we do is continuous monitoring and past historical monitoring, which helps we identify where the unstable zones are. And this means that the design itself can be carried out such that landslides are mitigated or the road damage is mitigated right from the beginning, and costly redesign is avoided. Next is during construction. The monitoring allows early detection of instability. So smaller interventions such as drainage corrections, for example, or strengthening of the slope or diversions can address the next issue instead of large corrective work later. Next is the post-construction. So in operations, early warning enables planned maintenance or predictive maintenance, and this reduces emergency repair. A moderate landslide can cost maybe 10-25 crores, but early intervention will cost you just lakhs and can significantly reduce this impact. Not all areas require attention. So instead of stationing your equipment over there and not knowing where to really station it, you can avoid these idle charges as well. And at the same time helps you control costs before damages occur, not after. Further, we can extend these capabilities, as you can see over here, to roads as well. We can monitor roads, bridges, and monitor minute deformations. And even if you place sensors over here, they don't always catch the deformations which are hidden. This can easily be caught with our landslide mitigation technology which we exist. We can carry out road subsidence, bridge approach movements, embankment stabilities. It enables continuous observation of infrastructure behavior. So as you can see here, this case over here, 8th November 2020 is when the maximum deformation 9 millimeters was carried out. And this deformation analysis started from 2015. So a 6-year period, by monitoring this bridge, we knew there's going to be a structural failure. And it actually turned out to be the case. This is in collaboration with an institute in UK. Lastly, ISRO, of course, is contributing greatly to this. ISRO has created various hazard maps, which has been incredibly useful for companies like us. So where ISRO says that where the landslides can happen, we will tell you the exact stretch. So we'll make ISRO's intelligence combined with our intelligence more actionable. ISRO carries out national, regional, district level repositories, whereas we do asset level, such as slope bridge, which makes it for MOTH more actionable. They do broad high-risk susceptibility zones, whereas we'll tell you precisely this 200-300 meter stretch needs action. And our studies are continuous and event-driven, right? So the action can be taken immediately, that to inspect or close the road or to stabilize, whatever it may be. And we are creating real-time alerts, dashboards, and link risks. So we are actually complementing the work which is done, of course, by ISRO. And lastly, one of the biggest advantages, and as I mentioned before, is scalability. It is not limited to a single corridor. Large regions across multiple states can be monitored simultaneously, and effort does not increase proportionately with scale. So this makes it suitable for a national level implementation. Thank you. So today's systems are largely reactive, but there's an opportunity to move towards a predictive approach where one action is taken before the failure actually occurs. So satellite-based monitoring enables this shift. And I'd love to entertain any questions, of course, in this forum, but otherwise, thank you very much. Thank you.
I request Shri Nirman Jambulkar to please join us on stage, EDP NHIDCL. Also, ladies and gentlemen, for any questions, you can also connect with our speakers offline during the high tea. We'll conclude the workshop with the high tea, so you can connect with our speakers if you have any questions. Sir, please take the center stage. Please give it up for Shri Bhavik Merchant. And now we begin the second last presentation of today's workshop on THDCIL experiences in landslide mitigation strategies and challenges faced during design and execution of landslide rockfall mitigation measures. To present this practical and experience-driven session, may I invite Shri Avkesh Kumar, Senior Manager, Design Civil, THDCIL.
So, very good afternoon to esteemed guests and ladies and gentlemen. I'm Avkesh Kumar. I'm Senior Manager in Design Department of THDC, posted in Rishikesh. So, since morning, we have gone through lots of content on the investigations and the design methodology and the construction methodology that has to be taken during execution of these landslide sites. So, keeping that in mind, so I'm going to cover the challenges faced during execution in perspective of THDC. So I will go through this with my presentation. Before that, just a small slide on about THDC. So basically, THDC is a profit-making public sector enterprise and was incorporated in year 1988 with the mandate to develop hydropower. So after having, developing these hydropower, it has diversified in various other sectors also, like the solar, wind, and the thermal projects. And by gaining experience in executing these projects, we have been into the providing consultancy services in high-end engineering services, which is one of the this landslide area is also there. So this was the small introduction about the organization. So going ahead, this is going to be the content of my presentation. So we'll be going through some brief status on the DPRs with THDC that we are doing on landslide treatments. And then was investigation and design philosophy has already been covered by different eminent speakers. So we'll not go much into this, but we'll just touch upon what we are going to do, what we are doing for preparation of DPRs. And then we'll show some challenges that we have encountered during execution of these landslide sites. And we'll go through a case study, but we have, strategy that we have gone through while mitigating the challenges that we have encountered. And then some, what lesson that we have learned while executing those landslide so that can be taken as a pilot project for, taking decision making of other the landslide treatment sites. And there will be some pre and post photographs that of the landslide that we have gone through. So as a presence, we are in almost all hill state of the country except South India. We are in almost all hill states of the country and working for most of the Ministry of Road Transport Highway departments and its allies like the NHID, CLNHI, State PWD. And we are also working with the shrine boards of Sri Mata Vaishno Devi Ji and the Amarnath Ji Shrine Board. And up till now, we have been simultaneously working for more than 1,000 number of landslide sites, and out of those, more than 650 number of DPRs have been submitted. And out of those, about 320 number are in construction, which were sanctioned by the different departments. So as an investigation, we are following a 5-step process, starting from the reconnaissance survey and doing the topographical mapping with the drone or total stations, and doing the the subsurface investigations by going with the geophysical or the geotechnical investigation methods, and do the depth study by designing all those, correlating the investigations and the whatever design methodology is there. So this is already have been covered when this is to be done and why this is to be done. Normally we are going with this kind of investigation when the RMR values of any particular storage is below 40. So here in this case, like geophysical investigation that we have been conducted, when we are going to have, to know the stratigraphy of the area, we recommend for SRT or MSW. And when we have to identify the, the cavities or the water pockets within the landslide, we are going for the ERT and this kind of investigations. So this is the particular just a site example where we have done the ERT and SRT investigations in Korab landslide site in Uttarakhand. So this is the stratification that we have that has been discovered. Like from some depth to some depth, like in about 14 or 15 meter, there was a overburden of top layer, and then it was occupied with the less weathered rock mass, and then the competent rock was encountered after 30 to 35 meter of depth. So back analysis also we are this is one of the method to decipher the soil parameters of the slope forming material. This is necessary so that we can perform our global stability analysis after applying measures or do the slope analysis for its failure. So after having all the investigations there and depending on the the circulated that matrix and available literatures, we go for the different kind of stability measures depending on the site conditions. And once all investigations and the methodology and the arrangements have been applied, we also perform the global stability checks for determining the factor of safety in dry and the critical conditions. Like in this case, it is shown in dry condition, the factor of safety have been determined. So this is the final product as a construction drawing or tender drawings. This is prepared for the execution at the site. So as a executor or as a technical monitoring agency, some anomalies that we have encountered during execution by the EPC contractor, like after preparing the design and submitting the repairs to the agency, there are cases that the approval of these repairs just gone much more 2-3 months post submission of the DPR. And there is time lag of more than 1 year or say 2-3 monsoon season. This causing a significant change in the topographical of the landslide. And this has caused many cases, like there is cases of COS, change of scope, and there the decision that whether the contractor has to be paid for that excess or extra the material that he is going to apply on this site is creating cases in department that whether it has to be verified or not. And in case the contractor has moved onto the site and while executing the site, suppose he has to construct the gravity wall or something along the toe, and he has excavated that area or that length for construction of the gravity wall, and in case there is rain or the monsoon season, the entire hill or the area that get collapsed. So these are the problems that we have been encountering during execution. And then one of the cases like hydrological score, that is like the failure of the the river retaining works when there is water level change or there is some flash floods due to flood conditions in the region. Thank you. So this is a typical case at one of the channels along Rishikesh Agra Khal. You can see here the time when the DPR was submitted. The area was, can I have this? The area was yes. So when the DPR was submitted, the problematic area was this one, and when before the submission, before this tendering process, the area has further expanded in the upward direction, and when the contractor has moved at site for the execution of the stability measures, you could see the area has further expanded towards the upper. It has receded towards upside, and the contractor has, because this has changed during the time the contractor has moved as site, so he has to cover this area also. But the problem is whether the contractor has to be paid for this additional area or not, because it is suggested that when the contractor is submitting its bid, he has to be bid as per the current site condition. So, but here in this case, the area has expanded when the contractor has moved at the site. So, in this case, the the area that has been aggravated further was to be taken care by in additional as a COS. So, like here in this case, like this is one of the site at Swala. You could see here the red line shows the case when the DPR was submitted, and the green line showing that when the bid date was started. During the bid date, you could see the area has expanded up to, towards the hillside, and when the contractor or the contract was awarded to the EPC contractor, the blue line showing the area has further aggravated towards hillside. And when the contractor has started working at site, because of some monsoon or rain season, the area has further aggravated to the hillside. So this entire topographical structure or map has changed during the execution time. So this is another example. This is the case along the side channel 35900 along the Gutkashi road. So there was the problem that along this river there was some river retaining works that was existing, and some works were that was happening along the road on the upper hillside. So when flash floods occurred during in November 24, the river retaining walls that was along the river has washed up, and because of this, there was sliding or dislodgement from the hillside along this river. There was bank erosion along this side. So, just going through a case where where we have taken the measures for restoring such kind of issues. Like this is a case of channels 106.350 to 106.45 at the Swala, which the Honorable Minister was talking in the morning. And you could see here the DPR was submitted in the May year 2022, and the work was awarded in year June 23 after passing of 2 monsoon season. So, so what happens here? The construction drawings that the contractor has submitted was for the stabilization of the expanded area, but he has asked for this serious proposal. But yes. So during the DPR time, the area that has been covered was this much, the orange one. And when the contractor has moved at the side, the area was expanded, the red line which is shown here. So this is the situation. This was the situation. The red line when the DPR was submitted, and the green line when the the slide line that has expanded in December 2022, and the blue line is the date of appointment of the contractor. And as per the CVS proposal, the contractor has claimed this is the blue line, the contractor for which has claimed for the compensation. So for this, the department has taken necessary action for whether it has to be covered into the CVS proposal or not. So contractor has submitted drawings, although he has also submitted a different proposal for bypassing this landslide through a viaduct. So however, the proposal of the contractor was not turned up, because this decision whatever was pending at the department was not taken. And in some after 1 year or something, there was heavy rainfall in the area, and because of that, some erosion towards the valley side that was happened. And this because of this, there was another meeting happened with the executing department and the agencies, that whether they have to take that valley side or not. So the decision was taken, like they have to prepare the different DPR for the valley side, and they have to submit a different proposal as per that time of site condition for the hillside. So accordingly, the contractor has submitted a proposal for stabilizing the hillside, and the DPO was prepared by TSDC for the valley side. After having investigations like the topographical mapping and the geophysical or geotechnical investigation. So this was the final drawing for the valley side that was submitted by TSDC. And during execution of the hillside as per EPC contractor's design and drawing, the EPC contractor was executing the site, and the contractor has created several benches. You could see here. These benches were created on the loose mass. So when the rain took place in September 2025, and this whole bench collapsed, and some of the tow structures that was along this road, that was also damaged. So this was also a serious issue, whether the design was failed or the contractor has not done the work properly. So this was also technically monitored by TSDC, and a report was submitted that the submitted whatever benches were created was on the loose mass. Then another meeting was happened with the executing department and the EPC contractor, and the EPC contractor has submitted a different proposal for for securing the area, but it has, because the area was expanded up hillside, he has submitted a different design drawing just covering the most critical portion, like the bottom, some 40 to 50 meter height of the slope. So this was the design concept that the EPC contractor has submitted, and this was technically approved by TSDC and the department. So currently the work is going on, and the road has been restored from valley side and the hillside. The road is now through. So now the execution vulnerabilities that we have encountered during these execution. So like we have seen that there are substandard quality of the material that is reaching at site. How it is happening? It is because the contractor is what is he doing? He is doing, like, suppose there is a quantity of 1000 or 1500 square meter of HT mesh or something. The contractor is taking MTC or the good quality material of some smaller quantity like 200 or something, and purchasing or procuring the remaining portion of the material from the local vendors. So whenever it is asked that they submit the MTC certificate, he used to submit the good one, the quality means the material, and applying those local material at site. And somewhere there are improper construction practices, like when we ask for the scaling of the slope, the contractor is not doing proper scaling. He is installing the anchors first, and then whenever there is a dislodgement or something, he is going to do the scaling of that slope. And also the EPC contract is not applying somewhere that, like, the boundary rope or the cast drains that is provisioned towards the crown portion. So these are some anomalies, and of course the time lag and the change in traffic is one of the key challenges that we are facing during execution. This is a case where shortcutting was done, but we have been recommending that there should be gap between two patches, like he has to go 8 to 10 meter. Then they have to leave a patch of 5 to 10 inches of gap for installation of drainage or weep holes, so that whatever seeping water is there, that comes out through these drainage holes. So the contractor is not executing this kind of measures. So these are some execution means the checks and balances that has to be done by the executing department through PDI, or the APC contractor has to submit the MTC certificate to the executing department. So these are the different checks that has to be done. Like we also have found that the anchors that we have recommending, like the SDR, in case of SDR, if it is 38 by 19, the contractor is using 38 by 22, because it is of the diameter is increasing, the strength will reduce. So these kind of things we have been seeing at site. And also we have been gathering that the grouting is not done properly. Like the grouting should be at a 1 to 3 kg of pressure. It has to be at the collar level, collar of this anchor, not at the machine level. What contractor is doing, he is applying this pressure from the machine of 1 to 3 kg square centimeter, not at the collar level. And somewhere we have been observing that the anchors that is protruding through the wall is uneven, like somewhere it is more than 0.3 or 0.5 meter, somewhere it is 1 meter. So it may cause some accidental damage, like along the road, if it is projecting more than 0.3 centimeter, it has to be curtailed. So these are some checks and balances that has been covered. Like we have been designing the stability measures for 25 years, and because the Gulfan coating, like 95% or 5% of zinc and aluminium coating, these are being manufactured overseas, and in India I think zinc coating is being manufactured. So these are other physical and mechanical properties that has to be tested by the executing department through third party, or the MTC certificate shall be submitted by the executing department. So these are some practices how the anchors to be installed, and the physical properties that can be checked at site, like inner and outer dia, and the base plate thickness that is mentioned in the specifications. And we also observing that during execution of the toe walls, like gravity or RCC walls, there is gap, or means consecutive lifts, like if it has constructed 1 meter or 2 meter of wall, it is being further implementing after 1 or 2 months. Like it has to be implemented once the concrete is green, or he has to be, means there some dowel bars or something has to be provided when the second lift is going to raise. So this is like a MTC certificate. So my submission is that the MTC certificate, whichever the party is supplying to the contractor, it should mention exact, means where for which road or which channels it is being supplied. So this should be, I think, mentioned. And then the following proactive measures that can be taken at site, like this should be taken like when we are preparing the bid documents. Like we can ask the EPC contractor to submit a site assessment report that could be inclusive of the bid submission document, so that the area whatever means changing between the DPR submission and the means the contractor is going to moving to site, that could be means accounted within that bid document. And the decision of whether COS is to be given or not given, this could be taken precisely. And if possible, the administrative delays, like the gap between the DPR submission and the bid preparation, this, if possible, this could be reduced by 2 or 3 months or something, so that the area can be minimized. And then the stringent material traceability. The supplier, we wish if supplier can collaborate with the supplier material, if his contract could collaborate with the supplier material during the putting the bid or bidding time, he should be collaborate with the he should disclose these material supplier within the bidding document. And for the executing department, there should be a rigorous PDI means previous discipline inspection, where the material shall be tested at their facilities. And then coming to the strategy recommendation on the bid rationalization, nowadays we have been seeing that there is, unorthodoxically there is lower bidding, there is discounting of more than 40 or 50%. So following mechanisms have been developed by the NHI Shimla recently, where we have seen this. So what we have done is they have introduced an additional performance security for abnormally low bids. Like if the bidder is bidding up to 15% of tender discount, there will not be any additional performance security. However, if it is going more than 15 to 20, there will be some additional performance security. Like here in this case, you could see into the table here. So if the bid discount is 20%, and suppose a project cost is of 10 crores, then the total bid price will be of 8 crores. And for this, the additional performance security will be like the 50% of the 85%, because 15% there is no additional security. 85% minus the bid price. So this is coming about 25 lakhs. This is the additional performance security the bidder has to submit. Then the total performance security would be like 49 crores, because 3% is the performance security for the bidding price. So and in case there is the bidding the tender discount is of 25%, and then the case would be there will be again the similar case, 50% of the 85 minus the bidding price, and the total additional performance security will be 50 lakhs, and the total performance security would be 72.5 lakhs. So in case it is going more than 30% or 40%, this is increasing in exponentially, like it is getting in crores. Like for a 7 crore bid, he has to submit a performance security of 1.2 crore or 2.18 crore. So that was something I wanted to share with you, because that may be helpful for you while making decision at your respective departments. So that was all from this. There are some pre and post photographs that we have executed at some of our sites. Like here, this is the Joshimat and Mana Govind Ghat site. We have done different kind of stability measures, as you could see. And like pre and post, it is side by side. You could see different kind of stability measures that have been designed and executed. This is RS wall at one of the site in Chamba Dharasu Road. The claddings at this is along the Tota Ghat in Kordiala Devprayag region, and some some aesthetic kind of measures along some stretch in Chamba and Dharasu. And then some this benching and terracing was done in Chamba, Dharasu, and some 88 channels. So that is all. Thank you.
I request Shri Raj Kishore to please join us on stage, RO Dehradun NHIDCL. So please take the center stage. ये ले जाओ. Thank you very much. Ladies and gentlemen, we now move to the final technical presentation of the day on smart monitoring of slopes and infrastructure using satellite and ground-based monitoring. To deliver this important session, may I invite Shri Siddesh Mahadik and Shri Gaurango Singha from Messrs. Inertia and Messrs. TechFab. Sir.
Good evening to all of you. I'd like to thank the ministry for this opportunity. Myself, Gaurango Singha, I am the founder of a company called Inertia Monitoring Systems. The company is based out of Barcelona. And I'm also the head of Geohazard Division at TechFab. So my presentation is about a technique called INSAR. I think my previous two speakers has already spoken about INSAR, but I'll add some more information to that. So I've been working in this technology for past 5 years. Prior to that, I was working as a LiDAR engineer. I have worked in LiDAR system for almost nearly 10 years from 2002. And I have worked more than 100 LiDAR projects worldwide. So this company, Inertia, is based out of Barcelona. I'm one of the founders. And we have our offices in Mexico, Lima, Peru. And our Indian office is based out of Gurgaon. We have a team of geotechnical engineers, geologists, and GIS analysts. So we know when there is a movement at the ground, what kind of movement it is, and we analyze the movement from a geotechnical perspective. So our specialization is basically we work on satellite interferometry. And currently we are monitoring more than 2,500 kilometers of roads in Mexico, where we are monitoring the RS wall, bridges, viaducts. As you know, the entire Mexico City is sinking. So to cover such large areas, you need something which is satellite-based. So we are monitoring a lot of sites there in Mexico. We are also monitoring 30 plus mines worldwide, and we are working with some of the companies in India. We have worked with NHI. We are working with NTPC. We are working with Coal India, and we are working on real-time INSAR projects. So as the previous speakers told you about INSAR, INSAR is Interferometric Synthetic Aperture Radar. So basically the radar satellites, these are low orbit satellites. So the radar satellites are from 350 to 450 kilometers from the Earth's surface, and they're continuously orbiting the Earth and taking images. So it basically compares two images of the Earth, and then it compares how the ground is moving. So these are images, these are images, but these are not optical images, these are radar images. So it's sending a signal to the Earth, and the signal is basically sensing back. And then it calculates the times. So from the difference of the time, it calculates how much movement has taken at the ground. So the resolution of INSAR data is about 3 meter by 3 meter. That's the highest resolution you can get. The best part of INSAR is INSAR has archival data of last 15 years from Sentinel-1. So if you are planning a highway somewhere and you want to check whether the highway is going to be stable or not from the past analysis, you can do that through INSAR. We have developed a web-based 3D viewer also. This can be accessed from anywhere in the Earth, and you can check how much movement is taking place in the real time. And it generates a time series analysis map. So you can see this is the time series analysis map. So from month-wise, you can select any point on the Earth. It will give you the XYZ coordinates of the movement. So these are the satellites, radar satellite from where we are taking the data. But I can tell you, with INSAR, there are some limitations also. Till 6 months back, it was not able to pick up data from very heavily vegetated area like northeastern part. INSAR is not successful. But 6 months back, when ISRO collaborated with NASA, they launched a satellite called NISAR. NASA ISRO collaboration satellite. So it's called NISAR. So NISAR is a satellite which changed the whole game basically. So NISAR has a L-band and a S-band data also. So with S-band data, it can penetrate the vegetation also. So we can get the ground information also. So with NISAR, we can do that. So Sentinel-1 has the archival data for past 10 years and it's free of cost. But the data is free of cost, but the analysis takes a lot of time. And the analysis has to be done from professional software like Gamma. There are freeware software also like Snap. But when you use a professional software like Gamma, the resolutions are much better. So there are other satellites also like TerraSat X, Cosmos SkyMed, NISAR L-band, S-band. So how a radar sensor is different from optical sensor? Optical sensor are basically images. So it cannot take images during the night. So satellite images cannot be taken during the night. It can have cloud covers. This is the biggest problem in the northeastern part of India. If you want to take a good satellite image, you have to wait a week or 10 days or 12 days to get a good picture. Whereas the radar signal, it can penetrate the Earth's atmosphere. It can take data any time of the day. And it does not require any illumination or any onboard power. It has an onboard power of itself. So how INSAR can be applied for your use cases? For DPR preparation, let's say if you are preparing a DPR or a tunnel in a mountainous area and you want to check whether that area is stable or not. So you can do a time series analysis for past 10 years from Sentinel-1 and you can process the data with certain accuracies and then you can check whether it is going to be viable or not. And you can prepare different alignment also. You can monitor RS-wall because we have seen a lot of failures of RS-wall and we are monitoring at least 6 RS-wall at the moment. You can monitor those RS-wall if there are any vertical settlements, horizontal settlements, you can do that also. You can do landslide monitoring of hill roads. We have done it for NHAI under Amrinder sir. And we recently saw another application where you can identify ghost structures through satellite images. As soon as a road alignment is announced, especially in Northeast, a lot of people start creating overnight structures. So that can be checked with satellite images, past satellite images. There is no other tool to go back in the data. So that is another application. So this is the tool which we have developed. This is the 3D data of Udhampur, Banihal, Ramban package. We did it for NHAI under Amrinder sir when he was in NHAI. He initiated this project. So we were basically monitoring the highway every 15 days during the monsoon period and every 30 days during the lean period. So we used 2 combination of satellites. One was Sentinel-1, another one was TerraSat X. TerraSat X is the paid one and Sentinel-1 is free data. So we combined both of the data. So if you click on any, so basically it's a 3D map. So you have access to this map. You click on any particular point, it gives you the time series analysis date-wise, how much that point particularly has moved. I'll show you 2 examples from this project also. So it's creating millions and millions of points and you can click on any particular point. It will give you whether this is subsidence or the location is sinking or it's moving. So you have that data. So before starting the data, we did a historical analysis of past 2 years to identify the hotspot where there are problems. And then once we identify the hotspot, then we do detailed analysis of that particular area. This is a very famous cafeteria landslides, and I think this has been moving for past, I think, so many years. I'll show you this also. So this is a time series analysis of the cafeteria analysis. So on the left-hand side, you see different kind of images, different kind of color code. So 1 centimeter movement is shown in green, which is stable. 1 to 2 centimeter is yellow, 2 to 3 centimeter is orange. And we can create alerts basis on these threshold values. So we can create the threshold values on the basis of this. So this is one of the slide where we are showing that one of the landslide which was basically identified and alert was generated. This was a Pira tunnel which was constructed by Gammon Engineering, and we gave an alert on 17th June, and there was a landslide on 19 June. There was only 2 days. So what has happened here? There was an accumulation of displacement of 8.4 centimeter till 2023 March, and 5.9 centimeter movement recorded in 1 month itself. So when you see this kind of movement, you can calculate, and you can, there's a technique called inverse velocity, where you can calculate how much movement has taken place over a time, and then you can actually make some prediction. But of course, those are plus minus 5 days, 10 days, depending upon various factors. Similarly, there was another incident, landslide. We reported on 25th October, and there was a landslide on 30th October. So we could identify 2-3 events through this. There was a total displacement in this particular case was 2.8 centimeter. This is the cafeteria mode landslide. You can see this is the most active moving zone in that particular area. I think NHI was constructing a tunnel also. There was a movement of 11.7 centimeters since March 2023. Now, to better these predictions, we have also integrated the in-situ ground instrumentation. We have developed a system called ARDA, Augmented Reality Data Access. So it's a mobile app. It's a app on your mobile. You go to the ground. You point the mobile towards the slope, it will tell you how many instruments are located underground itself also, and where they are located. And you can locate those instruments on the ground, and also you can combine the INSAR data with the in-situ ground instrumentation. So what we can connect the prisms, we can connect extensometer, we can connect inclinometer, we can connect seismographs, we can connect piezometers, and also radar data, the ground-based radar data. And we do a analytic part, so it can give you analytic based predictions also. So this is ARDA. We can give a live demo if you want. We have developed a system called Argos. Argos is basically in the name of Greek god, which basically is a smart rockfall monitor. So many speakers has already spoken about this. So these are basically mounted on a rockfall barrier. If a rock is falling down the slope, if it is hitting the barrier, it gives you an alarm wherever you are sitting anywhere in the world. It gives you a text message or WhatsApp message that there is a rockfall event has taken place and how much kilojoule impact has taken place. And there is a software online also where basically you can go and check how many event has taken place in the past so many years, and you can basically track the kind of events, and then you can take a corrective action. With this, I'd like to thank everyone for giving me this opportunity. Thank you so much.
I request Shri Ankit Layol, GM NHIDCL, to please join us on stage for the presentation of a memento. Please give it up for our final speaker, ladies and gentlemen, Shri Gaurango Singh from Mrs. Inertia. Thank you very much. And I now invite on stage Shri Amrendra Kumar, Director Technical NHIDCL, to kindly deliver the vote of thanks.
Good evening to colleagues, seniors, esteemed experts from academia, industry, as well as contractor and designer. Ladies and gentlemen, as far as experience in hill roads concerned, we can rightly say that we are in experience-wise as well as learning-wise, we are in a very nascent stage when we compare to the normal road construction, where large achievement has been done, but success stories in hill roads are not much. And because of this only, this full day workshop on landslide mitigation measures for resilient hill roads is very beneficial for all the stakeholders. I firstly thank our Honorable Minister Sri Nitin Jairam Gadkari ji for encouraging us to hold this workshop. I thank also for sparing such a long time with us during this inaugural session, as well as he has participated in technical session also. I also take this opportunity to thank both guest of honor, our Honorable Minister of State, Sri Ajay Tamta ji, and Sri Harsh Malhotra ji, for sparing time from his busy schedule and giving encouragement to us. As we all know, our Secretary, Road Transport and Highway, V. Uma Shankar ji, is a tough taskmaster. He has finalized this overall framework for this workshop, and under the technical direction of Sri V.K. Rajawat, our DG, RD and SS, and Sudeep Chaudhary, ADG, has been assigned to implement this workshop. We are very fortunate from Team NHIDCL that we have been assigned this work. We are also beneficiary of this workshop largely because we mostly deal with hill roads only. Sri Pankaj Agrawal, Chief Engineer, SNR, and Sri Vidur Kant ji, Director New Technology, has overall coordinated this workshop. I greatly thank him for their contribution. I thank all the esteemed 11 speakers who have given these lectures, and we have listened full day during this workshop. These are senior persons from academia, experts from industry, and users and designers. I will not repeat names, but it is my heartfelt thank to all of them for sparing time for putting together such a beneficial presentation customized to this workshop. At last, I thank Team NHIDCL, both the technical officers as well as administration and general officials, who has taken day and night put together because it was executed in a very short period of 4 or 5 days only. Apart from this, I also thanks this team of this Bharat Mandapam, ITPO and ITC who has provided catering, the ladies who have coordinated the mic and other facilities here, and the presenter. And with all, I will not take much time. Thank you all for sparing such a time. And with this, I thank and conclude this. Thank you. And at last also there is a high tea also, so enjoy that, and after that use that time in interacting with experts also, and after that we'll part. Thank you. Officials of NHIDCL are requested to remain here. Sudeep Chaudhary ji से request करने की फोटो में आ NHI, DCL officials, all officials who has been given some task also, technical as well as general, all should come here.